Okay, go ahead. Three, two, one.
Fabio, are you set? Thank you. Fabio, also change your name on the screen, please. You can just put F if you like, but it's going to confuse people if there's 2 Michael Lanes on this. 3 Michael Lanes. Ben, James, are you set?
Yep, we're live too.
Terrific, thank you. And can somebody ping Michael Mealing?
He's on.
Okay, I don't see him as a panelist. Okay. All right. Let's get started. Thanks, everybody. I appreciate y'all being here today. We're going to jump into a pretty awesome event over the next 2 days. We have some terrific speakers, some interesting topics, and we're going to talk about, how the Moon Society is trying to lead some of the development of the moon. To start off with, we're going to speak to some of the leadership of the Moon Society. We'll bring on Michael Mealing, the president, James Burke, vice president, and Ben Smith, director and membership chair. Over the course of the next 2 days, we're going to explore a couple different aspects of the moon. Some of the hardware, a little bit of the business, some outreach components, and some national policy. Most of today is focused on a little bit of visionary stuff, some level setting about where we came from to give us a good understanding about where we're going. And then tomorrow, it's an awful lot about habitation and what it's going to take to actually spend time, extended time on the moon. So with that, I'm gonna start with Michael Mealing. Michael is a longtime friend going back nearly 20 years, so it's really great to be working with him on this project. He is one of the co-founders of Starbridge Capital, a venture capital company focused on commercializing space. He'll be followed by James Burke. James is the vice president of the Moon Society for, I think, the last 2 years. And he's really been focused on some of he and Ben and Michael have really been focused on some of the reinvigoration of the Moon Society. He's also a force to be reckoned with for the Mars Society as well. So he's wearing 2 hats pretty often. So that's really terrific. And then Ben is, you'll hear a lot from Ben tomorrow when he talks about his Lunar Homestead project. So Michael, take it away. Take it away. You got about 5 minutes.
Cool. Thank you, Michael. Yeah, welcome everybody to the second Lunar Development Conference. I still do remember the original Lunar Development Conferences back in the 2000s. And one of the things that I was going to note was that even from the conference from last year, the space industry and specifically plans for the moon, both within the United States and around the world, we have seen a tremendous amount of change going on in terms of infrastructure plans, detailed plans coming from not just from the US, but from other countries, some of them participating in NASA's Artemis program, some of them not. And the moon is starting to become, I wouldn't say crowded, but at least there's a line at the door. And so I'm looking forward for this conference. One of the things that I hope everyone gets out of this both the participants as well as the audience is a sense of possibility and change and capability that we're building right now, and but also a challenge. The challenge I sort of put out to everybody is a lot of the things that we are going to be talking about over the next 2 days um, deal with infrastructure, how you go to the moon, how do we live there, what are the opportunities that are there. But I think one of the challenges that we have over the next few years is building out the customers and the market base. And I'll get to this a little bit in a talk that I give tomorrow on what I call the Starship Singularity. And I think that one of the things that the society and everyone in the business of developing the moon, we should start thinking about how do we educate the world and everyone that the moon is a place that they can go. And we're not talking about something for their grandkids anymore. We're talking about the people that are listening and sitting in this conference today. There is a very good chance that they will be able to get to the moon in their lifetimes and be able to make money doing it and be able to be the beginnings of a sustainable lunar presence. And so I do want everybody, as they're listening to all the speakers these next 2 days, kind of keep that in mind. If you're talking to someone outside of the industry about what the moon means, we really do as an industry need to start talking about the moon as some place that someone can go and accomplish goals, what those goals are, and even using some of the resources on the moon for helping out the environment of the Earth, but also realizing larger goals. We are quickly building out the capability to do all of this, so now it's actually time to start selling it, to start finding the people that need what we're building, and actually go out and start getting them signed up as customers and start building actual applications. That was something that we've always talked about, but now we have the capability to do it. So it's time for the next phase. And I think this is going to have some impacts even on the Moon Society as we go forward, as we figure out the Moon Society's role in this, and expanding that a little bit. So yeah, stay tuned to some of my talks on that, and I welcome everybody to the conference, and I'll turn it over to James.
Thank you, Michael. Yeah, good morning and welcome everyone to the 2021 Lunar Development Conference at the Moon Society. We're a small team. We organize this conference now for the second year in a row. We're planning to do it long-term, this series, and we're just very proud to be here. A couple quick housekeeping items. If you do want to use social media to talk about our conference, we welcome that. Please use the hashtag LunarDevCon. And also we have a community that you can join, and that's where we do all of our work at the Moon Society, and it's in Slack, and we can use it as a chat room and a virtual hangout for the conference. You can network with other attendees there, and so you can visit us at bit.ly Moon Society Slack. But I'm really excited about our conference this year. We have a great lineup of speakers. Pete Worden, I'm really anxious and interested to hear what he has to say about the current picture. There's been a lot going on in space, as we all know. Some of us have been at this for a long time, and it seems like every year there's more happening. But in the past year, we've had a lot of lunar missions either planned or landed. We had the Chang'e rover this year, and a lot coming up. And we're still, the US is still marching towards landing astronauts back on the moon in 2024, although I think a lot of people would question whether they're going to hit that date. But nevertheless, we have a human mission planned, and we're hoping to fly the Artemis 1 mission later this year. So there's a lot going on in the moon, and this is a great time for people to join the Moon Society as we march toward settlement of the moon and our human future in space. I'm also going to bring on Ben Smith. Ben is a tireless volunteer for the Moon Society. He's our chair for membership, and he's also on our board of directors. Ben, go ahead. Do you have any opening comments?
No, not really. Looking forward to the conference, and I think we've got a good lineup, and it should be really interesting. Hope everyone enjoys it.
Yeah, so what are some of the speakers that you guys are interested in hearing? I mentioned Pete Worden. Now, another one I'm really interested in is we have a major from the Space Force that's going to speak at the conference.
I'm interested in most of them. I'm hoping a lot of them have stuff I haven't heard before.
Yeah, I think we're definitely going to hear a lot of that. What's also exciting is we have the moon-based design contest that we did this year, and the majority of the participants that submitted designs are going to present in a block tomorrow. So I'm really, we got some really high quality designs from that contest, and just amazing engineering work. And they also thought through the politics and the economics of their settlements. And so, I'm really proud that the Moon Society was able to put that together, that contest, and we got such a great turnout from the entrants.
Yeah, that worked out really good. That may be something we need to think about doing on an annual basis or some variation of it.
Yeah, absolutely. Go ahead, Michael.
In particular, I'm looking forward to the business discussion 11:30 this morning between Laura Forsick, Andy Aldrin, the finding out what their viewpoints are. I'm in the business. I run a venture capital firm in the space sector, and I see a lot of things going on, but the moon is not something that we're currently, investing in. But I'm always looking for that secret, not secret, but the killer app for getting people on the moon. And I still think it's human beings in large quantities. So I'm really interested in that one, as well as the one at 2:30 that I think you were discussing on the framework discussion with Pete and everyone else in that panel. That should be very interesting as well.
Yeah, that sounds interesting. I'm looking forward to tomorrow, where we're going to get more into the technical aspects of how we're actually going to do this, figuring out some of the hardware and some of the technology and just design ideas on how we're going to survive on the moon long term.
Yeah, and then we also have Leonard David, the legendary veteran space journalist. He's worked with National Geographic, wrote a book about the moon. So I'd love to hear what he has to say about where we are now as well. So I think Michael Lane, I think we're ready to turn it back to you to get the thing going.
Terrific. I just want to say to the three of y'all and everyone else, it's an honor to be here and to be a part of this. I'm somewhat new to the Moon Society, and just the last couple month and a half to help to coordinate this effort on your behalf has really been terrific and really eye-opening. So I've always been a moon nerd, but this is kind of a different angle on it for me. So I'm really enjoying this. So thank you, everyone. With that, I am gonna start some of the content of our meeting. And let me just jump over, do a screen share, and jump over to my slides. Give me 10 seconds here. Can everybody see the presentation node?
We see your main PowerPoint screen. Okay, now we see it. That's good.
Okay, great. Okay, terrific. Okay. So I've been involved with space research of one kind or another for 20 years. And it has been amazing, profound, the changes over the last 20 years. Talking about the moon was not cool 20 years ago. I mean, there was a little bit of interest from some administrations at some points, but there hasn't really been sustained interest in the moon for a long time. And that feels like we're at kind of a new tipping point for lunar development. And I'm very excited about that. By way of background, I think that if you look at the last 20 years and then look forward another 15 years, I think there's going to be a lot that changes. I think this is a kind of a pivotal time in human history that kind of feels like what I imagine the Renaissance might have been once upon a time, where people's perceptions of the world that they live in is either radically changing or has already radically changed. And my role in this has been to think about big ideas, big projects. I started out on the original NASA Institute for Advanced Concepts research team for the space elevator. And while that has changed a lot over that time, about 4 years ago, 5 years ago, I really switched gears to focus on a lunar elevator. So that's when I started paying more attention to the moon. Well, I'm going to talk about that a lot more tomorrow, but this is the starting point for me. It was about a year ago. The National Space Council came out with a really powerful document about where we are as the United States and where we could maybe be going as a nation. Now, I want to point out that this is not the Moon Society is not an American-centric organization. It welcomes folks from all over the world. Absolutely. And as you get to know me, I'm involved with the International Space University, so I'm definitely a globalist. But I think this document is super important, and I'm gonna put a link in the chat afterwards. It's worth reading. It's not very long, 23, 27 pages, something like that. But it lays the foundation for where the United States has decided to go. And it's important to note that while this was a document of the past administration, it has been so far accepted and continued by the current administration. So I have high hopes for it. I know that things change in DC frequently, but the National Space Council has been reinstated. Many of the directions that were established over the last 4 years and before that 8 years ago, many of those ideals that focus on commercialization have been maintained currently. And that's really good news, I think. So the document talks about 5 major elements: commercialization at LEO, returning to the moon to stay, extending humans to Mars, deep space science, and education and workforce. Those are the big themes of it. The ones we're going to really pay attention to are commercialization of LEO and returning to the moon to stay. These ideas, to me, seem pretty straightforward, almost self-evident. But to have them come out as national doctrine, and then the ripple effects that came from that, it's called the New Era document. The ripple effects that came out of that New Era document, we're still feeling. There was an event that was held about this time last year. Well, no, I guess it was in May last year, that a lot of very smart people got together and started thinking about the immediate future. And And I think, if I counted correctly, 8 different national policy documents were formed from that event. And this is one of them, or at least, language in this was one of them. Um, some of the other ripple effects pushed policy into the other places in the Department of Defense, Department of Energy, Department of Education, Department of Commerce. So these documents, when they're crafted, have ripple effects. They have powerful ripple effects, and it's really great to kind of see that happening. The guy on the left here is retired General Quast, 3-star General Quast from the Air Force. He was a strong advocate for the development of U.S. Space Force. And to not pull his quotes out of context, he's saying that the conversations we're having around space right now might truly be some of the most important conversations in our nation's history. And I pushed him on that. I asked him some questions about that. And what he's saying was, since the founding of this country, we had to make some really important decisions. But for most of the last nearly 250 years, things have kind of gone along in some sort of steady state. There's been innovation and there's change, of course, we all know that, but that the changes that we are about to face, the decisions that we're about to make, might influence the next 250 years of our nation's future. And I thought that was pretty interesting. He's an Air Force general with a focus on educating senior Air Force leaders. And so if he's talking about this interesting future, it does make me kind of pay attention. And so that was pretty powerful. And then this other guy on the right is not very well known. His name is Dr. Joel Mosier. He is the chief scientist of the U.S. Space Force. And it's his actual job to look into the future and decide, what are we looking at? Now, he's coming from a national security threat perspective. So, he definitely has a bias about, what are things that the United States needs to be concerned about. So, that's his professional bias and that's his job. So, I understand where he's coming from. But what he has been working towards over the last maybe 3 or 4 years, even prior to Space Force being officially stood up, was to understand what the next 60 years look like. Sorry, 2060, the next 40 years. That's when the document was written. It was 2020. What does the next 40 years in space look like to 2060? And working backwards from that, what does the next 15 years look like to 2035-ish? And no one has a crystal ball. So, that's very hard to do. And it's fascinating to me that the Air Force at the time, U.S. Space Command, that's transitioned to the U.S. Space Force, was looking at the moon, right? The Chinese National Space Program, CNSA, has always been a military program. The program that we usually enjoy in the United States is a civilian-run program of NASA, and then to a far lesser degree, DoD, Department of Defense involvement. Whereas in China, it's entirely the opposite. There's very limited civil space. There's becoming some commercial space. And so as China has had a space force effectively for a very long time, and as the United States and Japan and France have all developed their space forces really in the last 3 years or so, it is interesting that an aspect that we hardly ever think about, Department of Defense, thinking about the moon, that could have some really interesting, maybe unintended consequences. It might be great. I think the verdict is still out and will be for a long time. But I guess I'm pointing this out because there is a role of government, whether it's Department of Energy, whether it's Department of Education, and of course, NASA and DOD and those folks. There is a role of government that makes space possible. It's a catalyst. Sometimes it's called a lighthouse client that is pointing to safe paths, safe shipping lanes. Sometimes it's referred to as an anchor tenant. Certainly it is for the International Space Station. But there's other stuff happening. So the role of government, maybe I have a personal bias that maybe I don't want it to be quite as influential as it is, but it is one of the primary, if not the primary, drivers for the near future. And it's this constant cycle of current programs being replaced by potential programs. And there's always budgetary management. There's always question marks. It feels like the most important game in Washington, D.C. these days is the fight between current programs and potential programs. I tend to look at space from the perspective of kind of, one lens with four filters, right? If we're going to do space, whether it's lunar development, LEO development, whatever it might be, I look at it from the perspective of kind of four filters. Almost everybody, almost all the time, focuses on hardware. We're going to do it at this event. We've got basically the whole day tomorrow talking about habitation on the moon. Hardware is fun. It's fun to talk about. I'm a big nerd. I like space stations and I like rockets and I like environmental control and life support systems at the really kind of systems of systems level. Hardware is some of the stuff that inspires us, right? It's what we get great pictures of. I got to tell you, I've seen some of the imagery for habitation tomorrow, and it really is quite amazing and beautiful. But less focused on, but equally important are the other elements: business, outreach, and framework. How do we pay for it? On my last slide, I was talking about budgets at the DC level and other governments that have the same budgetary problems and questions. That's one way to pay for it, is government support. Another way to pay for it is private capital. And we're going to be talking about that quite a bit later today and a bit tomorrow. There's a flood of new money flowing into the system. And that's really exciting too. So that's something to kind of pay attention to. How do you pay for your hardware? How do you pay for the team that puts that together and maintains it and operates it? What are your operational and management processes? What's your strengths, weaknesses, opportunities, and threats, right? So that is all encompassed, and it's often ignored. Now, it's been getting a lot of attention maybe in the last 3 to 5 years, but I'm going to butcher this quote, but I think I think it came from Gene Cernan, although I'm not sure of that. But one of the lines of early NASA folklore was, uh, "With no bucks, you've got no Buck Rogers." And while I might have butchered that quote, the sentiment is really straightforward. If you can't pay for it, you don't get to build the rest of the stuff you want to build. So it's not as glamorous as maybe the rest of the hardware, but it's certainly a vital element. And then outreach, what I call storytelling. This event, what we're hosting right now, is a part of that outreach, right? It's outreach for the Moon Society, but it's also outreach writ large of the space community to the non-space community, or to the Moon Society, a segment of the space community. And outreach can happen in a lot of different ways. It's everything from these sort of conferences to STEM education in the 6th grade to global summits where heads of nations and heads of space agencies meet and plan for the future. And then finally, another section that's often overlooked and ignored is the legal policy and regulatory framework that makes all of this stuff possible. If governments are currently the primary drivers for space, the laws and policies and regulations of those governments certainly has influence and power over most of those decisions. Even eventually, when commercial drivers are the primary drivers in space, they still have to operate within the framework of regulations and policies. So, The Martian, with Mark Watney from the movie The Martian, was talking about space piracy, and I got a real chuckle out of that, because someday down the road, space piracy is going to be a thing, and I don't think it's a thing yet, but it will be a thing someday. And so that framework lays the foundation for that future, hopefully without pirates. I also break the actors in space into kind of 4 sections. I jokingly refer to it as AC/DC because I'm, 53-year-old rocker that liked AC/DC. Academic, civil, defense, and commercial. Those are the primary actors in this space. It started out as a primarily academic exercise, which is why I put it first. Eventually, civil got involved, defense and commercial. Commercial is definitely a late player to the sector. Yes, of course, Boeing and Lockheed Martin were deeply involved in the earliest days of the Apollo program, but their role in developing space has shifted pretty dramatically. So that's how I kind of frame the actors. And there are a lot of nonprofits. Obviously, the Moon Society is one of those nonprofits. I usually lump them in with the civil crowd. It's not a perfect fit, but it fits a little bit. So, given those actors, given that there's national policy for the United States that other nations are also enacting or similar rules, given the actors, given the lens to kind of look at the problems, this is where we're going. This is where I think we're going. There's kind of 6 big elements to it. We're really, really, really good at launch now. It's taken a long time. It's taken a really long time, but we've gotten very, very good at launch. On average, we're launching a rocket, like the world is launching a rocket to space about every 3 days. Somewhere in the world, somebody's firing off a rocket. I think that is astounding. I really do. Like, just kind of let that sink in for a second. We're launching a rocket about every 3 days somewhere in the world. And not everybody's going to get the attention that SpaceX craves. and they've got a media machine that is highly tuned to their audience. But there's a whole lot of other rocketry happening beyond SpaceX. And if you can do launch really well in almost a routine manner, then communications and observation become an immediate effect of being able to launch regularly and consistently. And so we have seen, when I started 40 years ago, there were less than 400 active satellites. Last quarter, the first quarter of 2021, we launched over 700 satellites. Now, most of them were small. When I started, most satellites were big like a desk, big like a van, a minivan. Now, they're the size of a thermos sometimes, right? So, the form factors have changed, but I think we've got a really good handle on launch, communications, and observation. Like, we know how to do that really well. We went from an environment of 400 active satellites to 4,000 active satellites now, and we have a near future target of north of 40,000 satellites. The Satellite Industry Association predicts that 90 to 110,000 satellites will be constructed in the next 10 years. A lot of them are going to replace current constellations, and some of them will never be constructed. So Dr. Brian Whedon last month told me that he was anticipating 40,000 active satellites. So I think checkbox, we got that. So then once you've got a lot of launch and comms and observation satellites, then you're going to start doing something that's somewhat new. The idea of space tugs has been around for a really long time, but it's only been lately in the last year or so that you could really act on that vision. There are, I believe, 4 space transport companies out there now, and there are many more on their way. Why are there so many? Because there's over 150 known tracked launch companies. So those launch companies are going to send a lot of satellites up. Not all those satellites are going to get where they want to go because of the rideshare component of their launch vehicle. So they will use in-space transportation to get somewhere else from where they started to where they want to be in orbit. And whether that's LEO or GEO, or even to the cislunar environment of the Lagrange points, or even all the way to the moon. So that's coming. It's like near term. There's some of it happening already. There's more of it on its way. I'm a big proponent of the lunar elevator infrastructure. So we're going to talk about that a lot tomorrow. So I'm going to skip over it a little bit now. I will tell you that I think it's a vital element of in-space cislunar infrastructure. So I'm excited about that. There are going to be a lot of space stations constructed. A month ago, there were only 6 astronauts orbiting the world. And 2 weeks ago, we had some more flights from Chinese taikonauts. And now we've gone from 6 to 9. That's probably our current limit. It's probably not our maximum threshold right now, but that's our current limit. But I don't think it's very far away till we double to having 18, semi-permanent astronaut slots on orbit. I don't think that's very far away. There are other nations considering partnering with China and the International Space Station on their various assets. And there's a lot of talk about commercial space stations being constructed. Axiom is by far the farthest along, but by no means they are not the full story. I still have some hope for the now closed Bigelow Aerospace. I hope that they closed only because of COVID last year, and I hope that they restart. They have some pretty powerful technology behind them. But I think we're going to see an awful lot of space stations constructed soon. Once you've got that infrastructure, then you can start talking about mining and manufacturing, orbital manufacturing, and harvesting resources from both the moon and eventually asteroids. And that is further down the road, but kind of an inevitable consequence of developing the moon and developing space stations to their full potential. And ultimately, if you can do all of those things and you do them well, because all of this takes mastery. There's no amateurs up in space. If you can do all of those things well, I believe you're going to start harvesting resources from the moon to build enormous solar panels that are then brought back to geo orbit and power the top 300 cities of the world. If you can power the top 300 cities of the world, then you can power, with clean, green, limitless energy, you can power 40% of the global population. And I think that is worth striving for. So I think this is how our next 15 years are going to unfold. It's going to be clunky. It's going to be hard. There are going to be missteps, but I think that's where we're going. And with that, I am out of time. I'm going to swap over. Oh, wait, am I out of time? Yeah, I'm out of time. I'm going to swap over, and we're going to bring James Veda on in just a moment. Let me end with this. Sorry, I'm having technical difficulties on my screen sharing. All right, there we go. Sorry about that. I'd be happy to answer any questions in the chat. And is James on screen?
I'm here, Michael.
Oh, terrific. Thank you. Okay. I didn't see you for a second.
I think my name comes up as Angie Buckley because I'm using her sign-on.
Correct. I'm actually a little confused about some of the names. There's an awful lot of Michael Lanes on this screen. I'm not really sure why that is. I think perhaps they are using the link that I sent, but I don't know. It's quite interesting. But yeah, thank you, James, for changing your name on the screen. All right, I am going to bring you on. Let me just pull up your bio here. James Veda has worked at the Aerospace Corporation Center for Space Policy and Strategy since 2004. Previously, he taught in the Department of Space Studies at the University of North Dakota. He has a PhD in political science and a master's degree in science and technology policy. He is also a mentor of one of my former interns, so I think that's pretty awesome. And he's retiring soon to go off and play music, so I think that's also pretty awesome. So, James, really great to have you here. I'm really looking forward to your presentation. I'm gonna jump into my files and pull up your PDF, and I'll post that to the chat in just a moment. Okay.
Okay. Well, thanks for inviting me, Michael. And as I mentioned before, I'm sitting in for Angie Buckley, who was originally scheduled to do this slot. I am her stunt double, so I will make remarks that may not necessarily be the same thing that Angie would have said or anyone else at Aerospace Corporation would have said. So these are my comments alone. And I'd like to key off a little bit of what Michael just said a few minutes ago. in that we have to look at all aspects of our space development, even though we like to talk about and look at pictures of our hardware that's developed along the way, and in fact even specific types of hardware that get most of the attention. I've always been a big proponent of developing a space infrastructure concept, particularly in cislunar space, because I remember back to a comment made by one of my favorite old space pioneers, Kraft Ericke, almost 40 years ago. He said that if God had intended for men to be a spacefaring species, he would have given us a moon. And in fact, we do have a moon. But I think I would reinterpret that in a way where you would say, if God had really, really, really intended us to be a spacefaring species, he would have given us a fully functional cislunar space infrastructure. But we don't have that. We have to build that ourselves. And as Michael mentioned a few minutes ago, we tend to dwell on the glamorous parts of it, the spacecraft and the rockets. They're very visually compelling. They are the things that we associate with space development. But I'd like to push for attention to the less glamorous things, because they're all quite important, but they tend to slip our attention. Even in infrastructure on the Earth, if we are talking about what it takes to make up a city, and most people in that city don't even think about infrastructure, and those who do probably associate it with stuff like the electric grid and roads. But how many people think of stuff like sewage? I mean, it's just certain parts get neglected. So we have to incorporate all of these infrastructure elements in our thinking right off the bat, and that means the on-orbit servicing and even things like space weather prediction. That has to happen in near real time as operations increase there. The generation and distribution of power, the extension of our ability to do space-based navigation in a way that encompasses all of cislunar space. All of this is a training ground for what's going to come later on as we move beyond the Earth-Moon system. We've got to learn it here, just like when you were a kid and you had to learn how to behave and maneuver in your own little neighborhood before you could venture out more widely. The same kind of thing is true today, because today we are infant spacefarers, and we still need to grow up. We haven't even hit our adolescence yet. So all of that has to be learned in this this area that we've called cislunar space, or the Earth-Moon system, before we venture beyond. So how are we going to do this now? In funding, that's the next aspect that Michael was talking about earlier. You might look at the fact that, okay, NASA is taking this seriously now, and their funding has been increased recently. In fact, in the FY22 President's budget proposal, NASA is going to get a raise, and it is set at about 24.7 billion. Sounds like some serious money flowing there, and that's a good thing. Now, if you look at the segment of that that's devoted to the Artemis program, that's about 6.9 billion. So in other words, about 28% of NASA's budget devoted to Artemis. So what happens if we are seriously trying to set up a cislunar infrastructure that includes all the components that we need, and not just for a one-off use, but actually for ongoing use, for multi-purpose use, for use by all of the participants in that development process? Well, if you compare it to the development and maintenance of infrastructure on Earth, you find out it's very expensive. So what money do we have available to us from civil space activities? If you add up all of the civil space budgets from countries around the world that have such budgets, you are in a ballpark of something like $50 to $60 billion a year. So NASA is the biggest piece of that. So let's be generous and call it at $60 billion a year. And if you just assume that 30% of each of those budgets is going to be devoted to developing that cislunar infrastructure, that gives you around $18 billion a year. Sounds like a lot of money, but really it's not enough. It's not enough to establish, develop and establish the new hardware, and then to continue to operate it continuously as a sustainable system. So there has to be more participation in the system by other sectors that include primarily industry, and not just industry traditionally associated with space program activities. So the industry obviously needs some type of incentive to be involved in a way that's going to allow them to make money. If we look at projects, very large projects that industry has done, and often has done collaboratively across multiple companies, you see that there's been some pretty big things. The Trans-Alaska Pipeline, for example, which was built in the mid 1970s for a cost of about $8 billion. And a little bit later than that, in the early 90s, the English Channel Tunnel, that was also a completely privately funded activity. And that took 6 years to build, and at a cost of $13.5 billion. And both of those projects, if you adjust for inflation up through today, each of those projects would be in the neighborhood of $30 billion. So these were successfully executed by private companies working as teams. So can we see something like that being done in space? Well, yeah, if the proper incentives are in place, because there's companies that have a lot available to invest. If you look at the top companies in the Fortune 500, it's an interesting list when you trace over a number of years those top 10 companies. So if you go back a decade or so, the top 10 was dominated by oil companies. If you look at the latest list of Fortune 500 top 10, there's only one oil company in the top 10, and it's Exxon at number 10. Exxon used to be always on top. Now that's shifting around, and it's large retail companies and information technology companies that are dominating that top 10. And in fact, you see companies like the number one now is Walmart, with a last year having a profit of $13.5 billion. That's not revenue, that's the profit. Okay. Amazon is number two. Their profit last year was $21.3 billion. Apple is number three, and they were at $57.4 billion. Now they had a greater profit. They rank these by revenue, but I'm giving you figures for how much profit they had. Okay, so Apple's profit, in other words, for 1 year, was more than enough to pay for 2 years of NASA's entire budget. Okay, and if you also look at, we all know that Apple has a big bank account. It's estimated that they have cash in the bank equivalent to around $200 billion. Now, if you've got a piggy bank of $200 billion, you may think, wow, they can do almost anything they want without borrowing any money. But the truth of the matter is that they were, in this past year or so, borrowing at record rates for the company. And this seems to be counterintuitive. Because if they've got $200 billion in the bank, why do they need to go out and borrow money and at a rate greater than in the company's past history? Well, the reason is that interest rates were low and they're planning ahead. They wanted to get those interest rates locked in so that they could have that capital available to them. And that's an interesting way of operating that you really can't do with government agencies because of the laws and the procedures that they have to follow. They can't plan that way. They can't have a piggy bank of billions of or tens of billions or hundreds of billions of dollars. They can't go out and borrow money that they don't actually need right now just because interest rates are low. But private sector can do that. So they have avenues of generating the capital needed for these huge projects that are not available to the government agencies that we usually think about for space development. So that's one of the reasons why the private sector needs to be brought into this activity, and not just as a contractor, but as entities with skin in the game. So, so that means that the incentives to convince them to join into something that will eventually be profitable need to be front and center to get them on board. They have expertise, they have lots of well-trained people, and they have the money. So that's how we're going to succeed in the long run. And before I run out of time, I wanted to talk about one aspect of how we think about the metrics for success in doing this. You've heard over the past few years that Jeff Bezos is fond of saying we've got to work towards having 1 million people living and working in space. Okay, now he's not the first to say that, but he's been a prominent voice saying that over recent years. And hey, I really like Jeff Bezos. I shop all the time at his online store, and in fact, I've even shopped at his brick and mortar supermarket that he has now. So great. That's fine. But I think his metric is wrong, because we should be doing as much as we possibly can with automation, because that is going to ultimately drive us faster and be more affordable, because we all know how much extra cost is added to space projects when you have people that are involved that have to be sustained in these very hostile environments. So yes, people will be involved, but if you can have one person managing 100 robots doing the work on the lunar surface, for example, I think that's better than having 100 people doing that work. If we want to advance this, we don't want to have, as it's been called, a self-licking ice cream cone in which the whole purpose of the hardware, the facilities that we install out in space, is to sustain people, and then you've got nothing left to do other value generation. Our metric should be how much value are we generating by our activities there, whether we're talking about scientific value, economic, or other types of value. That's your metric. And the most that you can do with, the more you can do with automation, the better. So that is, I guess, the message takeaway here is that the maximum involvement of private sector, including non-aerospace companies, is going to be essential to this development. Allow them to use the types of value generating funding activities that they are accustomed to and that they are very good at, and then measure it with the right metrics. So I guess why don't I stop at that point and see if Michael, you want to have any further discussion or bring up some questions. Microphone.
God, a year and a half into this, and I'm still not hitting the mute button on time. Dr. Veda, thank you for that. I don't want to kind of beat a horse to death here, but you know, it does come down to budgets. Can you kind of put on your wave your magic wand, pull out your crystal ball, and kind of imagine, what do you think some budgets are going to look like going forward? Historically, lately, we've been at, half of 1% of the federal U.S. budget. Do you think anything's going to change there? Is that kind of consistent, do you think?
Well, that percentage of the budget thing, I don't see that changing at all in the near future. Instead, I think that we are going to find some shifts in what's going to be expected of NASA, and that can be characterized by their plans for after the International Space Station. NASA has already said, we're not going to build another one of these. We are going to rely on the private sector to provide us, at least in LEO, provide us with on-orbit habitation and laboratory facilities. And those operational things are going to be shifting more to the private sector because the capabilities have been increasing. Right. I mean, look, when NASA was started up, we were all at square one. We had no one who could go out there and say, yes, we know how to do space, and we know how to do it economically. We know how to do the science. We know how to do the commercial things. No, it was all working up from scratch, and who had the resources to do that type of thing? Well, governments had the resources and could marshal them to show results. But that was not intended to be the way it would be done forever. So, I mean, sometimes there were people in the business at NASA who kind of forgot that their job was to make space so easy that it could be handed off to others. So some things that we developed were handed off to operational entities. NASA and the Defense Department worked on communication satellites, and that got handed off to the private sector. They worked on weather satellites, and that got handed off to NOAA. So we are going to see, I believe, more situations in which things that are developed in NASA, supported by NASA, are going to graduate to a new life in other operational entities, and that NASA is going to be more of the innovator, the enabler, and not the operator, because they're going to get out of operating space stations. They're still, for a while, going to be into operating rockets with the SLS once that starts flying. But the indicators already are saying that this is probably going to be the last time that we're going to look to NASA to create new rockets and operate them.
That is a big shift, right? I mean, that's gonna cause some blood in the streets and at the congressional level.
Yeah, so we have we have that situation kind of hanging on where SLS is this government project and probably always will be, but the sophistication of what's going on in the private sector is going to make the next generation, including very large boosters, something that makes more sense being done outside of NASA.
Well, that's exactly the segue I was hoping for. So Michael Mealing and I have been referring to kind of the Starship singularity, that everything changes once you have that super mammoth launch capabilities. So am I implying correctly that you think that the era of NASA building another super mammoth launch capability like the SLS, those days are over? Is that what you're saying?
Well, I think they're going to continue on with the SLS program of record, but
Sure. Yep.
beyond
But
that,
there's no SLS 2.0.
right,
Right.
I don't think that they're going to go beyond that because look, we're already seeing at least a couple of companies in the U.S. that want to pick up the baton from them and take over for a large capacity launch. And this is a good thing. I mean, if NASA would reflect over its entire history, it should be celebrating that because, hey, look, we made this happen.
Right. They're
We
enabling.
should be proud of ourselves for
Yeah.
doing this.
Yeah.
So we've made space easy enough for others to take over. So that's what I think is going to be happening in this next generation. So that's going to have implications for NASA's budget. It's going to have implications for how the Congress sets up its oversight of the U.S. government space enterprise. So I suspect that there is going to be some substantial changes that we are probably going to be seeing within 10 years. I've talked to a lot of people about this who suspect things are going to stay pretty much as they are until 2040. I'm not so sure.
Okay.
There could be changes that remain very subtle for a long period of time, but there could be dramatic changes as well, driven by lots of different things, whether it's dollars or whether it's international competition, or whether it's the development of something in cislunar space that makes it worth investing substantially, like say some of the microgravity sciences that we'll be doing come up with something that affects industries, affects the medical profession in significant ways that encourage more activity to be done in space. Because we've only scratched the surface in that. I mean, there are people who were back in the 80s saying, "Oh, this whole microgravity thing, it did not live up to its promise." And wait a minute, we've hardly begun to investigate that. We have not spent the hours, days, years of research that you would do in a terrestrial lab for any other scientific activity. We haven't put in the time in space research yet. And when we do, we may find that something, whether it has to do with manufacturing or whether it has to do with the pharmaceuticals industry or whatever it might be, we could hit on something that makes it worthwhile to invest in space as costs come down and the value generation goes up.
So if we're watching a situation where budgets will remain largely flat, I'm going to just round it to $25 billion, but that the two largest expenses, the International Space Station and SLS, will eventually shrink. Do you have a guess where that? I'm going to guess that those freed up dollars are probably going to go to the moon. Do you think that's a safe guess?
Well, if NASA is going to continue to stand up and take responsibility for sustained activity on the moon, then I would say yes.
Okay.
That's something to be determined by future future administrations
Future
and
Congress.
Congresses,
Yeah.
if they are going to continue to have the major responsibility for making that happen. So yes, I think that's where it would go. But when you have an annual budget process, and some turnover in the Congress, it's really it's really impossible to predict how they're going to treat legacy programs, and it's just as likely that they could see that all of this freed up money goes somewhere outside of NASA to be used for other programs that could be terrestrial infrastructure, like we're talking about now in the Congress, and or it could be to beef up the social programs that are going to be necessary for our aging population. There's so many factors across society that could prevent the excess dollars, the peace dividend, whatever you want to call it, from staying within NASA.
Okay. I've got a question from Michael Mealing from the audience. Quote, for the commercial sector, especially the finance side, to be involved in a meaningful way, it needs to see some commercial markets beyond just government contracting. Given that the biz case for space resources for use on the Earth won't close until marginal costs are roughly equal, have you given any thought to what those markets might be? So kind of future lunar markets.
Yeah, I don't see the lunar resources being used on the Earth as anything that's coming along. Probably not in my lifetime. But the use of those lunar resources to teach us how we can live off the land in space. I mean, that's probably, if you want to come up with a catchphrase for something that is the most important thing that we do in the next generation of cislunar development, is learn how to live off the land in space. Because if everything, I think your audience knows this well, if everything is always dependent on supply lines from Earth, right down to the air and water we need to survive, then things are going to be not developing much beyond an Antarctic research station. If you really want things to develop fully, those resources are going to have to be processed in space and used to make structural parts for other construction, or even things like circuit boards that will be used for the electronics that are used in space. And as we construct new things like more innovative space platforms, solar power satellites, things like that in space, that's where the lunar resources side is going to contribute. But I think we should not yet write off that materials processing research, because it could show us some ways to manufacture things that can be done better in space, and that would have sufficient value when transported to the Earth to make it worthwhile. So we're still you're pretty low on that learning curve for those things. So let's set up, when we set up those facilities that NASA is counting on the private sector to do for research purposes, let's fund some of those projects to make the results that will generate value and encourage more participation, even from non-traditional businesses.
Terrific. Dr. Vado, really appreciate you being here. Thanks for filling in for Angie. She's irreplaceable, but you're an amazing replacement, so thank you. We're gonna shift gears here, and Fabio, if you could bring up the schedule screen for just a moment. We just kind of want to showcase this to everybody so they kind of know who's coming up when. Melissa, thank you for coming on screen here. Next up is Melissa Roth. Let me read her intro here. Melissa is the co-founder and lead researcher of Off Planet Research. Is a provider of lunar regolith simulants for testing and research purposes. This goes exactly to what Dr. Veda just said a moment ago. We need to figure out how to live off the land. Off-Planet Research is a private research company that strives to enable a meaningful, enduring human presence beyond Earth orbit by helping organizations learn how to work and live on the Moon, Mars, and other worlds safely and productively. They produce high-quality simulants, test materials that emulate the regoliths and ices of the Moon and other planetary bodies. They also design, adapt, and test components and processes for inclusion in future missions. These resources dramatically increase mission assurance, cost effectiveness, and speed of development of safe and effective space-based technologies. Melissa is a member of the LEAG Lunar something group. I don't remember what LEAG stands for. LEAG Commercial Advisory Board, and a leader for LSIC's Extreme Environment Regolith Survey Interface Group. Thanks, Melissa. Join us, please.
Of course, yeah, no, I also thought that that was a great transition there at the end. How wonderful. So let me go ahead and pull up my presentation real quick. Let me know when you can see the slide version. In the middle of the presentation, ooh, spoiler alert. Okay, let's start back over at the top. Okay, so can you see the slides now? Wonderful. Okay, well, thank you so much. My name is Melissa Roth, and I am one of the founders and lead researchers at Off Planet Research, located in Washington State. And I want to thank the Moon Society for having me today. It's exciting to be back. I will be speaking about the formation of lunar regolith, the challenges that it presents to human and robotic missions, and how lunar regolith and the resources within it can be leveraged to help sustain a long-term presence on the Moon and in deeper space. So a little bit about us. Off-Planet Research simulates extraterrestrial environments for testing spacecraft and landed technology with a current focus on the lunar environment. As engineers, we know how testing and good test materials are important to increase that mission assurance, cost effectiveness, and speed the development of space-based technologies. OPR was founded in 2015, and we spent several years developing our lunar regolith simulant production methods, make sure that we mimic the natural formation processes on the Moon, as most commercial crushing equipment tends to smooth the particles or contribute high levels of contamination. In addition to our lunar regolith simulants, we have also developed lunar icy regolith simulants that include the 9 L-cross components found in the L-cross plume. Additionally, we consult on working with lunar regolith and conducting component testing. The prevailing theory of the origin of our Moon centers around a giant impact that threw off material that eventually formed the Moon, with both planetary bodies now at a little bit of a tilt. Returned Apollo samples support this collision theory as well. When you look at the Moon, you can see the light and the dark patches. When Galileo looked at the Moon through a telescope in 1609, he thought that the dark patches looked like the smooth bodies of water, so he called them mare, an Italian word for ocean. When he studied the lighter portions of the Moon, they looked rugged like the mountains on Earth, so he called them the highlands. These are the names that we actually still use to this day. The soil in the darker colored mare is mostly composed of basalt, as seen in the photo here on the left of our mare simulant. Basalt is most commonly found all over Earth. However, some terrestrial basalts are better matched to lunar basalts than others. The simulant on the right is representative of the lighter highland areas, which are mostly made up of rocks called anorthosite. Aegean anorthosite is not very common on Earth and is more than 3.5 billion years old. When the Earth was cooling down from a ball of molten rock, this anorthosite was one of the first components that solidified and floated up to the surface. Now, when you were looking at that photo of the Moon, I imagine that the image on the left is the one that comes to mind for most of you. What many people do not realize is how different the far side of the moon looks. There are a very few Mare patches on the far side of the moon, and while the lunar highlands cover almost 80% of the lunar surface, most lunar missions have actually landed in the Mare regions. And due to challenges with the Earth and the far side, only one mission has landed there, which is Chang'e 4. To clarify some terminology, regolith is the term that we use to refer to the layer of consolidated rocky material covering bedrock and is used to describe the soil on the moon and other planetary bodies. Lunar regolith simulants are the materials made here on Earth to simulate or replicate the regolith found on the moon to be used in research and testing due to the scarcity and protection of returned lunar samples. The environment on the moon is one of the most challenging that humanity has ever encountered. In addition to the extreme temperatures of plus or minus 260 degrees Fahrenheit, one of the most difficult parts of this environment is the nature of the regolith on the moon. Earth's soil contains organic material, and the particles are formed by wind-blown and water processes, which makes them relatively round and smooth. The regolith on airless bodies, such as the moon, have no organics, are not altered by moisture, and are entirely formed by impact and explosive processes. This means that these particles are very hard and covered in fractured surfaces, with sharp edges as in that image in the middle. The regolith on the moon is very destructive and hazardous to both humans and technology. It is abrasive like sandpaper and also very susceptible to static charge due to its high surface area. Additionally, more than 60% of the regolith on the moon is composed of particles that are quite fine, like those in talcum powder or cake flour. Due to all of these factors, regolith particles easily get into the spacesuit joints or moving mechanisms of rovers and cause them to seize up. Considering how short their missions were, astronauts' gloves and suits suffered a lot of damage. The Earth is fortunate to be protected from most meteors by our atmosphere. Those that do get through radically change the landscape, like in that upper photo, which shows Meteor Crater in Arizona. The moon has no atmosphere, so even tiny micrometeorites hit the surface, making their own craters that behave just like their larger relatives. This is how rocks on the lunar surface get crushed into a very fine powder. Additionally, the energy of the impacts melts some of the surrounding regolith, which quickly cools and glues other regolith particles together, forming agglutinates, as you can see in that lower left photo. Due to the structure of agglutinates, they have a significant effect on the mechanical properties of lunar regolith. In this iconic photo of Buzz Aldrin on the left, you will note just how white his suit is, with the exception of a couple of dark spots on his knees from a fall. On the right, James Irwin's bottom half is absolutely coated in dark gray regolith. Not only is the regolith abrasive and destructive to the fabrics and joints, but the astronauts were susceptible to overheating as that pristine white design was meant to help reflect heat. And I do just want to note how difficult it is, or how dangerous it is for astronauts like Buzz to fall, and yet he was not the only one to do so. Given the nature of the regolith and rocks, falling into this sharp abrasive material could ruin the suit and put the mission and the astronaut's life at risk, especially if they are not near a lander or habitat. The ability of the astronauts to move freely and safely while wearing a suit cannot be overlooked. Fortunately, I know there are some new suit designs out there, and I look forward to seeing how they enable astronauts to get more mobility, but also how they hold up to that regolith. A new dust-generating system arrived on the moon, starting with Apollo 15 in the form of the Lunar Roving Vehicle. While the LRVs dramatically increased the distance traveled and mission capabilities, they also stirred up even more lunar dust to coat the LRV, the astronauts, and their instruments. In regards to cleaning the suits after each EVA, Gene Cernan said, "Probably the most difficult job of all the closeouts was trying to dust the suits." In the photo on the right, a very dirty Gene Cernan can be seen in the lunar module after taking off his suit. What I find fascinating about this photo is that Gene should have been protected from the regolith in his EVA suit. His skin was never exposed to regolith outside the lunar module. The suits being dirty makes sense, the astronauts inside them less so. And despite all that time spent cleaning, as we can see, the regolith that did enter the lunar module quickly dispersed around the cabin. Many astronauts developed lunar hay fever as a result of breathing in these fine abrasive particles. In fact, researchers are now studying how long-term exposure to lunar dust might affect the lungs of future astronauts. This table shows some of the statistics of the Apollo EVAs. The 6 missions over 3.5 years show a rapid advancement in the amount of time spent outside the lunar module, the total distance traveled, and the quantity of samples brought back. The addition of the lunar roving vehicle drastically increased the distance covered by Apollo astronauts, and thus the variety of samples brought back. That said, the longest the astronauts have spent on the lunar surface is less than 24 hours. So if the dust was so abrasive that it wore through 3 layers of the Kevlar-like material on Jack Schmidt's boots, how will our technology survive weeks to months on the lunar surface? If you're attending this conference, you know that many national space agencies and private organizations have visions for a long-term sustainable presence on the moon and in deeper space. With almost 50 years since the last human mission to the moon, how can we make these visions a reality? As I'm sure has already been discussed, NASA's solution is the Artemis program, a series of missions with the goal of landing the first woman and the next man on the moon by 2024. The first phase of this ambitious program begins with smaller landed missions, transitions to larger landers with deployable rovers, and is going to culminate in a crewed mission to the lunar South Pole in 2024. The second phase will build upon the first to increase mission capabilities for Mars. There are also many other missions planned through international collaboration and private industry, such as Chang'e 6, the Emirates lunar mission, and Luna 27, to name a few. While normally industry struggles with bridging the gap between technology and business, while still applicable for the space industry, the bigger struggle is about bridging the gap between technology designed for environments on Earth and technology and designed for the moon and other worlds, of which we often have incomplete or little knowledge. These unknowns are called strategic knowledge gaps, or SKGs. They are questions that researchers and industry experts try to answer or plan to answer through a mission. One such knowledge gap is dust mitigation. As I mentioned earlier, Apollo-era technology had many issues operating in dusty environments on the lunar surface, and they just kind of had to live with it. Well, for that vision of humans inhabiting the moon, you can't just live with the dust. We either need to prevent dust from collecting on surfaces in the first place, or we need to create new technology that is more durable for this harsh environment. So first, let's look at some Apollo-era dust mitigation strategies and see how they did. In addition to procedural mitigation techniques, cleaning processes, and strict planning to avoid hazards, astronauts use dust brushes, dust covers, and rover fenders to reduce or remove dust. Now, the problem with a brush is that it often creates static. As I mentioned earlier, with particles that are very fine and susceptible to static charge, these brushes were really only marginally effective. Additionally, what happens when a vital component breaks on the moon and the closest hardware store is 239,000 miles away? There were actually several instances of life and mission-threatening breaks during the Apollo missions, but one almost prevented the final 2 lunar roving EVAs of the Apollo era. At the end of the first Apollo 17 EVA, Gene Cernan's hammer caught on the edge of the fender and it popped off. Without that fender extension protecting them from the dust, driving the LRV was a serious hazard. Due to the 16G, any lofted dust goes much further than it would on Earth, and they described it as driving around with massive rooster tails behind them. This lofted dust spread all over instruments and suits, and since it's darker than the instruments or the astronauts' bright white suits, it absorbed heat from the sun and could overheat the instruments. So while the astronauts slept, the team in Houston had to create a replacement fender with only the materials the astronauts had on them on the moon. Their solution was to attach 4 of the 28 lunar maps with duct tape and 2 telescope alignment clamps, as seen in that middle photo. This amazing story illustrates the importance of thinking on your feet, adapting technology, and learning from experience how to mitigate dust. Without this fix, the only geologists to set foot on the moon might not have had the opportunity to discover the orange glassy regolith on the edge of Shorty Crater during that second EVA. With missions launching soon, both nationally and internationally, new dust mitigation techniques are needed. We need optical systems such as camera lenses, solar panels, and spacesuit visors. We need advanced fabrics for spacesuits, habitats, and covers. Thermal radiators and painted surfaces will help with heat reduction. Dust-tolerant mechanisms like linear actuators, bearings, rotary joints, hinges, and quick disconnects are all necessary for technology longevity. New steels and soft goods for spacesuit interfaces, hatches, connectors, and hoses are going to be very susceptible to abrasion. So going back to that vision of a lunar village, we've studied the environment, we've developed new dust mitigation techniques that work great, and we're launching missions on a regular basis. Wonderful. Well, now we need to address the business case that we set aside earlier. Science and research goals can only fund so many missions. Governments can only fund so many missions. It would be hard to make the case for a lunar or Martian village without being able to show the financials of why we need to go and not just why we want to go. This is where lunar resources come into play. We need to be able to show that the resources of the moon, Mars, and asteroids can literally propel ourselves deeper into space. This all starts with the idea of in situ resource utilization, or ISRU. ISRU being the idea of living off the land and utilizing the resources around you. There are so many resources that can be extracted from the regolith and used on the lunar surface. Lunar regolith is at least 40% oxygen by mass, and silicate minerals make up over 90% of the moon. There are a variety of metals and crete components, that's potassium, rare earth elements, and phosphorus in the regolith as well. Volatiles refers to the frozen components that have been discovered in lunar ice. In the 2009 LCROSS mission, NASA crashed a satellite into the South Pole and discovered water, carbon dioxide, ammonia, and methane, to name a few, in that ejected plume. LCROSS estimated 5.5 weight percent of water in addition to the other volatiles, while spectral modeling estimates up to 30 weight percent ice. With one data point of ground truth, there are a lot of unknowns for volatiles, but they have really revolutionized how lunar resources can be used. The oxygen and hydrogen can be used in rocket fuel, breathable air, drinking water, and in agriculture. The rare earth elements that are in their unrefined state on the moon can be exported back.
Did we lose Melissa? Oh, she's back now.
Okay.
She is.
Hey, Melissa, we lost you for a second. You're muted.
Can you hear me now?
We can. We don't know what happened.
Perfect. Was I talking about oxygen and hydrogen at the time?
You were, yeah.
Perfect. Let's go back in. Why don't we? Okay.
I know you tested this yesterday, but you were also frozen visually for a while.
Oh, okay. But you were able to hear most of the presentation?
Oh, yeah. We're good.
Okay. This one. There we go. I mean, look at all those visuals you guys missed. So let's make sure we see them. So I'll start back at the beginning of the slide. I apologize for any repeats.
No worries.
So that oxygen and hydrogen can be used in rocket fuel, breathable air, drinking water, and in agriculture. The rare earth elements that are in their unrefined state on the moon can be exported back to Earth to be used in many applications like electronics. Raw or processed lunar regolith can be used in sintering and 3D printing applications to make tools and construct buildings, protective thermal and impact shields, and roads. Earlier, I mentioned that there are a lot of unknowns about the volatiles found in the lunar polar regions. The largest supply of volatiles that is most easily accessible from the surface is expected to be in the permanently shadowed regions where the sunlight never hits. These regions at the North and South Pole are often in or at the edge of craters and are ultra cold at minus 260 degrees Fahrenheit, or even colder in certain craters. Early missions to the polar regions will send prospecting instruments and rovers like NASA's Viper rover to head into these extreme access environments to categorize and map the distribution of volatiles in preparation for future excavation and extraction missions. Later missions will then utilize these resources to create robust infrastructure on the lunar surface. So back to the business case. In order for ISRU, and particularly lunar rocket fuel, to make sense financially, it needs to be less expensive to source propellant from the moon than to launch it from Earth, and there needs to be a market. With the recent flurry of mission planning to the moon and deeper space by the commercial industry and national and international government agencies, the market has mostly been defined. The biggest delta V is getting out of Earth's atmosphere. Once you're out of LEO, the delta V significantly reduces and each kilogram of propellant is more efficient. If the cost of propellant obtained from the moon in LEO is less than the cost to ship propellant to LEO from Earth, the business case can be closed. Refueling upper stages in LEO to transport heavy payloads from LEO to GEO and beyond. This can increase the affordability of NASA's activities on the moon, ESA's Moon Village, and missions to Mars. While the savings depend on the in-space transportation approach and assumptions, there is now a big business case that can be made for sourcing propellant in space. In fact, a 2019 WGM report has released a conceptual economic study on mining water on the moon. They see the market as encompassing satellite refueling, the International Space Station and Lunar Gateway, Moon and Mars bases, space agriculture, tourism, and hotels. They are valuing this market at $206 billion over the next 30 years. The moon is a stepping stone to the rest of the universe, but it should not be overlooked for the science and resources it offers in its own right. By developing lunar resources, colonizing space becomes profitable and desirable. Regolith, which is one of the biggest nuisances and hazards of the moon, might just be the very reason humanity can envision a thriving economy in space. Ultimately, the reason for becoming a multi-planet civilization is to better the lives of everyone and ensure the survival of humanity. As we begin the next stage of space development, we need to ensure that we work to make this vision a reality while not repeating the errors of our past. And learning to survive and thrive on the moon is our first step towards this new existence. In the future, there will be thousands of people working and living to space. So here's to the beginning of the next great human adventure. Thank you for your time, and I welcome any questions.
Thank you, Melissa. Always terrific to hear you. So without being a jerk about this, regolith is difficult to deal with, yeah?
Yes, we can tell you even the terrestrial stuff is not the most fun, but you know, learning how to utilize it here and kind of some of the nuances will hopefully help influence decisions and technology that can be used on the moon. So we got to do it, right?
I want you to tell us a little bit of inside baseball. You know, you have worked with these materials for a couple of years. You just moved laboratories just recently. Tell us about some of the surprise stories of your own experiences in your own lab. Like you've worn down equipment that you thought was going to last for a long time. Tell us some of that stuff, please.
Definitely. So basalt, I think a lot of people are very familiar with. It's very porous. Believe it or not, it's softer than the anorthosite. The anorthosite is really hard. It has a lot of crystals in it. And so just looking between the two and how we have to crush them down and the output that they produce has been very eye-opening. Additionally, as you mentioned, when we started refining our processes and getting closer and closer to the final processes we wanted to use, we were breaking our equipment. We had, nuts snap off. We had glass jars that we had put material in with, a lid, and the lid we wouldn't be able to turn it because it had kind of seized up from the particles that got into those grooves and kind of jam themselves in with their little angular abrasive surfaces. So kind of learning, to make sure the top of the jar is clean, which is something that, makes sense. But in a laboratory environment, you're just sealing a jar, right? Well, no, you're not just sealing a jar. So kind of things like that. What sort of materials do we need to use? How often do we need to replace them? It's fascinating how quickly metal as well abrades away in the presence of these materials. So we're utilizing all of that, and we're excited to be able to share it with clients who are looking for that sort of expertise.
Well, and it's challenging to just function with this stuff in your own, like, one atmosphere environment, right? So imagine what it's going to be like to keep an environment clean when you're out in the middle of it, right? Like, how do you do that?
Definitely. I mean, I think about how much the dust lofts here on Earth, and that's going to be nothing compared to how much it lofts on the moon, because it really does like to spread around, get everywhere, it finds those little nooks and crannies to hide in, and it's very interesting. But that's again where we need to develop dust mitigation techniques, and honestly, an array of them, and probably combine that array of them. We need more tolerant materials. We need more tolerant designs that aren't going to allow the dust to collect as much, that are going to help the dust, kind of fall off, so to speak. And then obviously we need some removal procedures as well. The brushes weren't the greatest, so what else can we use? Are there cases where we do need brushes? If so, what style and design is going to be more effective? So that's where I think that it's going to be some very interesting work over the next few years.
You know, Dr. Veda was referencing an Antarctic style station. I have a hunch that an Antarctic style station would be the tippy top of luxury as compared to a lunar settlement. The earliest lunar settlement is going to be a mess, I think. And I really think it's an underappreciated problem. And so testing in advance, is pretty darn important, and certainly mission critical. Um, I know that you've recently won a couple awards. Can you talk about them publicly or not just yet?
Yeah, so one of our grants is from the National Science Foundation, and in that grant we're expanding our icy regolith capabilities to be able to make the process more portable and also size it up a little bit. It's great if folks want to come up to beautiful Seattle, at least when we're not in a heat wave. But we recognize that not everyone can, that they need to be able to test remotely at their facilities or elsewhere. And so it was really important to us to be able to make that process portable. And at ultra cold temperatures with some corrosive gases, it's not quite as linear as you might expect to size that up and do it elsewhere. Additionally, we had a NASA phase 1 SBIR to start answering some of these questions about dust mitigation. We were looking specifically at fluid and gas connectors to operate repeatedly in dusty environments.
Food and gas connectors?
Fluid and gas.
Fluid and gas. Okay.
Yeah. And really looking at for long-term missions, whether they're robotic or human, you're going to be able to you're going to need to reuse components multiple times in dusty environments. They're going to get regolith in them. They might be dropped. And so what can you do to design hardware that's going to be more durable for that environment?
I'm going to ask one question. You only have about 2 minutes to answer it. How does mammoth capacity of Starship change your vision of the future, specifically your business model for off-planet research?
Yeah, so I guess I should ask the question, are you envisioning Starship on the moon or Starship for Mars?
Well, I'm aiming definitely for the moon. Definitely for the moon. Sorry, that's a bias of mine.
Okay, us too, at least for now. No, I think the interesting thing about Starship is just that, honestly, the mass that it can take up is going to be so much more than we've been anticipating. So add in the years of trying to reduce mass, reduce volume. Hopefully we'll be able to get a lot on the ships. Additionally, hopefully it will allow us to bring things that can then make more on the moon. So when you're looking at, as someone in the comments mentioned, 3D printing, or you're looking at space agriculture or building habitats, you're going to need, in all likelihood, composites or even some water to kind of create the mixtures or the cements, essentially, that you're going to need. And so being able to bring up some of those resources is going to exponentially allow more to be made on the moon, especially if we're smart about what goes up on what mission to really help build that infrastructure. So as you mentioned, those first settlements might be a little rough, but what is going to be needed? Do we need what sort of equipment, what sort of tools, what sort of, again, kind of composites or additives? How is the regolith going to be used? How are we going to sift it? Do we need to sift it? All great questions.
Terrific. I mean, I think it's a fascinating future that we're going to be building together. So, good luck to you and Vince and the rest of your team. We're going to shift over to our next speaker. Thanks a lot, Melissa. Appreciate it. Michelle Zappa, nice to see you all the way from Sao Paulo, Brazil. We appreciate you coming in today. Let me just rattle off your awesome background. Michelle Zappa helps people and organizations think about possible futures. His work is about making sense of the technological ecosystem by mapping and tracking how it develops in order to bring forth more equitable futures. Michelle works with policy and decision makers worldwide on technology strategy. He's a futurist, information designer, and founder. His work aims to illustrate the implications of accelerating change and facilitate a higher level of awareness about our relationship to technology. Founding Envisioning Technology Foresight Institute in 2001 after publishing a series of speculative infographics. He has supported development since day one. He's devised methodologies and research frameworks for the future. Thanks a lot, Michelle. Really appreciate you being here. Please take it away. Thanks.
Thanks, Michael. Thank you so much for the invitation. Yeah, it's been a decade, not two quite yet. So since 2011, we've been at this, and of course, you're very present in the history of the company, and we'll talk about that in a second. So thanks again for your attention, and thanks for being here. I'm not an expert on space by any stretch of the imagination, so I'll be bringing in what we can hopefully call an enthusiast's perspective on what's going on, and hopefully rally some interest around building something together. So Envisioning is a technology foresight institute, and the objective of the conversation here today is to start sort of garnering interest around building a collective intelligence platform. It's something we've been doing in other around the space economy. So it's something we've been doing for other topics and sets of challenges, and we'll talk a little bit more in depth about that. But I think the stated objective is how can we work together in using all of these insights and intelligence of all types towards building something that is more sustainable and equitable. So I'm founder and CEO of Envisioning. I've been at this for, as I mentioned, about a decade, and I've always tried making sense of the near future. I think it's something that I've been drawn to my whole life. There's always a sci-fi bend in how I go about it, and but at the end of the day, what we're really trying to do is to make sense, or to bring I want to say, a degree of metrics or data to what we see going on in technology. Technology is oftentimes hyped. It's easy to get caught up in its possibility. And what we're trying to do as an organization is to bring a data layer to what's going on in emerging technology and then convey that to decision makers of all types. Envisioning is a fully global and distributed organization. There was very little adaptation after COVID. Thankfully, we've been remote since day one, and we're big on publishing and giving away our research as much as possible, licensed as Creative Commons and variations thereof. And we try to bring this degree of rationalism to how we look at technology. This photo taken a couple of weeks ago now, over at the Bund in Shanghai, where each dot on that QR code is a drone flying over the river, and then composing what effectively is a piece of advertising, because you're meant to scan the QR code and you see ads on your phone, or it takes you to a promo page. Well, why am I showing this? Because this is not the kind of technology we're about. I mean, this is part of the technological ecosystem, and this is some hype often gets more attention than unhyped things by definition. And this is not our angle at all. We want to be rational and have and promote a level-headed approach for tracking and making sense of what's going on, including the ability to talk about progress in a cohesive manner. And I can't present without name dropping James Burke's connections as one of the key sources of inspiration in doing what we're doing. But I think what Connections did wonderfully in the 70s is, if you haven't watched it, by all means you should. It's on YouTube, it's on archive.org. And what James Burke did with Connections is they as a team, they highlighted the intricate relationships that exist between innovations of different types and how innovation will often jump from one field to another. And that's something that's sort of core in how we approach our research. And we'll break that down a little bit more when we get to the actual specifics in a second. And my dialogue with Michael began about a decade ago as well, after publishing a couple of speculative infographics. Envisioning began as a couple of subjective and speculative infographics about the near future, where I tried making sense of what I saw going on, and then tried extrapolating on how those futures, technological futures, could possibly unfold. And you'll see that the second last column in this particular infographic is about space. And this is when Michael and I connected. He reached out early on with his own take on how these particular technologies might unfold in the near future. And ever since, we've been figuring out ways to build out this collective approach together. And we've had, as a company, we've had the privilege of working with organizations, both in the private sector, in trying to bring insight into innovation and technology happening in certain fields and industries, but mostly in the public sector, with doing horizon scanning and helping public agencies make sense of what's happening in, say, key areas of the economy, or domains that are relevant to their particular challenge as an agency. And we'll talk about one of these in depth in a minute, which is with the GIZ, the German Corporation for International Collaboration. And we'll explain the work we've been doing with them. So it's a great privilege to work with organizations like these. And what we're trying to bring to the table is always this measured and data-driven approach to talking about technology. And we do that by tracking technology, scouting them, we call it research, contextualizing them, putting them into stories and narratives, which we call content. And we do that using our own tools and visualization methods, which is what we call the platform. And another piece of James Burke, or his thoughts, I came across this phrase recently, and I felt it really resonated with what we're trying to talk about here today. So if you understand something today, that means it must already be obsolete. And I think that speaks to what we're trying to do, which is tracking a moving target. Technology is constantly advancing, it's constantly developing, it's constantly leveling up in some respect. And knowing where it's at right now means your information is probably old. And that's something we've been trying to solve systematically by building out these platforms, because technology moves in a certain direction. It progresses over time. It becomes more accessible. It becomes more interconnected. It becomes faster and faster due to underlying power laws and observations like Moore. And I think so it's with this in mind that we try helping others figure out what will be possible in the near future. And we do that specifically by isolating technologies, documenting them, tracking them, assessing them using various metrics. We'll talk about TRL in a second, but the underlying approach that we bring is trying to put every conceivable technology into a preset framework or logic using our various research tools. We do that obviously aligned with the Sustainable Development Goals. So every technology is tracked according or tagged according to which SDG it helps address. And we use a lot of data visualization, which I'll show on screen share in a second. And we consider ourselves as having a broad mandate in tracking these technologies. We talk a lot about emerging tech, but what defines or rather where the boundaries for what can be considered emerging, as those boundaries are fairly fuzzy, we try being as inclusive as possible in what goes into the database, especially so we can develop this ability to track dependencies between one technology and the other. And this is sort of highlighted here as between plows and space elevators, obviously. But this is meant to bring home the point that we don't consider only the cutting edge to be technological, much on the contrary. I think Alan Kay says technology is everything invented after you were born. And that's a little bit of the bias that we're trying to undo in our approach of tracking technology. And we believe strongly in that imagination informs innovation. So within imagination, everything is possible. Within imagination, you have a broad almost unlimited set of possibilities, whereas in innovation, you're confined to what can actually happen within, say, the realms of physics and economics. But there is a relationship nonetheless. This, of course, is the communicator from Star Trek's original series, which became one source of inspiration for the flip phone and eventually the smartphones. And there are numerous examples of how science fiction informs science fact. And the reason we bring this up is because the key metric that we look at when assessing any given piece of technology is its readiness level. So TRL is probably I'll assume that most of you are familiar with it, but for the benefit of those who aren't, I'll talk through the basic premise of how TRL assessment works, which is basically you attribute a number from 1 to 9 to any given piece of technology or technology application, depending on its degree of maturity. And then you can slice and dice those, you can group those scores according to various ways of blocking them. So in our case, we look at it from technologies beginning as concepts, that's a very low TRL, turning into proofs of concept, then they're validated, tested as prototypes before finally becoming products. The approach to TRL varies per industry. At the end of the day, what we're trying to do is bring a systematic way of measuring it, including, let's say, triangulating how different experts look at the maturity level of any given piece of technology at any given time, and then tracking those various scores over time, and hopefully at some point being able to predict how quickly, or rather how they might unfold in the near future. It's not only measuring the rate of change, which is something we're starting to do now, but also predicting how they might unfold in the near future. And specifically, I want to talk about our efforts into building out platforms. And these platforms are systems for collectively tracking technological progress in any given piece, in any given field or topic. And we're going to showcase a specific project done around sustainable development, which is something we launched a couple of weeks ago. But we want to use this as a springboard, as a starting point to doing something similar around the space economy. We believe that there are, I mean, we see what's going on, affectionately called the billionaires in space. We think that's great, but we also think there's plenty of space for others to be part of this transition into a new economy that we see going on. And that's the angle I think that's a primary purpose of what we want to present here, is how can we start leveraging that interest and build out something together. And I'll dive into, well, actually, I'm going to switch to screen share here. So I'll do a quick showcase of the project we launched only a couple of weeks ago. And this project was done in collaboration with the German Corporation for International Collaboration, or their International Development Fund, called GIZ. And here we're primarily looking at technologies for sustainable development. And so everything I've discussed thus far is present in this platform, and the platform is live and public and freely available. I'll drop the link in the chat in a second, but it's on here, techdetector.de. So what we're doing here is we're trying to give a comprehensive view of what's going on, of the technologies being developed for, or rather technologies and the relationship to sustainable development at large. So there are a few ways of organizing these insights. We can, a different entry point. So we can start with the SDGs, the Sustainable Development Goals, as one perspective. All 17 are listed. We can take something like eliminating hunger, and then seeing the different stories, technologies, technological applications that are relevant to that particular SDG. That's one approach. Another approach is we're creating a lot of original sci-fi to give context to the technologies presented in the research. And these original pieces of sci-fi are meant to help bring to life how the technologies might be used in the near future, and hopefully help direct the decision-making process today about which technologies that either the GIZ or any of their stakeholders should be investing in. And all of our data, or rather all of our research, is data-driven in the sense of that we collect various metrics. We've talked about TRL, so using this visualization layer, we can pull up the technology with the lowest TRL according to, from this perspective, so Perskovite solar cells would still be within proof of concept, again, from this point of view of sustainable development, as opposed to 3D slicing software, automatic legislative tracking, technologies that are fully developed on the TRL scale. So, but to complement that, you could argue that that's an objective measure or global measure, TRL, but we complement that with other aspects around that are much more subjective and much more field dependent. And that's a little bit of how I want to lean on that a little bit, and how we look at the platform as potential solution for tracking technologies within the space economy. Because what we've been able to do with the GIZ is to assess the technologies according to various sustainability metrics. So without getting too bogged down in the details of this particular platform, we can pull up a technology like social programming matching databases. And then not only do we know that it's a fully TRL9, but also that the sustainability impact of this particular technology as assessed by internal stakeholders from this organization is largely positive, and this is how those scores break down. And for a few of these, we have something similar around gender metrics. So not only how sustainable the technology is, but also how it affects gender balance in the economy at large. And this is meant to be a general insight about how we can identify relevant data points around each technology. And our underlying interest, once again, or our intent with this, is to create let's call it a level playing field, or a shared source of truth around which you can read about the technologies that are being developed, how ready they are, how quickly they're progressing, who's working on them, so the related organizations, academia, startups, all of that data is tracked for the Sustainable Development Challenge here, but also in general in our backend. And this is a bit of the approach that we would like to offer to this community, and to figure out if there's enough shared interest in the participants here today to try doing something similar, again, for the space economy. And with that, so hopefully, so we're working on a few more fronts and a few more topics that are likely candidates to be upcoming platforms. But we're big believers in doing something around the space economy, and would very much like to figure out where that interest lies, and especially what kind of challenges that are faced in as a community that we are not privy to, that we're not looking at, because we're coming at this from a research and development perspective. It's very, I want to say, a global approach, in the sense of we don't know, we're not sustainability experts the same way we're not space economy experts. What we know how to do is to identify, track, and make sense of these technologies, primarily through this platform, but also through a few different other approaches. So what we're looking for within the group today is really who else is if this challenge makes sense, who else would be interested in participating in getting this off the ground, and start sharing insights around the technologies affecting how we reach the stars as a species. I'll drop a link to a web form in the chat together with the Technosector link in a second, and the QR code should be working as well. The web form is meant to start gathering the potential interest, again, around this challenge. And with that, again, I want to thank all of you for your attention, and again, thank Michael for getting us invited in this select group.
Happy to have you here, Michelle. Really appreciate your team. For the folks who don't know, he's got a team that's spread between Brazil, where he is, and Germany and other parts of North Europe. I believe he's got an 18-person team. So this is a pretty interesting organization. I've known Michel since almost the very beginning, maybe before the official beginning of envisioning. So it's been amazing to kind of watch that evolution. So nice job to you and your team. So I'm going to ask a question that Michael Mealing posted, but before I do, I'm going to point out to Michael that Michelle and I have actually talked about your paper about market readiness before, and I think it's a really terrific overlap. So he's already been briefed on you, buddy. So I'm going to read the question. NASA and the Office of Science and Technology Policy have been asking the VC world over the past 3 years why we don't invest in advancing the TRL levels of technology that NASA needs. Our response is that market readiness matters far more than technology readiness. To demonstrate that, I wrote a paper on one way of doing market readiness levels, and he posted the link there. I've read his paper. It's a good paper. You should read it. And the question he asks is, does your framework have an equivalent market readiness level?
That's a great question. And I agree with the sentiment that technological readiness doesn't mean as much if there's no market and business preparedness for doing it. So on a concrete note, we've tracked both business readiness level and market readiness level. They're slightly different approaches for a particular project. In the past, we did a piece of work with the European Institute of Technology, their manufacturing branch in Spain, just last year. And there we looked at the delta between TRL and it's either BRL or MRL. Now it slips my mind which one we ended up using because we considered both. So 100%, it's something that we want to look at more extensively. We've only done it in a pilot for one complete set of technologies around manufacturing, and the framework is ready to be applied across the board. At the end of the day, it's sorry, I think that answers the question.
So, one of the reasons we brought you on board is, you're a space nerd, but you're not a space pro, right? I think that's a safe way of describing that, right? Okay. So one of the things that we brought you on board here for—
This is my, you can barely see it, but I have rockets literally behind me here. So.
Beautiful.
Behind the screen, yeah. So.
You are a nerd. Me too, man. We're speak the same language. So one of the things that we wanted to talk about was, here we are, we're trying to develop the moon, right? That's the point of the Moon Society. That's the point of the Lunar Development Conference. But we don't really have a good handle on— I don't think we have a good handle on where we came from. We definitely don't have a good handle on the current state of the art. So it's really hard to make any sort of— I know you don't like the word predictions about the future, but it's hard to make assessments about the future if you don't have a good understanding of the current state of the art. And so in my view, that's what your platforms are doing, is they're enabling an understanding of the future by understanding where we currently are. Is that a safe way of assessing that?
Absolutely. So I think we felt there were two sort of low-hanging fruit that could be used in addressing the concern you're raising, which is how do you make sense of what's going on? I think the two low-hanging fruit we're working on especially are both TRL as one of the indicators of simply adding a number to the technology. We feel that's something every article or even gadget blog should be doing, because it's so difficult to make that distinction, right? So on one hand that, and on the other hand, just putting the technologies into stories, give them color, give them context, put them into, and having that sort of bilateral, or that the approach where we can literally link a technology from within the story and have that be represented as metadata we feel goes a long way to help people make like just simply discern what's hype from what's real. And then to the point of prediction, I mean, we would love to do predictions. We do avoid it now because I think it's too fuzzy. But having data-driven predictions would be very different. And that's something I think that's what we're working towards. So simply tracking TRL over time and having, I think that gives you that together with BRL, MRL, and other assessment methods as timestamp data should, that's a big hypothesis, but it should give us the ability to determine how, at least how quickly things are progressing. We get that, but also how they might unfold in the near future, comparing that to other fields, sectors, etc.
So first, I want you to put your screen back up, the one that shows the link to the web form, because there are more people on the various wild west of the internet video screens than there are attendees here. So I want to make sure they can see that. I don't expect anybody to type that out. That's going to be pretty challenging.
No, I'll do this though for your. There we go. So that's a big, very clickable or very scannable QR code.
Thank you. Yeah. We've got a couple hundred people out in the wild west of the internet, but fewer people are here. And I just want to make sure that because you posted the text in the chat, which is great, but I wanted other people to be able to see that. So thank you.
Yeah, and if you're able to type this up, leave a note. If you find the URL by typing it in, we'll get you a special bonus prize. No, but sorry.
So, you're monitoring a bunch of different technologies, and your organization has tracked stuff for smart cities and a bunch of different use cases. About how many technologies are you tracking currently?
So we're breaking down technology into three distinct buckets. We have domains, which are the areas of research, things like AR, VR, IoT, even AI and ML. Like all of those are usually, we would never consider that a technology, but rather a field of research. We call it a domain. And then within each domain, we have what we call methods and applications. Method is how something is done. It doesn't really have TRL, and an application is what something's used for, and that really does have a TRL. So between those three buckets, only really applications have TRL. And we're tracking about 1,400 technologies of both methods and applications. In the sustainable development platform, there's about 150 applications, I want to say, plus a number of methods. But on the back end, yeah, it's over 1,000.
And what you're looking for from the community at large is how do we start tracking space-specific applications, space-specific technologies? Is that correct?
So there's no clear line between what's space-related and what isn't, right?
Super glad you said that. Super glad you said that.
So I think the framing is really around how ready something is for space is sort of the best hunch that I have in terms of, so any technology can be used in space, but of course it needs to be lighter and more robust. And there's all these constraints on what you actually want to use in space, not to mention the different resource use that you'll have out in orbit. So at the end of the day, what we really want to find with the community is identifying these indicators. Like how can we look at our complete data set and say, how ready is this for space? How can we take 1,500 entries and create an assessment vector or metric that talks either about the space readiness or even quantifying things like weight or energy use. There are a lot of possibilities in how we can apply these tools. And again, we're by no means experts on this. So what we're doing is we're offering our experience and our tools for the community to figure out a way, hopefully to figure out a way how to pull this off together.
Well, in my opinion, the thing that differentiates what y'all do versus some other futurist style organizations is you have a very repeatable methodology, right? That you can use the same tools to evaluate different ideas, different technologies, and that gives you I think that's a very powerful tool that could be leveraged for the space community. All right. Michelle, thank you very much. We really appreciate you having us here. I hope you're feeling okay. And let us know if there's anything that we can do to help. We're going to switch gears here in a minute and bring on our Vice President of the Moon Society, James Burke. By the way, I will point out the James Burke that Michelle was talking about is not related to our James Burke. I learned in the chat that our James Burke is descended from a different line, the Irish line, but family Galway. So I think that's pretty neat, but not the same James Burke. There were some questions about that. So.
He could be like my 12th cousin or something. I'm not sure.
It's important to note that our James Burke does not have an E at the end of his name, and that James Burke does. I've been making that error for about 6 weeks now, and I finally figured it out.
You're not the only one. The method behind that is the British like to put the E on the end of my name to make me British, but I'm not. I'm actually American, so.
Right on. Okay, James Burke without an E, please take it away and talk to us about vision, mission, values of the Moon Society. You've got about 15 minutes, so we're right on track, by the way.
Sounds good. Awesome. Thank you so much, Michael. And again, thanks everybody for attending today. I'm on the organizing committee of this conference, and I'm really proud about how it came together. But that's what we do at the Moon Society. You know, we're a small organization, but we accomplish a lot. And I want to talk today about our past history a little bit and our vision, mission, and values. But we are sort of at a crossroads. We are trying to figure out who we want to be as humanity moves into this new phase of settling space, enabled by things like Starship. We're going to be able to actually get to the moon in this next decade and start doing the things that the Moon Society has been talking about for 20 years. And so the Moon Society, we actually grew out of an earlier organization called the Artemis Project, the Artemis Society. No relation to the NASA program. They didn't ask us if they could use the name Artemis, which is fine. They can use the name. But you know, back in the year 1995, there was a book that came out, or a plan that came out in this. It was published originally in Analog Magazine. This is the January 1995 issue of Analog Magazine I'm holding. And inside it is the Artemis Project article, which was basically a commercial plan to go to the moon. And to do it with private money using the space shuttle and raising funds primarily through entertainment. So they wanted to, at the time, this was Greg Bennett's project. He was a former NASA flight controller. And what he wanted to do was raise money through entertainment, through some selling of the science results as well, and other things, you know, promotion. But they would fund the mission for about $1.3 billion, and that's 1995 dollars. But definitely a low-cost mission on the cheap that could be accomplished. Now, the Moon Society grew out of the Artemis Society, which was founded by Greg and others to promote the Artemis Project. And in the year 2000, the Moon Society was founded at a conference in Las Vegas. And I was there. I actually was there. I was a lot younger then. I had more hair, but I was in the room when we started working on our bylaws. And to quote from our bylaws, we had the idea that we would create, through the Moon Society, create a spacefaring civilization which would establish communities on the moon. That was our big goal. That was right at the beginning of our bylaws in the year 2000. Also in the bylaws, we wanted to promote the large-scale industrialization and private enterprise on the moon. Private enterprise has always been a focus of the Moon Society, and trying to see how the everyman, so to speak, a regular person could actually help make this future a reality. We also wanted to bring together people, and this conference is a manifestation of that. We're bringing together people from government, industry, educational institutions, the press. All those are represented in our conference today and tomorrow for the exchange of information about the moon. And then finally, informing the public at large. And we would do that through various publications that we did. Our flagship publication for most of the Moon Society's history was the Moon Miner Manifesto, published by Peter Koch. It was a monthly newsletter. And so lately we've been working with Peter to publish a couple of his books that are taking material from the newsletter. But I want to talk about our mission, vision, and values. And so our current team at the Moon Society, we're, again, a pretty small volunteer team. I rejoined the organization in 2018 as vice president. Michael Mealing became our president shortly earlier than that. And we have other great volunteers such as Ben Smith, who will talk again today. And so what we've come up with now is what you can see on our website, which is our mission is simply to enable permanent lunar settlement. And we will do this by building a community and building a set of partners. And we're well underway with doing that. We have a lot of great partners that we've been working with. And we want our community to be inclusive and include not only research of technology and science, but economic development. That's a huge focus for us, business, and bringing in venture capital to lunar projects. And then finally, public education, outreach about the moon and understanding what the moon is all about and what the potential of the moon is for our human future. Our vision is that we envision a hopeful and exciting future. We're not a dystopian approach. We don't believe in like scarcity in the solar system. There's a future, it's a future of abundance that we see, and a future that we can solve a lot of the problems on Earth by exploring space. We want to see multiple permanent civilian settlements on the moon, not government, not military settlements, civilian settlements that you can go visit, you can go be a tourist at, or go live there permanently, or have a summer home, or visit for a week or two on vacation. That's what we see. The future of the moon is somewhere that anyone can go to. And also contribute to a robust cislunar economy. We believe that there will be, in the next 10 to 15 years, a very robust economy around the Earth and the moon and that system, using the Lagrange points, having space stations in lunar orbit, such as the Lunar Gateway that NASA is working on, and others, and having economic development across the system. Using local resources on the moon, making sure that we can mine the water ice that's available and other resources such as helium-3 for fusion reactors. That's all things that people have been talking about for a long time, and we're going to actually get to see that in the next 10 to 15 years. And finally, again, we want to improve the quality of life on Earth. We're not exploring space by taking away what people would spend money on Earth. It's not a zero-sum game. We explore space because we want to improve the quality of life for everyone on Earth. Our values, we don't really have a formal set of values, but this is what I would propose. And again, we're at a crossroads at the Moon Society. All of us would like to talk about where we want to go and what we want the Moon Society to be. Michael Mealing will have a few comments on that later today as well. I know Ben has ideas and Michael Lane has ideas and others have ideas, and we want you to be part of this too. But here's my proposal for the values of the Moon Society. And innovation in all endeavors that we do. And I think we've been good at that with the projects we've accomplished in the last few years. Engineering and technical prowess, business acumen, those are all really important things for settling the moon, I believe. We should be an inclusive community with diversity, not only of people, but of ideas, and inclusive of those ideas. And we want to be a global community. We don't want to be focused on the US or specific countries, but we want to include everyone from around the world in what we do. And then finally, we want to get things done. We want to be mission and goal driven and have a pioneer spirit and a can-do attitude. And so with these values, in the last few years, we've actually been able to accomplish a few things. The first thing we did was we revitalized our website, and you can browse our website. There's a lot of great information here. We also, as I mentioned, published Peter Koch's book, A Pioneer's Guide to Living on the Moon, making use of a lot of the concepts that he had back in the Moon Miners Manifesto newsletter that he published since 1986. This is an ebook and a printed book. It runs 700 pages. It's not a light read, but it is very comprehensive and talks all about how we could settle the moon and build a sustainable lunar civilization. We put up an online store, lunartraders.com. This was a store that had been around at the early days of the Moon Society, and we resurrected it. And you can access our books and some other swag there. Also, the proceedings of last year's conference are up there as well. We actually were able to create transcripts of all the videos from last year and publish that in ebook form. One of the things we also were able to do in the last 2 years is to merge with the Lunar Resources Company, which was the commercial arm of the Artemis project and the Artemis Society. When that effort was going on in the 90s, they formed a for-profit company that was going to be the Lunar Settlement Company. That then spawned our organization. So what we were able to do was go back to all the original shareholders from the 1990s and buy up all their shares. And so we've now merged the Lunar Resources Company and all of its intellectual property, including the Artemis project materials, all the 3D designs that they did back then, into the Moon Society. And you can think of now the Moon Society as we have a nonprofit arm and a for-profit arm, and our projects we do may use one or either of those in the future. We also have our wiki, the Lunarpedia wiki, which we hope to grow and become the #1 resource for information about the moon. It's a public domain wiki, so it's designed that all the material in here can be used for other projects, sort of like open source software. You could use the information here for building other projects, and we hope to eventually have a lunar atlas and comprehensive details about all the locations on the moon. But we already have lots of articles about lunar science and lunar settlement and mission concepts. And then the last thing we were able to do in the last year was the moon-based design contest. Several of our entrants to the contest will be speaking tomorrow. I'm very proud of how this went. We had high quality designs that were submitted. Here's the winning design. It's called Domi Inter Astra, DIA is the name of the settlement. It was created by the Space Generation Advisory Committee concept team, and just great high quality renderings that they created, as well as their 10-page proposal. And we had 18 total entrants. Some of them are really fascinating to take a look at, and a lot of them will be presenting tomorrow. So I'm looking forward to that. So we're the Moon Society. We'd love to have you join us. We are a membership organization. It costs $35 a year to join, and you can participate in all of our activities, but we definitely would love to get more volunteers to help grow our projects and grow the efforts that we have online. And again, I'm really proud that we were able to organize the Lunar Development Conference again this year. This is our second one, and we plan to be able to do this every year to bring together the community around discussing the topics surrounding the moon. So thank you all. If I can take any questions if we have any. I think we have about 2 minutes in the schedule. One of the things that I'm really excited about, as well as the first book that Peter Koch created, he has manuscripts for another 3 books, so a total of 4, and we'll be publishing those over the next few years.
Any questions for James? for the chat? Okay. James, thank you very much. Really appreciate that. Pardon me. The Moon Society is in good hands with these vision, mission, values. It's going to be really great to watch this unfold over the next coming years. You know, as a 35-year-old organization.
Our organization, the Moon Society, was founded in 2000, so we're about 21 years old at this point. But the effort that came before us by some of the same people started in 1995. Yeah,
it's really quite tremendous. And given all of the activity globally, it really is exciting to kind of see this organization, I would say, have a renaissance moment and kind of come into its own as a thought leader for where humanity can go on the moon. So I'm really excited about that. My participation is recent, but I'm pretty darn excited about it. So great. Okay. Let's move on. Laura, are you here? I see you. I just don't see you. Okay, there you are. Hey, how are you?
Doing great.
Good. All right. Let me, by the way, before I bring you on, Laura, I want to kind of point out the schedule. So this is where we are. We're on track. So pretty happy about that. We're switching gears now to kind of, with my talk in the beginning of the morning, I talked about hardware business outreach and frameworks. So this was, this kind of concludes the first part of hardware. We talk about hardware a lot tomorrow, so don't worry about that. We're going to come back to hardware. We're going to switch gears for a bit and talk about the business of space, the business of the moon. So pretty happy to bring on Laura. Let me read off her bio here. Laura Forsick is the owner of space consulting firm Astrolytical, specializing in space science, industry, and policy, and offering space career coaching services. She is a NASA subject matter expert for planetary science missions. She serves on the advisory boards for the Lifeboat Foundation and the Society of Women in Space Exploration. She serves as a mentor for the Brooke Owen Fellowship. Awesome, by the way. We'll talk about that in a minute. She is the author of Rise of the Space Age Millennials. Prior to forming her own company, she ran the Florida office of international startup, working to establish parabolic and suborbital flight at Kennedy Space Center and globally. She has also worked as a scientific analyst for a nonprofit facilitating over 50 experiments on the International Space Station for the benefit of life on Earth. She is pretty awesome. We're really glad to have you here. Thank you very much. Take it away.
Thank you so much. So the moon has always been my thing, by the way. I do a lot of other things in space, but ever since I was in third grade, I decided I wanted to go to the moon, and that has not changed. So the moon is still my passion. If anyone wants to send me, I'm right here. I volunteer. So getting down to the business side of things, one of the questions I am most frequently asked is, why is now different than before? And maybe some of you are historians and can answer this better than I'm certainly on the younger side, probably, of the people in the audience. So you've lived through a lot of cancellations, right? We've lived through the cancellation of both President Bush's programs, the journey to Mars. There's been lots of changes in direction with NASA in particular. Why is now different? And one of the things that keeps being said over and over is now is different because of the approach, the public-private partnership approach and the international collaboration approach. And I find that interesting because we haven't proven it, right? If it works out, if we do get to the moon and we do stay there for a significant length of time, longer than Apollo, because Apollo did go there for several years, right? Then that will be so fascinating to look back at history and say public-private partnerships work. There is an economic business profitable reason for companies to want to do this. It's different. Okay, so back up a little bit. Why is it different this time? We all know, I mean, actually most of us know, there was a congressman in a recent hearing that asked Bill Nelson, why is it corporate involved now when corporations were involved in Apollo? So most of us know, but that congressman did not know that corporations were very involved in the Apollo program, right? But it was a different approach because NASA owned the hardware, NASA owned the direction, NASA owned the designs. It was NASA led. And now it is quite different in the approach in some aspects where NASA has this pool of companies that they've chosen for the commercial lunar payload services CLPS. And they are telling these companies, this is what we need. You figure out how to do it. Same with the human landing system, hopefully. I don't think that's going to change at this point, although some members of Congress wish it would. But hopefully it'll be the same thing. This is what we need. You figure out how to do it, and we'll pick you if we think your approach is the best and the price is right and that kind of thing. So that kind of change in mindset of fixed price contracting might make the difference. Maybe. What's in it for these companies, though? So what is unproven that is talked about constantly in the circles that I'm talking to right now, so you might feel called out, I apologize, but what's talked about constantly but not yet proven is mining. So I come from a background where my graduate degree in planetary science, which you have it wrong on the slide, by the way, I didn't actually finish my PhD, I'm all but dissertation, but my PhD research was to study lunar regolith. And so looking at the properties of lunar regolith and mostly how it moves and the difficulty of tracking it. And you might have seen some of the presentations about how it can, if there's an impact on landing, for example, the retro rockets can really get this stuff absolutely everywhere, like orbiting the moon kind of everywhere, even impacting Gateway in some way or another. There's some interesting work by Phil Metzger at UCF and Masten Space Systems, really fascinating stuff. So I worked sort of on that, but on low velocity impacts, so really small impacts. But even in small impacts, lunar regolith is a real pain to work with. It's sharp, it is electrostatic, it is just a real problem. So are we going to be able to process, first off, pick it up, right? And NASA has a call out right now where they have asked companies globally, if you mine this stuff and just put it in a pile or put it in a collection bin, we will buy it from you. And that's a separate issue where it's actually trying to establish legal precedence. But that initial step of just picking this stuff up, that's the first step, right? There's a competition that's held, I think it's annual. I don't know if it happened with the pandemic, but it's at Kennedy Space Center where groups of university students try to figure out how to mine a regolith simulant. And it's just fascinating. I was there when it was first started. It was called Lunabotics at the time. They changed the name. I don't remember off the top of my head what they changed it to. I haven't been involved since I moved, but it's just a really difficult problem. And that doesn't get into the problem of then once you have it picked up, how do you deal with it? Can you really break it apart as easily as we think? Can you really, process it as easily as we think? So all of these steps need to be proven before we can be sure that there is going to be a profitable return, either to use the resources on the moon for the purpose of whatever we're doing on the moon. So ISRU, in situ resource utilization, or taking it to orbit and using it for fuel depots, which is another problem because then you have microgravity, and everything in microgravity is just a lot harder than we used to. So we can do experiments on ISS, and we have done experiments on ISS on, flow and fluid dynamics and that kind of thing, but it just has not been proven yet. Or maybe we take it back to Earth for some reason or another, or maybe we take it elsewhere. And it's just, all of this is very complex. And so when we're thinking about the profitability of mining, it very well could be that is the first thing that companies latch onto to make a profit. But it's still a long ways away. It's still not the next 5 years kind of thing. Another thing that is talked about is tourism. And with good reason, I myself want to be a lunar tourist, or send me as a scientist. I don't care. I want to get to the moon, right? I'm sure a lot of you do as well. So tourism is an area where it's just beginning to start in suborbit this month, really, sort of, although Virgin Galactic is not flying tourists this month, but Blue Origin certainly is trying to, with whoever won that auction at $28 million. And then Wally Funk, I don't know if you can consider her a tourist necessarily, but they're trying, right? They're trying to do commercial suborbital spaceflight. Back in the 2000s, we started with orbital spaceflight, but that was with a Russian rocket, right? Russian technology, pretty much Russian everything, Russian training. The only commercial that was involved was Space Adventures, which is a commercial company that sort of was the facilitator and helping to get the customers and train the customers and prepare them. And so we're just now at the very start of suborbital space tourism and commercial space flight. And then arguably, in September, or as early as September, we might get orbital with that Inspiration 4 mission flying on a SpaceX Crew Dragon, free flying around the Earth, not to the International Space Station. So that might be the beginnings of real, true commercial suborbital tourism, or I'm sorry, orbital tourism, if you want to call it tourism. Which I think it probably falls in that definition. How long until we can get people who are not trained professional astronauts, who are not government astronauts or sponsored researchers? How long until we can get them on the moon? Well, it's probably going to be decades, right? And there's some other things that are talked about. Helium-3 research is talked about a lot. We're not there yet on Earth, let alone trying to deal with it on the moon. And there's lots of other ways that have been thrown around to make money, but we're just not there yet. So why am I being pessimistic, right? I'm not trying to discourage anyone. I'm trying to set a realistic standard that is not usually here in these kinds of talks. I'm trying to get you to realize that for the longest time, it really truly is going to be government directed and at the whim of government. And I'm not just talking about NASA either, because we do have the Russians and the Chinese who have partnered together with the, see if I can remember, I can't remember the acronym, International Lunar, you guys are shouting it at me, I'm sure. But anyway, they have their own lunar base idea. Now they have a different time scale. And I don't like to use the word race, right? Because it's such a different time scale that it's really not a race. It's a competition, sure. But they're not planning to send people to the moon until at least 2036. Whereas Artemis program is still saying 2024. We all know it'll probably be 2025 realistically, or even later. But hopefully, sometime in the next few years, right? So totally different time scale when you're talking about a decade's difference there, 2024 versus 2036. But there are other governments involved. And then when you're talking about the Artemis program, it's not just NASA, it's also other government agencies around the world. There have been 12 signatories so far of the Artemis Accords. And those countries may or may not be sending people, but they're certainly involved in payloads and science, in whatever it is that they decide is the right way for those countries to get involved, is how they're going to participate. Now, there will be international crews on Artemis 2 will have a Canadian astronaut as well as NASA astronauts. And the plan is that Artemis 4, I think, is going to have an international astronaut as well, although that's not yet decided. Artemis 3 is going to be all NASA. But there is that change, right? And that is another change from Apollo, where it is very international rather than very nationalistic. Nationalistic in terms of it was US beating the Soviets, right? Yes, we had a plaque that said we came for quote unquote all mankind, but it was all NASA astronauts. It was all NASA, right? We did have some international partnerships involved in the whole process, but it was only ever going to be NASA astronauts that went to the moon during Apollo. Whereas now it's quite different, where we do want to bring in international collaborations. The interesting thing, going back to the whole concept of tourism, is that NASA has decided to take this approach where they are purchasing services from SpaceX. If that GAO protest holds, it'll be SpaceX for Artemis 3, and then potentially other competitors like Blue Origin for Artemis 4 and beyond. And NASA is not owning those vehicles. NASA is not owning that technology. NASA is allowing those companies to own their own technology, own their own hardware, and sell it to other groups, whether it is taking another government astronaut on board separate from an Artemis mission, or taking tourists up eventually, right? Elon Musk's plan for SpaceX from the start was to take people to Mars, and Mars is quite a distance away. And so if you're going to be thinking about taking people to the moon, we have already an example. We have Dear Moon Project. Do you remember that from like 3 years ago, where there's a mission on the books? Who knows when it's actually going to happen? They originally said 2023. We'll see if that happens, where they actually want to take a starship around the moon, circumlunar, and eight passengers and 3 or 4 crew or something like that. I'd have to go look it up again. But that is the beginnings of lunar tourism, right? You're not landing there. You don't have to worry about a lander. You don't have to worry about, eclipse on the moon and all of all the complexities of landing. You're just sort of doing a trip around. And that might be just the beginnings, right? Which is very exciting. I would go, and in fact, I applied for Dear Moon. I'm sure some of you did as well. I did not get to whatever the next round was, but I find that very exciting. The whole concept of SpaceX deciding that they could go ahead and take non-government astronauts around the moon. And of course, nothing is final until it actually happens, right? Things can be canceled, things can be changed, but I find this whole idea very interesting. So how does Apollo differ from the ways that how does Artemis differ from the ways that we have done it in the past with Apollo, with this SEI, with Constellation, all these other programs that just were insanely expensive or unrealistic and were canceled? Well, hopefully, if it's no longer just the whim of governments, then hopefully, whether or not a government initiative decides that, yes, we want to go full force to the moon, there's going to be some commercial incentive to keep on going or to keep on pushing. That's the idea. And I am not here to tell you the future. I don't know if it's going to play out the way that we all think and hope it will. And I know there's probably some people, not on this conference probably, but there are some people who wish we just go to Mars directly and ignore the moon. I've never been one of those people. I'm sure most of you are not as well. But sure, yeah, there are some people who think, well, maybe we need just to skip the moon altogether and go to where the passions of the public are, which the public actually does prefer. If you look at the polling, they prefer people going to Mars rather than the moon. And you've seen some discussion about that, especially during the Obama administration, where it was Journey to Mars. But I find it so interesting that we have those choices, right? It's no longer just one government program saying, we're doing this. It is lots of different companies saying, we want to do this. Lots of different countries saying, we want to do this. And all those different options. And whether or not there's the money and the technology and the motivation and the luck, because there's a little bit of luck involved too, right? Whether all that works together to have the options of saying, we want to be in low Earth orbit with commercial space stations. We want to be in the moon with Gateway around the moon. We want to be on the moon with these lunar bases that we want to establish. We want to, there's a concept of the moon village with the European Space Agency. We want to go to Mars with people, and beyond, right? And beyond was always tacked on there of where's beyond? Well, anywhere and everywhere, right? Within our solar system and eventually beyond. That's the science fiction-y kind of answer, but it's the truth, right? We're just not going to stop at the moon. We're not going to stop at Mars. We want to keep going. And having those options, I think, is invaluable because it gives us the opportunities to explore things in ways that we haven't been able to in the past. Because in the past, it's all been the government money. And realistically, commercial operations saying we want to do a space hotel or we want have not been realistic because it's been too much money and too much technological difficulty. But now that's changing. Now it's changing where commercial companies have the technology and the capability, where billionaires are spending the money, where it could be a different way to approach it, where NASA may be doing one thing, but a company may decide they want to also do something else at the same time. So I'm looking forward to seeing how this all turns out. I don't know if this is the kind of talk you were expecting, but this is what has gotten me most interested in Apollo. I'm sorry, in Artemis. And one of the things that I wanted to, I was talking about the difference between Apollo and Artemis the other day with a colleague of mine who was very involved in Apollo astronauts. And one thing that she talks about is how outside of the space community, it is not really known that Artemis even exists, let alone that this is the program that's going to be sending the first woman to the moon. Just by scanning the screen right here, I don't see any other female names. Maybe if I keep scrolling down, I'll see other female names, the other women on this call. But believe me, it's important to us women to see other women, because for so long, women were excluded from even having the opportunity. And this is something that's come up recently with Wally Funk being chosen for Blue Origin. I'm so thrilled for her, because those very qualified women that were training under that pseudo NASA program, it wasn't truly NASA, it was kind of imitating the NASA Mercury program training. They were incredibly qualified and yet not allowed to become astronauts. And so the society is changing, and we need to not just say it's changing, we need to actually show the world that it's changing. Show the world. How many female cosmonauts are there? Almost none. How many female taikonauts are on the Chinese space station right now? None. It's a crew of 3 men. It's very important that we not just say that it's important to have diversity, but we also demonstrate it. And also the person of color has been added recently to that little saying of we're sending the first woman, the first person of color. I don't necessarily like the phrasing of that, by the way. I feel like it's tokenism, but at least they're saying that that is a priority for them, that we are going to show the world that more of the representation of humanity can be going out and exploring the solar system, the universe. And I find that very, very important. Another thing that's very important, and Michael touched upon my book when I was introduced, when I was interviewing millennials right now are in their 20s and 30s, all the way up to about 40. Millennials were not alive during the Apollo program. We did not see any landings on the moon. All we saw was shuttle, right? There's nothing, shuttle was fantastic, right? But it's not the same thing as landing on another body. So for millennials to see this is something that will probably change how millennials see the space program and how millennials can see themselves in the whole structure of the universe. And another thing that Michael touched upon is the Brooke Owens Fellowship. There's the Brooke Owens Fellowship Summit is going on right now. It's a fantastic group of women and gender minorities that they choose each year to do these internships in aerospace companies and then come together during the summit in person before the pandemic and hopefully soon after, and also virtually right now. And it's just, again, it's that representation. It's knowing that they have the opportunities, that it is for people like them, that they can go and get involved in aerospace companies and have an aerospace career. And they themselves can either work on programs to go to the moon or personally apply someday to go to the moon. These are all undergraduate students, so they're still a bit young. They're still trying to figure out their way. But I think it's super important to have that ability to show people that, yes, this is really, truly happening, and it can be for people like you. And whether that's people like you women, whether that's people like you who are not white, whether it's people like you who are not American and are in some other partnership, international partnership, an Artemis Accord signee, I don't know, but I think that's a really important thing to focus on. So I'm going to stop here. And okay, Michael says that more of our speakers are women. That's good. I did know about some of them. I didn't see them on the list. So great. I'm going to stop here and just open it up for questions. I don't know if you wanted me to focus more on the business side of things, but I can always answer questions.
We're good. We're good. And by the way, I'm really glad that you highlighted the Brooke Owen Fellowship. I really think that that's a super important organization, and the partner organization with Patty Grace Smith Fellowship. Like those are the industry has needed that for a really long time. So it's really good to see that. And what's your role there? That event is happening today, this weekend, right?
Yeah. It started yesterday. I'm an executive mentor and a coach for the challenge. So I really help out the students in any way that they can to have a great summer and have a great internship. And really, there's 2 different challenges, and I'm helping out with the satellites in orbit kind of challenge, where my group is trying to figure out how to clean up space debris and that kind of thing.
Cool. I'll post a link here, or you can post a link here in a second to both of those organizations. It's really neat. I'm just gonna read. Michael Mealing's always pretty opinionated, and I'm just going to read his comment here. I definitely agree with Laura on this. He's talking about activity on the moon. I definitely agree with Laura on this. unless and until there are large numbers of people who are willing to spend their own money to go and stay, it will be government agencies and thus very difficult to attract private capital. So you're the first person, and he's going to talk tomorrow about it's really hard to attract capital for lunar focused projects. Tons of stuff is getting capitalized if it's going to low Earth orbit, if it's a data play on Earth observation or something like that. Tons of capital is going to LEO. Almost no capital is going to the moon because it's governmentally focused. Do you have any thoughts on how to break that logjam? I mean, if you have an answer, I don't have an answer, so not to put you on the spot because it's hard.
I think it's just time, activity, maturity, right? That's how LEO got or is getting commercialized, right? It started out with government satellites or very few commercial satellites for decades, and then it diversified. And it diversified because we found more opportunities with different industries and more applications for these satellites. And I think it just is maturity of the industry and activity to show that it is happening. So it's almost a chicken and egg problem, unfortunately, where you have to have the money to do something, to prove the activity, to then get more money. But that's where the public-private partnerships can come in as well. Because if you get a government contract, that's proof that, yes, you're doing whatever the government is asking you to do, but that can also be dual use. And by dual use, I mean like government and commercial. I don't mean like military, although military is certainly involved, and military certainly has a lot of money to throw at Lunar as well. And so I wish I had a better answer because it really truly is chicken and egg kind of problem. And I am absolutely horrible at getting money. So I defer to Michael Mealing on that kind of topic on how to attract investors. I just talk to investors and tell them what's real and what's not. But it's going to be maturity of the market. And right now it's brand new. It's really brand new. We haven't done anything like this commercially. Like I said, Apollo was all governments hiring corporations. This is such a new area.
Yeah, it's really quite amazing how this has evolved. For those who are sticking around later today, Laura has highlighted some of the stuff we're going to talk about later. Dr. Roger Lanius is a senior historian, and he's going to talk about kind of how we got here, right, from the Apollo perspective, because as you said, most millennials have never encountered, quote unquote, the glory days of NASA, right? Like the coolest thing we've ever seen, I'm a little older than that, but the coolest thing that most of us have seen has been a space shuttle, which is pretty awesome, but it's not an Apollo program. So Dr. Lanius is going to kind of bridge backwards in time to kind of showcase how two budgets, a Soviet and an American budget with one goal, has evolved into thousands of budgets, thousands of organizations, lots and lots of goals. So that's going to be pretty fascinating. And Dr. Goswami is going to kind of catch us up to where we are currently. So you had a really nice segue for where we're going later this afternoon. One last question, because we're running out of time here, is Starship Singularity, right? Hashtag Starship Singularity. Do you have any predictions on when it's going to fly? Musk talks about fleets of 100 starships. That feels like hyperbole, but I've been wrong about him a couple times now, so I'm going to kind of walk back that, and maybe it's there. So thoughts on Starship Singularity? Like, what does that do to our future?
It needs to be proven first, right? So I'm a bit more skeptical, right? I need to see this thing be proven because so far it has not been to orbit and landed. And that's the very first step. I think that Starship, and I could be wrong, I don't know, SpaceX's internal plans or Elon Musk's mind, but I think Starship will focus on the contracts that it currently has, which is NASA HLS and even Dear Moon as a step towards NASA HLS. There are other things that Starship could potentially do in the future, but those should be their primary concern. Is I remember back in the Commercial Crew Program days before they flew Demo 2, where they were a bit scolded by Jim Bridenstine. Do you remember that? For focusing so much on Starlink or whatever they were focusing on at the time, and not as much on what NASA was paying them to do. And I think that kind of did change their mind a little bit to really focus on. I mean, Artemis is such a huge high profile mission that I can't imagine that they're not going to focus so much attention on Artemis 3, because that is where everything else stems from. Everything on the NASA side for Artemis program will stem from Artemis 3. That's the first human landing since 1970s. Someone else tell me, I don't remember, 1970, whatever. And it is also the beginnings of them showcasing that, yes, we can land humans on another body. And remember, Elon Musk wants to get to Mars. So, I can't imagine that they're going to focus on, too much else initially. Beyond initially, though, I mean, there's so many possibilities. It's really hard to predict. So they're going to go where the market is, and I'm not them. So I can't tell you what their focus is going to be after that. But I want to see it proven first before I can say, yeah, it's going to revolutionize everything and change everything, which it could. I want to see it operational first.
Okay. Right on, right on. Thank you so much. Really appreciate that. Enjoy your time with the Brooke Owens Fellow Women this weekend. That's a terrific program. Thank you for taking time out of that to be a part of this today. Thank you. Appreciate it.
Thank you.
Okay. Bye-bye. Dr. Aldrin, glad to see you. So
I am here. I am indeed not Dr. Autry for the moment. So Greg and I just flip-flopped.
No problem at all. No problem at all. Thank you so much for being here. So slight schedule change, but we'll roll with it. It's going to be terrific. So thank you for being here. I know your, by the way, your bio on LinkedIn is pretty sparse. You're a much more amazing person than your bio on LinkedIn. So
I'm humble too.
I'm going to read the bio, but I'm going to actually ask you to fill in the blanks. Okay. It's like the bio is 3 sentences long and you're more interesting than that. So here's what the bio says, and then you have to fill in the blanks. Okay. Dr. Andrew Aldrin is currently the director of the Aldrin Space Institute at Florida Institute of Technology. ASI is a multidisciplinary institute created to advance commercial space development. He is also the director of my school, International Space University Center for Space Entrepreneurship at Florida Tech, and the Sino-US Space Policy Research Center. So please fill in the blanks because there's a lot more to it than that. Thanks a lot for being here. Appreciate it.
Okay. Well, since I'm burning Greg's time, I can take as much time as I like.
Go nuts.
So, for most of you, you sort of went to the moon, and in my case, obviously the moon came to me, kind of walked in the front door when I was 11 years old every night. So it's a little bit different perspective because I've grown up sort of in space. People would argue as a space cadet for, over 50 years now. And I've seen a lot happen, and now is a really exciting time. So what I'm doing right now, well, I just, briefly, I actually began life as a Sovietologist and wrote my dissertation on how the Soviet Union beat the United States into space, which has some meaning because it was really a story of entrepreneurship. And fast forward to today, I'm studying entrepreneurship. I think I'm training entrepreneurs. In fact, just yesterday, one of the teams that was created in the program, Greg is also a participant and sort of my co-conspirator in the Center for Space Entrepreneurship. And one of our teams actually got a NASA award yesterday called Eternal Light, and they are going to be sending an experiment to the moon with astrobotics. And for me, honestly, that's one of the coolest things that has ever happened to me, to have one of my students go into the moon. So I'm super, super stoked about that. In between the sort of Sovietology and where I am today, I had, a career at the Rand Corporation. I was an executive at Boeing. And here you've got a guy whose background is political science and business, and I was running strategy, advanced programs, and business development for Boeing's NASA, their civil business, and then later for their launch business. Then I went to ULA and kind of did the same thing there. And then Then I ran Moon Express, which is a weird, wild ride for about a year, and then tried to retire and got pulled in by my dad into Florida Tech and the things you talked about. I guess what's new right now is something that won't be public, I guess, for another month, but I am the program director of a new program at Embry-Riddle University, Embry-Riddle Worldwide. It's going to be 100% online, Masters in Space Operations. And we're going to focus on training the world about space. And the focus of it is really going to be very market directed. We've broken it up into a series of market verticals, where for each one of these markets, whether it's launch, comm, GPS, remote sensing, we break it into, we talk about history, we talk about policy, we talk about technology, operations, markets a lot. And so the idea is to train them market by market rather than discipline by discipline. Super excited about that program. And then I just started a thing with John Wensfien, who is running the Levan Innovation Center at Nova Southeastern University. He asked me to come in and help them set up a space, we call it Space Dock, but it's a space innovation center doing economic development. What we're trying to do is bring the Space Coast to the South, to South Florida, with all the dynamism of entrepreneurship in South Florida and all the technology of the Space Coast. So a lot of stuff. I'm super excited about it. And then, of course, there's the Aldrin Family Foundation that I run, which is really K through 12 education, and that's super exciting. Anyway, those are the blanks that I could fill in, but I really want to get to my story because it follows really closely with what Laura was talking about. So let me share my screen and we'll get to that.
By the way, thank you. Greg is here now, so I'm going to bring him on screen. I want you to go through your slides and do your thing, but Greg, if you could go ahead and just peek in and say hi. Take it away, Dr. Aldrin.
Oh, okay. Greg is just going to peek in. All right.
Peek in, and I'm going to kind of like bounce between the two of y'all a little bit, so we talk about education and entrepreneurship.
Okay.
And space.
I'll stick around for Greg's talk as well.
Yeah.
All right. So Laura talked about private sector going to the moon, and I'm very much in agreement with both Laura and Michael. The private sector isn't going there alone right now. We are going to go there in partnership with the government, and we are trying to do things differently. But this isn't the first time we tried a public-private partnership, and it is going to be a challenge. So, in fact, I'd argue that figuring out the economics and the policy of public-private partnerships is probably going to be more challenging than the technology. We kind of understand that. At least if we throw enough money at it, we can burn down that risk. This is a set of risks that's really different. So I just want to start out with this statement, which I didn't think was that big a deal, but I kept having my students come back to me and said, I remember you said this, and it's true. I think today we are getting closer to programs which have very little government participation, but there's still some participation. And when we talk about commercialization, there are all kinds of definitions, and Ken Davidian and I have spent literally hours talking about this stuff. And so everybody's got a perspective on it. My perspective on it, which is no better than anyone else's and probably worse than most, is risk sharing. Industry and government both have some part of the risk pie, if you will. And the degree to which government takes more risk means it is a less commercial program. The degree to which it takes less risk, or industry takes more risk, makes it more commercial. Sounds simple, right? It isn't, unfortunately, because government and industry have different profiles on risk, right? Government is worried about budgetary risk. They're worried about performance risk. Industry is fairly simple. There are two risks industry worries about. It's cost risk and revenue risk. And so if those are going to be kind of the terms that I'm going to use to talk about this in the next few minutes here. And so now I'm going to start with my cool graphic. I call it the chasm of risk, because you got a guy here with money. Hey, wait a minute, that's my dad. I didn't know he had that money. You got a guy here with money, and he wants to buy fuel on the moon. And the thing which is in between the two is a huge chasm of risk. And it's technical risk, it's financial risk, it's policy risk, it's political risk, it's all kinds of different risks, but we got to cross that. And it's worth having a conversation about that. One of the things is I talked about industry and government risk and that they have different perspectives on it, right? Industry is worried about cost and revenue risk. Government is worried about performance. Is the contractor that they deal with, are they going to be able to deliver service they have promised to the American people? And budget risk. It's cost is more a function of budget than it is of actual cost. Because if they get the money appropriated and enacted in a budget, they don't care. They're going to spend it all, right? Their incentive is to spend it all. But once you bust that budget, then you got a problem. Okay. And so we've done this before, and this is by no means a comprehensive look. I just picked a few interesting examples in the past. So let's start with X33. So the way to kind of look at this chart, obviously red is high risk, government risk, high industry risk, green is good. As you go further from here out here, the scale of the risk grows. Okay, so the X33, wonderful idea. Really cool, right? It was a prototype to a single stage to orbit vehicle, which proved to be impossible technically. The basic deal, but somehow or another, Elon's going to figure it out. I don't know that. But at any rate, the basic deal was NASA gave Lockheed, I think, about $1 billion to do a prototype. Anything over and above that, which they knew was going to be considerable, was up to Lockheed. But Lockheed took on a lot of risk. And the government at the same time kind of took on some risk as well. But anyway, what had ended up happening was technically it proved to be too challenging. Lockheed started losing a lot of money on it. They didn't see that it was going to work out, and they bailed out, which cut their risk off, right? It left the government kind of holding an empty pail. But so the X-33 program didn't really work out. In my opinion, it didn't work out because they put too much risk on industry. And when industry will get out of the program when it becomes too risky, most of the time. So EELV, personal favorite of mine because I lived through this pain. Thankfully, when I came to Boeing, I was not part of the launch business unit, but in this particular case, Boeing and Lockheed took on an extraordinary amount of mostly revenue risk. I mean, they took on some cost risk, but we knew how to build launch vehicles. That wasn't going to be the real challenge. The real challenge was, can you make money in this? And in order to make money, you had to sell lots and lots of launches. And remember, this was in the time of what I call the second wave of commercialization, when we were literally going to darken the sky with satellites. Of course, then it only took 1,000 satellites to darken the sky. Now it's going to take 40,000. But that was the story. And what happened? Boeing had a manifest of 40 launches a year. Turned out to be 4. It kind of sounds like the shuttle, doesn't it? When we originally started the shuttle program, we thought the shuttle was going to cost $8 million a launch. $8 million, right? We missed that one by a little bit. Anyway, so industry took on a lot of risk and they failed. And industry came to government and said, we're losing here. We can't afford to stay in this business. And the Department of Defense said, no, guys, this isn't like NASA and X-33. You can't bail out of this program. But what we will do is we'll restructure the program so that we will accept more risk in this program. And we will make you financially solvent from this point on. But you've already written off your $2 billion apiece. And you're going to you're stuck with those risks. And so we ended up with a program that's called EELV by 3, in which the government absorbed a lot of risk. I would argue almost an inappropriate level of risk. It was good. What was now ULA, it was good for ULA, right? Because they became profitable, at least going forward. And it was good for Lockheed and Boeing. It turned out it was bad for the industry, right? Because what ended up happening is launch got very expensive, because at this time, like I said, we were launching 4 times a year rather than 40 or 10 or something like that. On an individual basis, these launches were expensive, and it was a politically challenging for the government, in part because they busted through their budgets. We had at least one non-McCurdy breach, which is what happens when you bust through a major defense program budget by a certain amount. You actually have to declare a breach to Congress, and it's all kinds of nasty stuff. It was not good for the Air Force. It wasn't really very good for Boeing and Lockheed politically. And so we had swung the pendulum, I would argue, way too far in the other direction. So we managed to get it wrong both ways with EELV. So let's go to COTS. Let's go to COTS. When this started, there's somewhere in the catacombs and archives C-SPAN is a presentation that I gave saying industry would be crazy to take on the level of risk that they were throwing at them with programs like COTS. Well, I was wrong. All right, you can put that one down. COTS actually had a pretty good balance of risk between government and industry, and then it went to CRS, which put a little bit more market risk, revenue risk on the government side, or took its revenue risk away from industry by guaranteeing, I think it was the initial tranche was 40 tons of up mass. And it worked out really well for SpaceX, I think, because it enabled them to actually build the Falcon 9 and lots of other good things. And I think financially, it was a pretty good program for SpaceX. For Orbital, it's less obvious how great a program it was, but I would say by and large, this is a program where we got it right. We got good capability. We got it at a good price. When the government sits back at the end of this, it got 2 new launch vehicles. It got 2 new transfer vehicles. It got the basis for crew launch. It was a good deal for everybody, I think. So this is the case we got it right. And so, of course, we're going to copy exactly what we've done with this program with everything we're going to do in the future, because it's going to be easy now. Okay, so we tried commercial crew. Yeah, I am sure Phil McAllister would be throwing darts at me, probably throwing missiles at me for where I put this, but I think commercial crew put a lot of risk on industry and the way it was. I mean, because they set it up more or less like COTS and CRS, but the way it was supposed to work is industry was going to propose its standards for human rating, government was going to accept those standards, and everything was just going to go forward like it went forward with COTS and CRS, only it just didn't really work that way. And it didn't work that way because the government has a legitimate need for deep insight into its astronauts and the safety of its astronauts. NASA astronauts are not like commercial space passengers. They are different from, we can have this discussion for another hour, but they're different, and NASA cannot, and I don't think should not, absorb that risk. And so they have to be hyper vigilant about safety. And what happens when you're hyper vigilant about safety is you require more and more detailed analysis, validating the safety of it. And when you were talking about detailed analysis, you're talking about time and money. And while NASA paid for the time and money for the detailed analysis, in the meantime, you've got a standing army that's supposed to be building these things, that's chugging along at half speed in terms of making progress, full speed in terms of spending money, right? So it's a program that obviously it has not worked out very well for Boeing. And to be sure, a big chunk of that was self-inflicted, but nevertheless, in the sort of classic shuttle era cost type contracts, that risk would have been borne primarily by the government. And Boeing took the hit, and to their credit, they are pressing on, and they're going to be launching again the end of the month. Okay, but the point is, I think, and this is a personal opinion, since I don't really have any institutions, I don't represent an institutional viewpoint. My personal opinion is we got it wrong here. I really would like to. I really need to talk to more people and determine what the perception was. The trouble is, it's sometimes in a program that's ongoing, it's hard to get honest opinions from people. Anyway, next thing up is CLIPS. So, absent some other factors, I would have put CLIPS way up here, because basically what the government said, what NASA said is, we want you guys to go build a spacecraft. We're not going to tell you if we're going to we're not going to reduce your market risk at all, because we're not going to guarantee anything. We are not going to pay for your development, but we'll buy missions from you maybe sometime in the future. And that would be absolutely insane were it not for the fact that a lot of these companies had already developed systems for the X Prize. So in some way, I don't know, Uncle Google. Well, nobody got paid for the X Prize stuff either, right? The investors lost at any rate. Nevertheless, so where we stand right now, CLIPS looks like right now from this point forward, CLIPS is looking like it might be a pretty good deal. It might be a pretty good deal to get missions to the moon fairly cheaply. Just think about this, Surveyor, just the spacecraft alone, in $2020 is $600 million. And you had to put it on top of a rocket that was probably another $200 million. It's almost $1 billion program, right? And we are doing missions, CLIPS missions that are, I think we're talking 70 million delivered to the moon. That's pretty good. That's pretty good. So that's really encouraging. And then finally, so we talked about when we were bagging on EELV being all over the place. What I will say is now the Space Forces and industry, with Elon's help, to be sure, have got it about right. I think it's a good balance where that program stands right now, which is a good thing for everybody. Anyway, this whole diatribe was just to say we're all over the place. We really, I don't think we know what we're doing because I don't think we're thinking about risk sharing in methodical ways. I think you really have to segment. It's not just cost and revenue risk. There's a whole bunch of other things, but I think both sides have to understand what the other's risk profile is. And when you talk about going to the moon, you wanted to know when am I going to get to the moon on this whole thing, right? When you talk about going to the moon and generating resources from the moon, it's a massively expensive program. It's a massively risky program. It's a massively long program. And so solving this risk problem is going to be a huge deal. So first thing I want to say that we all talk about technical risk, right? Because we're space cadets and that's what we do. We talk about technology. The thing is, when you get down to it, we've had a lot of really smart people. This is a chart that was generated by some folks at SwampWorks at KSC. And Rob Mueller, I think, put this together. So I'm not going to take any credit for this. This is Rob's. But the point is we understand the risk. We understand the pathway. Any one of these may turn out to be something which is really, really, really challenging. But we've got a pretty good handle on how to get from here to there. When you get to some of the other risks, the business and government risks, I don't know that we really have a handle on it. In fact, I think we are looking at it from opposite sides. And in many ways, what government wants to reduce its risk is exactly what industry does not want. And so what I'm going to do is I'm going to kind of walk through a really crude risk burn down matrix. You got NASA on one side and you've got Lunar, our propellant depot company on the other. And we're just going to, this is hopelessly simplistic, but I think it illustrates the point. So if you start with one of the risks from industry's perspective is the risk is that development costs will exceed the plan and therefore you're not going to have enough financing. And so what does industry want to reduce this? They want the government to pay for it. At the same time, you look at the government and so they have a similar risk there, except it's not exceeding plan, it's exceeding budget. And what they want is they want industry shared investment. They want industry to basically assume any cost overruns. And these things are antithetical to the two, right? They're talking past each other. It's not to say they can't agree on a negotiated solution, but they got to understand that they're coming at it from different standpoints. Market risk, revenue risk from industry, insufficient demand. And so what industry wants from government for this, which is a perfectly reasonable thing, they want long-term anchor tenancy and they want a sole source contract. Well, the trouble is, the government has a legitimate concern over supply. If you basically do, and of course we're hearing about this now, ironically enough, from the contractors that didn't get selected, that the government shouldn't rely on just SpaceX to provide the human landing system. The government should want multiple suppliers, and they would. And we've done this with commercial crew. Thankfully, we did it with commercial resupply, and it's worked out well. The government is not going to be inclined to have a single supplier. Certainly early on in the phase, they're going to want to have multiple suppliers if they've got to rely on these companies. Once you get to operations, again, you've got a cost risk. What industry is going to want is they're going to want the government to furnish the infrastructure for them. And government wants industry to rent the facilities from them. And then finally, we get to some political risks, financing costs and availability. Industry wants government loan guarantees. Government hates loan guarantees. So here's where we end up. We're going to be yelling at each other. And until I think, my prescription is really to start the conversation between industry, government, and finance as distinct from industry, right? To understand what's the pathway to burn down risk to the point where we can get to Lunar nirvana and bridge the chasm. But I think it really does take a lot of discussion about it. And it's not simply which technologies do we need to develop. Anyway, so that's my rant. And I think we can get there, but I think we got to be smarter than we were in the past. And this is where we want to get to. This is what the next plaque needs to say instead of "we came in peace for all mankind." We came in profit for all mankind. Anyway, that's what I got.
I love that. I want to be that guy with that beer. Although
yeah, but it's a Carlsberg.
You
can't go all the way to the moon to get a Carlsberg. Seriously, it's got to be a Colorado microbrew.
Fair enough.
Okay. Anyway.
All right. Thanks a lot, Andy. Stick around, sir. We're going to bring on Dr. Greg Autry for a moment. And then we're going to just kind of riff a little bit on some of these ideas. I want to come back to your slide with the where you put some of those spots. I'm going to ask some questions about the mission slides. Okay. Dr. Greg Autry, glad you're here. Thank you, sir. Dr. Autry is the clinical professor of the Space Leadership Policy and Business at Thunderbird School of Global Management at Arizona State. It's a brand new program. We want to hear about that, sir. Thank you. He is an educator, a tech startup founder, researcher on entrepreneurship, commercial space, and economics. He's a former NASA presidential appointee, a writer and regular Forbes contributor. And I stole this off of your LinkedIn page because I thought it was cool. His goal: improve the world by educating a new generation of bold and ethical entrepreneurs, contribute to establishing a viable space economy for the benefit of humankind. It's a pretty badass goal there, sir. Thank you very much. Please, let's hear from you, sir.
Thanks, Michael. And first of all, I want to thank Andy for everything he said, because now I don't have to. He pretty well covered my shtick. So apologies if I duplicate any of that. I'm going to share my slides here and pitch what I'm doing, since Andy had that moment. And I think this is a really actually important topic here. There we go. I want to talk about something called the growing gap in space leadership that I've identified, that I know Andy is aware of. We've got what I call an astronomical need for talent, and you've probably seen a lot of cool data points like this. The space economy, according to the good folks at the Space Foundation, is $400 billion plus. And it always amazed me when I was a professor at USC for 7 years in the business school. They're trying to talk to them about launching a dedicated space management program, and I just couldn't get traction. They saw that as a niche, some teeny little niche, right? And they wanted to talk about apps and cryptocurrencies and NFTs, right? Space is already so much friggin' bigger than all that stuff, much of which is vaporware, and I'm trying to think of the nice word, but we'll just say BS. But there's a certain focus on that Silicon Valley mentality, and they totally miss the fact that everybody that's cool from Silicon Valley has been moving down to LA to start commercial space companies, like just a few miles from their institution. But anyway, I tried for years, couldn't get them to recognize this need for management leadership. Now, the good thing is that the government realized we need STEM, right? And that's been a thing for like a couple of decades, that we've got to get back on track there. We saw what the Sputnik moment and the Apollo program did for our nation by forcing a lot of young people like me to go into technology because we thought we were going to go to the moon with Andy's dad, right? And when that didn't happen, we launched software startups. Okay, I did that. Unfortunately, my software startup didn't make enough money for me to launch a commercial space program, but I got to know people who did, and that was pretty cool. Now, space economy growth, you're familiar with those projections, but I want to be clear that the crazy numbers from Bank of America of $2.7 trillion by like 2040 in the space economy, I want to be clear, that's the size of the entire UK economy. It's twice the size of the Russian economy. But those aren't crazy numbers. That's like a linear projection of growth of where we are. The potential crazy numbers are more like the size of the U.S. economy. Okay, we could be going there, right? So the space sector is already 4 or 5 times bigger than the mobile app business that excites all my friends over at USC. The B of A projection, again, mild. But what's been missing? So we've got this understanding of aerospace engineering demand, and there's been all these articles for years about how organizations are fighting for these engineers, and Congress is going to do something about it. But we need management. One of the things that I've really noticed is watching all my friends from NASA get sucked out of the agency into the commercial space sector for salaries that are way higher than even an SES salary. So, most people in government service are unfortunately locked into the GS $130,000 a year salary. If you're lucky enough to get an SES position, you get like 185. Space executives right now are being thrown for $500,000 with benefits. How do you get those jobs, right? How do you qualify for that? So there are very few people that are qualified both from a management experience or education standpoint and from an awareness of the space domain. So something needs to be done there. And Andy and I have been aware of this. We've been talking about it. We've been addressing it to some extent with the graduate certificate program we've been doing for 3 years with Florida Tech and ISU that I'm excited. I'm leaving tomorrow for KSC, and I'll see you there, Andy.
Yep.
To continue that, but we need actually dedicated programs. I am excited that students that I have worked with in the past have done amazing things. The guys at Relativity, Tim Ellis and Jordan Noon, who I had the pleasure of advising off and on since they were in the rocket lab at USC, have raised over $1 billion, right? $1 billion for the B. That's amazing. As Andy noted, some students from our last year online class are literally going to the moon with an astrobotics launch that NASA is supporting. How cool is that, right? So I think that I've had this opportunity to fix that. When I came out of not being NASA CFO, which kind of sucks to get blindsided by hashtag 2020 politics that were nonsense. I had an opportunity. A lot of universities came to me and were interested in what could be done with space management, and that excited me to see that even though the Marshall School of Business at USC doesn't get it, that there are universities around the world actually that do get it, are very excited about space management programs. So among the ones that came to me, I was most excited really about the Thunderbird School of Global Management, ASU. Thunderbird has a long history with the Air Force in particular, which I think really ties them appropriately into space. They're globalized with facilities in Geneva, London. We just opened one in Dubai, Moscow, Tokyo, Seoul. And we're excited that Thunderbird and ASU are opening a new facility in downtown LA, right in the center of the commercial space industry. It'll be the old Herald Examiner building and a Broadway and 11th. That's like, I don't know, 10 miles from SpaceX and 20 miles from Rocket Lab and Virgin Orbit and Relativity and Spin Launch and, everything that's exciting going on in that ecosystem. ASU also has this incredibly broad commitment to the space domain, so that excited me. And I thought, we're getting back to the moon. We need to have the science. We need to have the engineering. We need to have the business. We need to understand the environmental impacts, the legal impacts, and they've got that broad commitment. So I'm excited to be launching first executive master's program there. We chose executive master's because we want to put butts in the seats in January 2023. So we're launching in January. 1-year program. It's essentially the equivalent of a full master's in business with finance and accounting, but for space dedicated courses and a space context and networking opportunity to that. So if you're in Silicon Valley or some other industry, you want to get into space, it's perfect for you. If you're an engineer in space, you want management creds, this is perfect for you. That's our goal. The faculty I couldn't be more excited about. I won't pitch them all here, but go online and check it out or reach out to me and I'll connect you. As Andy noted, there are other programs emerging. I'm really excited about what he's doing at Embry-Riddle worldwide, particularly for a full online program, mostly asynchronous. That's going to provide some amazing opportunities. And we're going to still work together every summer at KSC with both our students to bring together that in-person experience and networking. That's so exciting. Definitely seen positive sounds coming from other locations. It was interesting. The USC Policy School and the engineering school get it, and they're coming together to put a certificate program someday. Maybe the business school there will get it. Anyway, that's what I had to say about that. And the other thing I wanted to share real quick, if I have a minute, is another project I'm working on with my colleague, Phil Metzger. Let me see if I can share these slides.
FYI, we've got about 25 minutes to kind of chat between the two of y'all as well.
Okay.
So we're good.
There we go.
We're not seeing anything yet.
Yeah, I am battling technology. There we go. Okay, so Phil and I have been talking about lunar landing pads, and he is a subject matter expert from the engineering side, and we've had this economic discussion about that, and I just wanted to kind of review with folks why this is a necessary prerequisite to getting much farther than CLIPS, right? As Andy noted, I'm excited about where CLIPS is going. I've been working with CLIPS teams. I'm particularly thrilled to see Maston, who came out of Mojave and who have I spent years watching, get a contract for nearly $100 million to literally go to the moon, right? And having our team on the astrobotic ride is super special. So you've got these plume effects on the moon that we've known about, since Andy's dad went there. You pick up some dust, as they said, coming down, and you're really kicking up the dust, right? You've got a super high speed exhaust plume coming out of this vehicle. It is hitting this material and sending it forward at those super high speeds, and there's no atmosphere to slow it down. So these bullets just keep going. That's been documented, and specifically was documented when Apollo 12 went and looked at the Surveyor 3 remote lander that had already been there on the lunar surface and saw what their landing did to the vehicle. They brought back some pieces of Surveyor 3 that were looked at. We were able to develop some models around that to understand what damage occurs. And basically for Artemis class landing missions, you're looking at like 50 times the damage that you got from the surveyor damage. And basically anything within 26 kilometers or so is going to have an issue. And that makes it really hard to land next to your lunar base, right? Or your scientific experiment. Or if somebody else has a scientific experiment in the center of Shackleton Crater, it makes it pretty hard to go there and get that water ice until you figure out what to do about this. So one of the things to do is cover the dust with a physical landing pad, right? And that's probably going to be a requisite for any human-sized landers that are going to routinely go to the moon. To do this, you're going to need site preparation. You're going to have to level the area. You're going to have to get rid of the big rocks. You're going to have to layer the gravel in kind of a macadam road manner to make sure that the weight distribution works out the way you want. And then what do you do to seal the surface so you don't have dust? One of the popular ideas is sintering, to essentially melt, in particular, some of the iron that might be in the lunar regolith in place into a hard material. You can do that with high-powered microwaves. How do you power those microwaves becomes a big economic issue. So the solar power isn't free because you've got to put the solar panels up there. There's a cost in time in doing any of this that delays your program, and the time cost is a huge factor, as Andy noted, on these programs where you've got a bunch of people sitting around waiting for things to be ready. You can bake pavers in an oven and you can distribute them. It turns out sintering might be a little bit easier to automate than setting up ovens and moving material into ovens and moving bricks out and laying them, but there are advantages to both. You can also spray plastic polymer and heat that in place into the soil and make kind of a composite plastic concrete. That works well, particularly in the outer pad where the plastic isn't directly hit by the heat of the rocket exhaust. So we're developing 4 different economic scenarios. I'm working in particular with Phil to work in the opportunity cost of delay on this program. What is the program worth, right? And what is the cost of every time you delay, and the energy costs that drive each of these solutions to help develop an optimal program. And it's the sort of combination of engineering and management that I think that needs to go into these things when we go commercial, because it's not going to just be a government program forever where we can say it's 1,000 times over budget like the space shuttle, and that's okay, right? Because it's a cool national agenda. We're just going to eat that. That isn't going to work anymore, and it is time to start thinking economically. So with that said, I'd love to just engage with Andy and whomever in conversation.
Terrific. Thank you so much. I mean, there was a lot in both of your presentations. I want to swing back to something that Andy said a minute ago. I personally, this is me speaking, I don't like the name New Space. I think it doesn't mean anything anymore. It was the phrase du jour 10, 15 years ago to describe the cowboy minority that was trying to commercialize space when there wasn't really a term for it. I think we've kind of gone past the usefulness for that phrase, but there isn't really a replacement language for that. Andy talks about risk in a couple different ways. I've been
That's my car. Go on.
Oh my God, that's epic. It's still wrong, but it's epic. So I've been kind of flirting with this idea that's not really fully formed, but that there's this spectrum of risk space moving towards safe space, right? And I'm going to use the example of SpaceX. When they first started and they were still blowing up rockets, they were solidly in the risk space category, right? But as they get better at it, as they get contracts, as they come in with Air Force contracts and eventually NASA contracts, they move out of the risky side and into the safe side. Now, there are still elements that they're taking on internally. So it's a spectrum. There are, Starlink was solidly risk space. for a long time. Now it's got some government contracts from Canada. So it's a spectrum there. And then, relativity, your friends, Dr. Autry, they started in the risk space entirely, and they still are mostly in that area, right? So is new space a useful term anymore? And if it's not, which I don't think it is, what can replace it? Because trying to talk about commercial space doesn't really feel accurate anymore.
Yeah. I have to say the worst thing about the phrase commercial space is that whenever I say it in a business school, they think I'm talking about developing strip malls, right?
Absolutely right. Yes, absolutely. I see. When I tell people I do space research, I actually use my finger and I point up because everybody thinks I'm doing real estate.
But space people don't get, because in our domain that works, just like they think crewed space flight makes sense. But when I say crewed spacecraft to the general public, they think I mean an unsophisticated, old, broken spacecraft, right?
So our language doesn't fit what we're doing anymore.
Yeah. Now, new space means nothing to them one way or the other, so they don't get it wrong because they don't know what it means.
So I'm not. I'm not going to burn too many calories trying to figure out what we're going to call it. I'm more concerned with what's happening, and Michael, you're hitting on a really important point, and I think that Eric Berger's book is really, really instructive. I would cast it a little bit differently. It's more of a learning process that SpaceX went through, because what they were doing wasn't, it was risk space, but let's be honest, a lot of it was dumb space. Okay. They were just making absolute rookie mistakes. But they learned fast. And in some ways, what they're doing is coming from a place which says, if you need to do something in terms of improving reliability, it has to buy its way in. And that's what's happened. But they've worked from a zero base to a place where they can still do a lot really quickly, but they've become a lot more like Boeing, ULA, whatever, than they were in the past. Right. It's a lot easier to do it from zero to where they are than where ULA is right now, trying to go from where they are, right, which is a whole lot of risk mitigation. And now you have to start peeling that away. And that's hard to do, particularly when your customers are going to question each and every risk that you peel away. So, maybe that's a better way to talk about the process, but I think it's hugely important. And if there is something which really represents a paradigmatic shift, that's it right now. We talk about a paradigm shift being one where we go from a government financing, government risk-taking, to commercial financing, commercial risk-taking, commercial markets. But I actually think the processes have undergone a greater change than, if you will, the top-level economics of the industry. And I think the top-level economics will probably follow that. But to me, what's important is the processes. You guys can call it whatever you want to call it, but there is. It's sort of Bob Dylan. There's something going on here, and we don't know what it is, do we, Mr. Jones?
Yeah. Well,
I'd like to see what the audience thinks about Andy's suggestion of dumb space, but I do think it's really important, because not what you don't know makes you powerful, right? So, the SpaceX people, and I have to recommend Eric Berger's book as well. It's fantastic. That said, the SpaceX people didn't know what they couldn't do as much as they didn't know what they could do, and the power in that is huge. And in any disrupted industry, that's been the case. That's how Apple got to where they were, because Jobs and Wozniak didn't know what they couldn't do, and it turned out they could do a lot of those things they couldn't do. So we've got to allow that, and X space, maybe experimental space, that it's that nature of experimenting and risk taking that's super critical.
I like X space, experimental space. That's interesting. So when the markets kind of determine some winners, right? So your buddies again at Relativity. I would say all of the SPACs that are coming online, every one of those folks have governmental contracts that stretch out years into the future, and large governmental contracts, right? So nobody in this risky side is getting SPACs, right? They're not getting these market buyouts just yet. Momentous has, I don't know, $100 million on the books in booked revenue. That feels like it's not risky anymore at that point. I mean, I think what everybody in this whole field is doing is risky, but it doesn't feel like it's quite the same financial risk.
Well, but it is when you value the company at $4 billion.
Yeah.
I mean, we did an analysis of what the real serviceable market for small launch is. I mean, I'm going to pick on small launch because I just did the work. And it's really maybe 120-ish launches a year, given what we know about future markets. That's not to say there aren't some events that could result in a dramatic shift. If you take that market and you make some reasonable, actually I'll make some unreasonable assumptions, like 35% profits, and you do an NPV for the entire industry. Assume one company takes over the whole industry. It's a negative NPV, even if you're looking at 10% returns.
Yeah, and so Michael, I got to say, you said succeed in the market or whatever about relative. I mean, there's the investment market and then there's the actual market. Now, the customer risk has been mitigated when you've got government contracts theoretically, but that doesn't mean that these companies are actually going to be able to deliver on those contracts. And I already know companies that have contracts in hand from NASA and DoD that are not going to deliver. I can tell you that. I won't give you any names. They're either going to be late, very late, or incapable of delivering on what they promised. Okay, this exists, right? That's out there. And then when you look at Momentous, they've got political risk that goes way beyond the technical or the customer risk, right? And so there's a lot of different factors that all have to be combined, which is why a broad management thinking is critical. You can't just silo this, look at it from engineering, look at it from finance, or look at it from management or politics. It's got to be across the board.
And it's not just, we need to have better managers. We do, absolutely. But we also need better people, better knowledge in the financial industry. I mean, it's not the manager's fault that they got valued at an astonishingly high. I mean, it will be the manager's fault if they squander the money.
Right.
But I worry about that. That's a different question. We need to do a better job of educating the finance community. And, we all talk to them, and they either come in like two flavors. One is, I really don't understand space, and so I'm just going to stay out. Or they say, it's a rocket. I want to buy it.
Right.
And rockets are good. More rockets, more rockets.
150 rocket companies is a lot of rocket companies right now.
Yeah. Let me do you all a favor, investors. Do not invest in any more rocket companies. That said, they want things they can go to a cocktail party and talk to the opposite sex about in a cool way, right?
We had recreational investors at MoonX. I'll just say that.
So let's focus back on the moon, right? If rockets are not the right investment right now, what things are attractive about going to the moon? It's harder than going to Leo. It's more expensive. There's maybe currently less things you can do there that have relevance back to Earth. So let's talk about the business of going to the moon, because so far as I know, no one's really figured that out yet.
I think there is a there. Sure. I mean, I think ULA makes a reasonable case, and I think there is in general a case that says propellant, if you can develop it on the moon at a certain price point and deliver it from the moon to anywhere in cislunar space, potentially could revolutionize space transportation, in space transportation. In fact, I think you could argue that the way we're really going to solve the problem of launching from the Earth is by launching from the moon. So there is value at the moon. For the moment, at least, forget about the other resources and things like that. But rocket fuel, we know what to do with. We know there is a market for rocket fuel at a certain point. And cheap rocket fuel in space can enable a transportation system taking things from LEO to GEO and other places, which conceivably could make the business case for things like space-based solar power look a lot more attractive conceivably. So, I mean, I look at the moon as potentially being transformational. The problem is there are so many things that have to happen to make it work, but there is a there. But as far as, you're talking decades. And so once you discount out the value of a dollar spent today, it's a tough business case without a lot of government participation.
It's a tough business case because investors don't want to invest in things that aren't going to happen or deliver in their lifetime, probably, right? And that's just human nature. Now, the good thing, though, is government participation is almost ensured as long as we have Cold War 2.0 going on. Which is a huge benefit to us, as it was a huge benefit back in the 60s for the Apollo program. So as long as the US government thinks that they've got a resource race going on the moon and a territorial race, frankly, then you've got the opportunity to continue to have that anchor customer in place to get to the economic closure that Andy's well aware of. And, just water on the moon as a propellant for electric propulsion systems in cislunar space is huge. If you make hydrogen and oxygen, that's huge too. If we're really ever going anywhere past the moon, it's going to be necessary. But you've got those asteroid cores sitting on the moon. There's probably plenty of metal. It's a lot easier to get it off the moon. Mm-hmm. It's a lot nicer place to extract it. It's a nicer place to do the manufacturing than strip mining, say, the Amazon rainforest and setting up smelting here on Earth, right? So in the long run, I think we get that. There is a there. It's just the time frame there. That's the question. And unfortunately, we're not going to have a constitutional amendment that changes the nature of the United States government from this 2 and 4 year cycle. So that external threat is golden. So, Chinese, Russian, moon base, perfect. I hope they add the Iranians and North Koreans soon.
It's sad, but it's true. And one of the things as a community we need to be thinking about is what do we do with it? I mean, there is going to be a competition on the moon for precious little bits of property, and governments will spend a lot to do that.
Well, and ironically, my space friends in the community that love this kumbaya cooperative sort of thing, and we need to work with the trades, that'll actually just kill the program, right? It will go nowhere fast in that mode. The competition, as long as it's positive competition and not actual conflict, is a beautiful thing and always has been.
I agree. But we need to be aware of it as a community and ensure that the things that we do leave behind or create the infrastructure we need to do real lunar development.
I was super excited that the new Appendix N that came out from NASA a few weeks ago used the word sustainable and sustainability all over the language, which is critical because we don't have any vision past Artemis 3, and we need to get clarity there.
Yeah, absolutely.
We need more than language. Right. We had plenty of language in the Apollo era.
So let's go into specifics, and we only have 4 minutes. So I just need some last thoughts on the CLIPS program. Andy, you kind of said, you put it in a different spot on your diagram than I would have put it on. So I'm curious, let's talk about CLIPS in a little bit of detail. Where are we going with that? Is that a model that we can rely on for active development to the moon? And me too. I'm a big fan of Astrobotic. I've been watching them. I was a 2-week employee for a consulting contract for Astrobotic at the very beginning. So I always root for them. So what are your thoughts on CLIPS?
I think it's a good transition program. I think it gets NASA cheap rides to the moon, relatively cheap rides to the moon. So it's a good program. Long term, it's not clear. I mean, at some point you'll be able to buy rides to the moon the same way you buy launches. What we don't know is whether CLIPS will really develop that part of the industry, but I think there's a reasonable shot at it.
Yeah. There are two futures in space. One where Starship delivers what it promises and on time, and another one where it doesn't. And that really changes everything long term. In the short term, CLIPS is a beautiful thing. I think there are actually closable business cases of in the many hundreds of millions of dollars for CLIPS vendors in the short run. And these are surprising things like lunar sample return for jewelry, the moon rock.
We talked about that at MoonX. You can sell that jewelry once.
No, you can sell it more than once, but you can only sell maybe 100 kilograms or so, but it's still hundreds and hundreds of millions of dollars. Lunar burials, proven demand there, and I don't think that ends. So there are these interesting little business cases. But again, if all of a sudden we're delivering hundreds of tons to the moon, everything just changes. And so we got to watch that play out.
So I would just conclude.
Wait. That was like a movie scene, right?
Yeah.
You're comment. You're both
if I told you who it was, I'd have to kill you.
You're both being a call at exactly the same moment, and I'm not. So I'm like, wow, it's the rest.
So Greg mentioned sustainability and the importance of that. I think the major difference between today and Apollo is there's the potential for a sustainable presence, but the statement I'll make is we will have a sustainable presence on the moon when we make money on the moon, when we make enough money on the moon to justify the continued infrastructure. And once we get there, we will be on the moon forever. If we do not get there, we will inevitably abandon whatever's on the moon because we're going to go to Mars.
The U.S. government believes in sunk cost. All the way back to when I was on the 2016 transition team, it said, put the stakes in the ground so that Congress can't back away from it. Put some friggin' hardware there. You have to maintain the ISS. Beautiful example. Once you get that going, Ted Cruz or somebody will defend it until the end of time.
Yep.
Sure.
Last question. Put on your future hat here for a second. 2035. How many people will be living on the moon? Put a stake in the ground.
I'll just tell you, I don't have a clue. I can tell you
Really?
what the events are that would have to occur in 2030 that would lead me to one direction or the other, but there's just so much uncertainty. I don't know. It's either 100 or none.
All right.
So it's either 100. It's either 100 or 5.
Okay. I like those answers. I can live with those answers. Those are good. All right, gentlemen, super appreciative that you are here today with us. Those programs that you showed, I think are necessary for the ecosystem to grow. You've got to have good people if you're going to build good programs. So thanks a lot. Good luck on your programs. Safe travels, Dr. Rautry. You're flying also tomorrow, Andy. Yeah,
Absolutely.
yeah, right on. All right. Safe travel.
Casey.
Have a great summer. Bye-bye, y'all.
So long.
All right. Well, that was fascinating. Thanks everybody for that. We're gonna shift gears to Raphael. Are you here, sir?
Yes, I am. How are you?
Excellent. Terrific. Pull up your screen. I'm going to read off your bio. I for the record, I'm going to stick with 100 people on the moon in 2035 or more. I'm not enough of a pessimist to think it's only 5, but I think I see where they're going with that answer. Let's see. Raphael. Rajan is the managing partner of E2MC Ventures, space-focused venture capital firm. He is also the author of, I don't know how to pronounce this, Hoke Hines. I'm guessing at that. You'll have to,
yeah.
Henas, okay. I don't know what that means. You're going to have to answer that. It's an introductory book on space business lecture. He lectures on space entrepreneurship at several universities and hosts the Space Business Podcast. Both I and James Burke of the Moon Society were on his podcast in the last couple of weeks, so that was really fun. Raphael is a chartered financial analyst. He invests in space companies. He is the author, I just said that, the host of Space Business Podcast and contributing editor to Space Watch Global, also an ISU alum. He's a partner in Space for Impact and lectures on space finance and entrepreneurship at several universities. Thank you very much, sir. We're going to bring you on now. I'm going to be quiet. Thanks a lot.
Great. Thank you, Michael. So let me share my screen. A second. Okay, I hope you can see that. Can you all see that? Okay, terrific. So I put it on full screen as well. Okay, and by the way, it's great to see so many ISU people. So I actually quickly changed my shirt and put on my ISU swag here. In any event, so I titled my talk Opening the Moon for Business, which I think we all want to do here. And if you're a science fiction fan like me, you may recognize the cover picture here. This is from the movie Ad Astra. This is depicting the moon base. And I mean, there's obviously many depictions of moon bases in science fiction, starting with, well, not starting with, but for example, as early as the movie 2001, A Space Odyssey, Clavius crater base, right? But what I really want to point out here, I really like this picture, right? Because you see clear signs of commercial activity. If you zoom in a little bit, you can see, I'm pretty sure it's a DHL sign, right? The yellow sign in the middle. And then to the right of that, which I like even more, you have the cowboy, right? I think it's in the US, it's called Vegas Vic, right? Which is probably, I'm pretty sure, is some sort of like nightclub or bar or something like that. And I put this here because we probably all agree, well, I'm not sure we all agree, but probably many people think this is where we want to get to, right? This is the easy part, this is the end goal. The question is, how can we get there? You already went to my background, so I'm going to skip that. So what we have done so far, I mean, I think everybody here on this call, this type of conference knows we've done the so-called flags and footsteps missions, 6 successful moon landings, crewed moon landings, 12 people who walked on the moon, all male, all American. The longest time we spent on the moon surface, 75 hours, so really not a whole lot of time. And we brought absolutely everything that's necessary to survive there, mostly in the form of the lunar module. We've done even more uncrewed missions. I think just the US has done, I think, way over 30. The USSR has, and Russia have also landed on the moon, China as well. And a lot of other nations have either flown around the moon or tried to land, like recently Israel and India. Okay, but again, the flags and footsteps is what we had so far. There might be an intermediate step, which I would call like the research station type presence. And on the top here in the middle, you have the South Pole Research Station. And then I'm sorry, on the bottom, I couldn't find a good science fiction depiction of a research station on the moon. This is from the movie The Martian, as you probably know. And on the right, you have, again, a depiction of from science fiction of what a future bigger lunar base could look like. This is from one of my favorite TV series, The Expanse. So you see the base on top, and on the bottom, sort of the type of activity I think we ultimately want to be able to enjoy on the moon as well, just having a nice drink with friends. But again, the question is, how do we get there? And so on this slide, I basically added to the same categories the type of people who would go on these missions. So flags and footsteps, there was obviously professional astronauts. For the research stations, presumably it would be scientists, maybe some service staff to run the station or protect the station, and possibly some high-end tourists. Of course, once we really get to a self-sustaining settlements, the idea is that we would have average people there, and that maybe tourists or maybe people who work in some sort of function on the moon. Okay, moving on, adding another aspect here. So what do we need for this different type of missions? For the flags and footsteps missions, we basically need that and still need a transport capability. Once you move to research stations where people may stay a little bit longer than the 75 hours, that was the longest time during the Apollo missions, well, we will need basic infrastructure, life support systems and so forth. We'll get to that. But then for the self-sustaining, sustained presence, we really need a reason to come and ideally to stay. And we'll talk about that. So let's go through all of these different elements. So starting with the transfer capability, and I'm pretty optimistic. I mean, it looks pretty good. I mean, on the left, you have the recent Chinese, obviously uncrewed lunar lander that actually brought back a sample. And it seemed so routine, it seemed so easy the way they did that. And of course, on the right, and with apologies if there's anybody on the call from the national team or from Dynetics, but it's obviously the Lunar Starship. And yeah, excuse me, I'm a SpaceX fanboy, and may I say I also pay taxes in the US, so I'm a fan of the SpaceX Lunar Starship. And so I think, as I believe many people on this call share this opinion, you keep on talking about the Starship singularity. This really would make a massive difference, the type of transport capability and capacity that Starship would represent to the lunar surface. So pretty optimistic on transport capability, to be honest. Okay, talking about basic infrastructure, starting with this slide, that's just reminding people that the moon is a harsh place, and this is why you need some special infrastructure. Actually, the distance, the travel time, and the communications latency, I'm less worried about. I'm a big fan of studying history. And if you go back to the time of the exploration of the Earth, or even like just some 200 or 300 years when we used to go to places like, let's say, England to Australia, well, that was a 6 months journey on a ship. And the communications delay was basically 6 months. So the moon with today's technologies, that's pretty good, actually. Of course, some of the other stuff is pretty harsh, really. Like there's no air, the water is in the form of ice, there's definitely no food there right now, and the temperature swings are pretty brutal. You're in a hard vacuum, there's lots of radiation, and there is microgravity, well, 1/6 gravity on the Earth. I put the mass values for reference as well, but I think probably most people on this call are familiar with these values anyway. But of course, because of this harsh environment, we need basic infrastructure if we want even an Antarctica-style research base there, right? We need energy. That's probably the most elementary need of them all, because that drives everything else. We will need environmental control and life support systems, or ECLIS as we call it. If we want to do anything more interesting, we will need communication systems, navigation systems. I forgot to put it on here, but probably a sort of systematic remote sensing capability around the moon so that we can observe things. Launch and landing facilities, spaceports, whatever you want to call them, or just pads, whatever. Habitats, well, kind of buildings, right? Habitats for where crew could live, or storage facilities for food, or greenhouses. Medical attention, because it is a few days back to Earth. So if there's an emergency, you will want to be able to at least take care of some medical emergencies. And that's actually the reason I put the picture on the left. That's sort of an interesting story that some of you may know. This is a Russian guy called Rogozov, who was and he got, so he self-operated. That was really the only choice. This is probably a remote place like Antarctica or the moon. You do want to have some medical.
Raphael.
The last bullet point here is, which I just put into infrastructure. Yeah.
Your audio is cutting in and out a little bit. Could you just repeat that last section? You came back on. I'm going to turn off my video to lower bandwidth. For folks that don't know, he's coming to us from Switzerland, so appreciate the distance. But I'm going to turn off my video so that clears up some of the line. Okay.
Yeah. Let me switch to, give me a couple of seconds. I'm going to switch to another, unless you can hear me well right now, I can switch to another network as well. It's good? Okay. So I don't know where I cut out, Michael.
Just start on this screen again.
Okay. So this is basically going through the infrastructure requirement, even for an Antarctic style research station. So energy is sort of the most basic of all, which drives everything else. If we have a crewed presence, we certainly need environmental control and life support, so what we call ECLIS. If we want to do anything more interesting on the moon, we probably need a communications capability, a navigation capability. I didn't put it on here, but I forgot, but probably a systematic remote sensing capability. Launch and landing facilities, a range of buildings ranging from crew habitats over storage to maybe greenhouses, and the medical capability. And that's the reason the picture is here on the left, which is a Soviet guy or a Russian guy called Rogozov, who in the 1960s was at the Antarctic Research Station of the Soviet Union. And he was the only trained physician. He got appendicitis, so he had to self-operate. And so this is just to say that it's probably good to have some basic medical attention on the moon as well, which is a few days away from Earth. And the last point I put is it would be nice to have just the publicly available data on the moon. And this is why like efforts like the Moon Society's wiki, I think those are valuable efforts. Okay, so this is the infrastructure part. Let's move on to the next part. If we really want to sustain present, we need a reason to come and to stay. I'm going to start again with science fiction and an anti-example. This is from, again, if you know science fiction, this is from Man in Black 3, where you have a maximum security prison on the moon, but I think that's ideally not the use case we want, even though there is, of course, terrestrial precedent with the exploration of Australia. Let's talk about some other use cases, and many of those have been mentioned already so far by previous speakers. I mean, science is an obvious one. Testing, the moon as a testing ground for deep space, a staging location for other locations. I mean, it's just significantly easier to get off the moon surface than the Earth surface. It's much less of a gravity well. Natural resources has been mentioned a few times. I mean, there's obviously the water ice, which you can process into hydrogen and oxygen, which you can use as rocket fuel and oxidizer, or we can use it for the oxygen for life support as well. And for this natural resource case, it's really quite interesting, right? Because again, that's where we look back at Earth's history, and we have a lot of precedent, a lot of settlement of certain regions in Earth originally occurred, at least helped by natural resources. So the various gold rushes, right? The California gold rush, the Klondike gold rush in the North Yukon, even including some very harsh regions. For example, there's an archipelago north of the polar circle, which is called Svalbard, originally settled as well for things including the exploration of natural resources. Tourism, entertainment, and I put the example here of some people planning a remote controlled car race on the moon, but I think there could be many other examples, maybe sports and some other things. Funny enough, we just mentioned in the last, I think, discussion, the collector's items. And it's really interesting to think what else. We need a killer app for the moon. And of course, the pictures here, I already mentioned the car race, and on the left, it's the tourism example, right? That's Yusaku Maezawa, who paid SpaceX a lot of money, not disclosed, but you can sort of triangulate. It's probably in the hundreds of millions of dollars to do an Apollo 8 style mission on Starship in the next few years. Okay, another thing, it's not exactly infrastructure, but I'm going to mention it at this point because it sort of fits in. If we want investment with sustained presence on the moon, we also need, as an investor, I want to have sort of governance. So it's a stable business. And that can basically happen in a couple of ways. One is you have an agreed and accepted legal framework, but very importantly, and for example, like the Artemis Accords, but very importantly, you need an enforcement capability. Like one of my nationalities is Brazilian, and without picking too much on the Brazilians, we have a lot of laws. The problem is many of them are not enforced, and let me tell you, it doesn't work. So the laws are useless unless there's an enforcement capability, and maybe it's going to be Space Force, maybe it's going to be something else, but you do need the enforcement capability if you use that route. The other way to get to some sort of government/security, which I probably prefer because it's not dependent on governments, is just game theory. And that's to some extent the Wild West. And on the left here, you have the Mexican standoff scenario, right? It's just, I'm not going to do anything bad to you because if I do something bad, you're going to do something bad to me. And in the end, we will both lose out and both of our businesses will suffer. But a general point being here, a stable environment for business in terms of government security, that's important. Okay, coming back to the slides where we had the various types of missions and where we want to get to. Now, if you look at the last row, I basically, the last row here is meant to indicate where the financing is most likely to come from. So the flags and footsteps types missions, of course, it's mostly, if not exclusively, public money, government money. If it's a research station, it's probably mostly public. Maybe we have some public-private partnerships as commercial actors get interested in testing a few things, having minimal viable products, having proof of concepts, in anticipation of then a bigger lunar economy, which should really be driven mostly by private actors. And so let's look a little bit at what how private investors might be motivated. Of course, my main role, as Michael said in the introduction, is as a space venture investor, so I qualify for that. And so here I put the investment criteria we use internally at E2MC Ventures, which is a seed stage space investor. So it's not necessarily the best example for the moon, but in any event. So let me just quickly run through those. We look at the team. And the team, it's important for us that somebody knows what they're doing also on the technical side. So if we had to look at the moon company, we would want to have somebody who understands the moon aspects. But there are people like that around. Not too many, but we can find people like that. The second point is very complicated for the moon right now, which is the market potential, precisely because we don't know yet what the really viable commercial business cases on the moon are. Nothing is proven yet. So one slight way around that, I wouldn't say it's cheating, but it's a way around it, is that we sometimes look at is companies that have what I would call a dual use type business case, and not dual use in the usual sense we use it, like civil and military, but dual use in the sense that, well, maybe they make a product that will ultimately be very helpful on the moon, but we can also sell it to terrestrial customers in the meantime. And there's a few examples like that, like mining equipment or turning panels, a regolith into solar cells. So these dual use, they may be invest. Sorry, I just got a message. My internet connection is unstable. Am I still there? Can you still hear me?
Yes, I can hear you. It is a little crackly
Michael?
sometimes, but mostly I can hear you.
Okay, just check. You can't hear me, obviously. Just scream. Okay, moving. Technology, that's obviously going to be case. We want to see that there is a through business model. The next one, exit potential, the big question mark at the moment for the moon. Ultimately, what could be the exit route, whether it's a sale or a listing for those companies. The execution plan, I'm going to come back on the next slide. The main problem there is the time frame for most lunar businesses. Moving over to the right column, de-risking elements. That could be, for example, the public sector supporting it in some way with non-dilutive financing or loan guarantees or being an anchor customer. And that's very, very important, I believe, for the moon, as many other speakers before me have already indicated, and I'll come back to that. A portfolio fit that's specific to our fund, so I won't go into detail on that. Our ability to add value is also specific to our fund. Co-investors is also less relevant. Positive impact and gut feel. Okay, so really the main problem here, if you look at our typical investor criteria, and the reason probably we haven't invested in any lunar company yet is, and that's probably, I suspect, similar for most other space investors, like Michael on this call here as well, Michael Mealing, is the market potential and what's really a business case. Okay, in a similar vein, I put down some typical investor concerns when we talk about investing in space. And this is from our experience when we go fundraising as a venture fund as well and try to convince potential investors to invest in our fund and in the space and thereby in the space economy at large. I mean, it's deep tech, right? And that's just generally some people are scared that they don't understand it, and that's fair. The second point is valid for lunar, for many lunar business models. They can be very capital intensive, of course. It costs a lot of money right now to take 1 kilogram to the moon. It still costs millions of dollars. The third bullet point we already mentioned, this is the long time frame to revenues and then to exit. And that's probably the case for pretty much any lunar business we can think of right now. And keep in mind, you may or may not know this, but for like a fund like ours, a venture fund, most venture funds, sort of the upper end of the lifetime of the fund is 10 years. And I mean, there's 1 or 2 funds out there which have 15 years, but that's then really the upper end for what typically be 7 to 10 years. So, and really, ideally, you wouldn't want to be able to exit your investments in that time frame again. Otherwise, it gets complicated. And this is another complication when we talk about lunar business models. Certainly, scarcity of successful exits today that used a general bullet point concern people had about generally the space sector. Recently, that's gotten a little bit better, largely thanks to SPACs. But certainly, since we haven't seen any lunar company SPAC yet, arguably, it's still a concern here. And the last bullet point, that's actually not relevant for lunar companies. Okay, so the question is then, what can be done given this reality that I just laid out and these various concerns? What can be done to still incentivize private investment on the moon? For me, and this has, again, I'm not the first one to mention it, this conference is it's about de-risking as much as possible. So, and this could be, and de-risking, this will be mostly by governments and government entities, right? It doesn't have to be, but probably mostly. So, for example, providing and financing the basic infrastructure we talked about. Like most basic example would be like an energy and life support infrastructure. Providing a business-friendly framework. So this is what we talked about, a legal framework or an enforcement capability. Acting as an anchor customer. Also, other speakers have already mentioned it. Acting as a co-investor. And providing any sort of other incentives, tax credits, favorable labor laws, maybe some sort of regulatory arbitrage. You're allowed to do something on the moon that maybe on Earth in certain places you're not allowed to do. I'm not talking about really bad examples, but just something maybe that on Earth people wouldn't want it in their backyard, but on the moon the backyard is much bigger. Subsidies, and maybe we should think about something like a lunar development zone where we basically combine some of these incentives, and then encourage you to think of what else we could do there. And once though, because I'm very much a free markets guy, once the governments have provided this de-risking, I also very much believe they should get out of the way and just let entrepreneurs do their thing, because usually that works. Okay, and so who can help with all of this? And this is mostly focused on sort of also where can the financing come from? And of course, governments in their various forms, whether it's space agencies, military agencies, or other entities, that's obviously a key one. It could be multinational entities, like we have the European Space Agency here in Europe. We talked a lot about public-private partnerships already. There could also be private consortia. There could be individual private actors who just really want to use their wealth. And that could be companies or individuals who want to use their wealth to advance the lunar economy. Or the crowd, like really people at large, retail investors, many, many people combined. And I put a few pictures here on the right, basically to give some examples, and you may know some of them. On the top, that's one of the dams of Tennessee Authority. Place. On the right, Big Five, which is from the history of basically the 5 companies which were active in sugar production. And to a large degree, they developed a lot of the economic interest of it because they do the sugar production. Also became almost a cartel and exerted a lot of influence, but I put there anyway as sort of a private. On the left, and this may be hard to read, it's a stock certificate of something called the South Sea Company, which was around 1720 was the peak of this company in the UK. And it's one example of when we're still in the period of exploration on Earth, and very excited about exploring.
Drat. So we'll try and get Raphael back as quickly as we can. I don't have a lot of control over the connection. We'll just pause here for a minute. Pretty fascinating stuff. As an investor in this field, he has some very difficult challenges that he has to overcome, right? Of all the pitches, and he's told me he's had hundreds of pitches, trying to figure out what to write checks for, what are neat ideas but not really investable, those kinds of problems he encounters all the time. Hey, Raphael, I'm going to ask you to go ahead and keep going with your video, with your presentation, but I'm going to ask you to turn off your
video.
Video, yeah. See if that.
Yeah.
I was just killing time for a second, saying that you had some difficult decisions to make when you're trying to figure out what's investable and what's not investable. So please continue with your slides.
Where did I cut out, Michael?
On this slide, we heard a little bit about the 5, I think you said sugar.
Oh, yes. Okay. That's fine. I'll pick it up there.
Yep.
Apologies. The Swiss internet is definitely not as good as usual.
Yeah, no worries.
I switched to my mobile network, which is Google driven. So hopefully it's going to be better. So and let me put this full screen.
And FYI, we only have about 5 more minutes.
That's fine. I'll get it done. Okay. So Okay.
Terrific.
All right.
Terrific.
So the big five. This is from the history of Hawaii. Those were basically sugar barons, and they arguably contributed a lot to the development of the islands because they had this business interest in sugar. It's probably a controversial example because they also exerted a lot of political influence. Were probably a cartel, but I put it here anyway as an example of a private consortium helping to develop a geographic place. On the left, the thing in sort of the light brown, you may be able to read it. It's a stock certificate of something called the South Sea Company, which was a listed stock in the UK in the early 18th century, the peak around 1720. And it's an example of several bubbles we had in the early stock markets, which were all companies where people got really excited about exploration on Earth of a certain region. So the South Sea Company, and this is going to be a really sort of like politically bad example, they actually got a monopoly on the slave trade to certain islands. But there's other examples. There's something called the Mississippi Company, and as the name implies, this was a lot about the Mississippi region and specifically about Louisiana. And there was also something called the Bengal Company, which, as the name implies, was about the exploration of the Bengal region in India. And all three of those stocks went through massive bubbles. On the South Sea Company, Sir Isaac Newton, Space Connection, he lost most of his wealth in that bubble when it burst in the end. But this is just to say, people, in the end, retail investors can get very excited about these opportunities, pour in a lot of money. And remember, that money may not be lost. It may actually get invested in those projects, and those projects may leave behind assets, developed assets, which are valuable for those regions. And of course, we've already mentioned the SPACs right now. I'm not saying for a moment that the SPACs are a bubble, but I mean, certainly it's fair to say that the SPACs have generated, the 11 SPAC announcements we've had since Virgin Galactic have generated over $5.5 billion of financing inflow into the space sector. And the last thing on the lower right here is just for fun. A few years ago, I wrote an article arguing we should issue a Mars cryptocurrency to help develop the basic infrastructure on Mars. I put here as the last bullet point that the key is to actually educate all of these groups, governments, private actors, companies, retail investors, and I'll come back to that because I really believe that. Okay, here quickly is something we developed internally at E2MC, my fund, recently to explain to people why the space sector is in such a good moment right now. And if you start on the left, we think there have been some elements which really gave the impulse to the new space economy. And this was a combination, we believe, of government support, the government really doing partnerships with commercial actors, giving out large contracts like commercial resupply, and of course now with the Moon CLIPS. And cost decreases via technology, so reusable rockets, CubeSats, and other things. And those initial impulses basically meant that suddenly a lot of business models became much more financially, economically viable than before, and some of them successful. That caught the attention of investors who started pouring in more investment money into space, but also of talent, of people who thought, well, maybe I should be a space entrepreneur. And both of these things have effects. You get the entrepreneurs coming into the space sector, you get the money coming, and that money that doesn't remain idle, right? This additional investment, it gets used for something, mostly for further research and development or for scaling up operations. If it's further R&D, it'll probably improve the technology even further. If it's used for scaling up, it's going to improve the economies of scale. Either one of those two will mean that economics improve even further, making the business models and new business models even more economically viable. And then you go into a vicious circle. And this is really, hopefully, the really positive virtuous circle we're in right now in new space in general. But I do believe, and so I've taken the same slide and modified it for the lunar economy, that we can have a similar thing with the lunar economy right now, that if we do it right, let's create a virtuous circle. And if you start again on the left, two elements. One would be sort of the actions by government. And again, the more they can de-risk it for private actors, the better. And then, of course, we have technological innovations as well. And the one we keep coming back to is what we call the Starship Singularity. And then with those two impulses, hopefully we could start the same virtuous circle of more and more business models becoming viable on the moon. And of course, there's also network effects between various business models, which is not even portrayed on this page. So in summary, what I would encourage all of us to do, right, is things like educate as many people as possible about the moon, because the various people, the investors, the politicians, the retail investors, they can't do anything if they don't understand the moon, right? So get them excited, be optimistic. As a venture investor, I'm always optimistic. I'm always thinking about, well, what if something works? And less thinking about, well, what if it doesn't work, right? Because I'm much more worried about missing something really, really big, then something going wrong. Something goes always wrong in venture investment. That doesn't mean we have to be naive and blue-eyed. Of course, we shouldn't do stuff that's stupid, that's obviously bad, like thinking that 200 launch companies will work out. But generally, we should be optimistic, because if we're pessimistic, we're never going to get anybody excited to help in lunar development. And so let's help to get that flywheel started that I just described and create a self-fulfilling prophecy of the lunar economy. And remember, the best way to predict the future is to help create it. And so I stop here, and hopefully that wasn't too much overtime, and happy to take some questions.
Thank you, Raphael. Appreciate that, and it did go better after you switched networks, so that was helpful. Leave that screen up for a second. We only have a few minutes. We're actually a mild bit over time, but the flywheel. Go back to the flywheel for a second. Yeah. So, what kinds of things? I believe that you haven't made any investments at all that are lunar focused businesses. Is that right?
That's correct. We are currently in the final stages of looking at one of those businesses that I described as a potential dual use business, which the product would absolutely have a very important use on the moon. But the reason we are able to invest in it is because we think the same product can be sold, and sold a lot, on Earth as well.
Okay, so is that your criteria? Is that you have your clients, your say portfolio companies, they have to be able to make money now in the real world, not some futuristic version where they're mining ice, for example?
Well, I think that there has to be revenue. In the end of the day, we need to get ideally a good exit for our investors within the lifetime of the fund. And I mean, yes, there's a way we can stretch that. We can extend our fund by 1 or 2 years. We could sort of sell an investment from our current fund into a successor fund. But typically, you want to be able to exit within the fund's lifetime. So that means in many cases, there should obviously be revenues or profits, or at least the company advances in some other way. Maybe it's a low TRL company, but during the lifetime of the fund, it has such obvious advances in TRL that it starts getting a lot more, it starts building its customer book, it gets basically contracts, it may get more non-dilutive financing, so that value is crystallized in some other way.
Great, that is much more clear. I think it is safe to say that it is hard to be a moon business. It is hard to raise money for being a moon business. And that's not going to change anytime soon, right?
Yeah, the typical problem, Michael, is right now, and you notice is, so there's obviously some companies which have, for example, received very large contracts, right? I think we mentioned Astrobotics before, and there are several contracts. I think the largest one is almost $200 million.
Yeah.
The question to all of these companies that investors always will pose is, well, what comes after the contract?
Yeah, right. Yeah, exactly. What happens if...
I mean, you have some of my VC colleagues who are less charming than me, and they basically, one of them has the tagline like, "You're not the company, you're a contract."
Yeah. No, it happens. It happens. All right, sir. Thank you very much. Appreciate it. We are gonna move on to our next speaker.
Pleasure.
Appreciate you being here. Thank you. Ben Smith is the director and the membership coordinator for the Moon Society, and we're going to hear a little bit about their programs, because that's pretty awesome. That's what we're all here for. So thanks a lot, Ben. Go ahead and take it away.
Yeah, thanks, Michael. Let me get the screen up. Okay, let's try that again. Having a hard time getting to the slideshow. There we go. Oh, hold on. Operator error. Slideshow from beginning. There we go. All right. So, hi, everybody. I hope you're as excited about the Lunar Development Conference as I am. We're now going to take a commercial break. I'm Ben Smith, and I'm the Moon Society's Mentorship Coordinator, and I'm going to spend the next 15 minutes or so talking about what the Society is doing and how you can help. And members, you're going to want to listen because I might cover some things you don't know. So let's talk money. The Moon Society relies on membership dues to fund its activities. More members equals more money, which equals more stuff we can do. More members also hopefully means more volunteers, which also equals more stuff we can do. In fact, volunteer hours is the current limiting factor for our projects. We have lots of ideas, but not enough people to execute them. So we're asking everyone attending this conference to join the Moon Society and volunteer your time, skills, and enthusiasm to the cause of lunar development and settlement. We're also asking everyone to tell at least 3 friends, family, or casual acquaintances about the Society and why they should join as well. All right, so how do you join? You go to our website and click on the Join Us link. It's in the drop-down from the Get Involved section. You select your membership level and follow the steps. Note that there is an option for LDC attendees to become members at a reduced price. And here's our address if you're old school and would rather pay by check. The address is also on the website. All right, so what is your membership support? Here are just a few of the projects that we're working on. The Lunar Development Conference is one of our flagship projects. Hopefully everyone's having fun here right now. The plan is to do one of these every year. We've already started working on LDC 2022, and you are more than welcome to help us make it the best one yet. Our virtual chapter, which we are calling Mare Cognitum, is launching next week on July 15th at 5 p.m. Pacific Daylight Time. It's going to be held on Zoom, and seating is only available to members. There's going to be a presentation and a chapter workshop at the end. Actually, I'm presenting the topic for next week's chapter meeting, and it's going to be on why lunar settlers will want to avoid the regolith as much as possible and go straight for the mega regolith. The topic of the workshop hasn't been decided yet, but it might be something like, what projects can this chapter work on? Mare Cognitum is still a work in progress, and you can be involved in shaping how it operates. You can also find more details about the chapter itself on the Moon Society website. Earlier this year, we concluded our first moon-based design contest. The goal of the contest was to showcase engineering-focused moon-based designs as part of the Society's activities and events. The contest was open to anyone, and we received 18 entries from individuals and teams, some of which are presenting at this conference. The first place winner won $1,000, while the second and third place winners won $500 and $250 respectively. You can see all of the submissions for the contest on our website. Lunarpedia is our wiki dedicated to everything lunar, from lunar science to base design to mission history. If it involves the moon, we want it in Lunarpedia. And because it's a wiki, Lunarpedia is always under construction. And we need your help to make it awesome. So anyone interested in research, writing, editing, and art should definitely join up and contact us. Luna City Press is the publishing arm of the Moon Society. We've already got 3 books under our belt with more on the way. Currently, we published Peter Koch's Pioneer's Guide to the Moon and Pioneer's Guide to Mars. Peter was the president of the Moon Society for many years and authored the Moon Miners Manifesto for over 30 years. We've also published the proceedings from last year's Lunar Development Conference. So we're always looking for people interested in helping us edit these publications. We're also looking for more quality literature to publish. So if you're interested in any of that, contact us. These are just a few of our projects. We have others in the wings waiting for a leader to pick them up and run with them. And let us know if you have an idea for something new. We're looking for people to lead projects to completion. All right, I know this is a dense slide, but basically, what can you do? These are some of the things that we have need for volunteers. The society is run completely by volunteers. We don't have any paid staff yet. That means there are lots of opportunities for members to actively participate in lunar development and settlement. I'm going to briefly highlight 4 of these. We hold elections every year for officer and board positions. Any member is eligible to run for office, and honestly, we need new people with new ideas and new ways of thinking. James mentioned that we're at our crossroads, and this is part of it. We need to realign what we're doing. The world is changing, and the society needs to change with it. We're currently running our 2021 election right now, so any member can vote up to the last day, even if you join now. And it's never too soon to start laying a foundation for a 2022 run. And membership coordinator. Yep, that's my position. I'm running for treasurer this year, and if I win, that's going to take up a lot of my time. So I'm looking for someone to take over as membership coordinator. However, I want to warn you that the position isn't as sexy as it sounds. There are a lot of tactical daily functions that have to be done, and we need someone who can be reliable in the face of grunt work. And then over on the other side, if you're enjoying the Lunar Development Conference now, why not join our team and help us make 2022 bigger and better? We're going to need volunteers to help put it together and to make it run smoothly. And we're going to start working on this in a couple of weeks. And finally, our new virtual chapter needs volunteers as well. Obviously, we need lots of engaged members to make it successful, but we also need speakers with exciting topics and volunteers to make it all happen. And finally, volunteering with the Moon Society has some benefits. And I highlighted having fun because having fun is important, but you do get some other stuff out of it. And for more information, you can check out our webpage, you can email me, you can join us on Slack. There's lots of ways to contact us. So ultimately, the Moon Society is only as effective as its members. If you want to see the Moon Society grow and do great things, then we invite you to join and help us do it. If you have any questions, you can email me at ben@moonsociety.org, join us in Slack, ask your questions in Commons, or just say hi. So that's it. And thanks for watching and enjoy the rest of the conference. I left a little time built in so everybody can go to the website and sign up or ask questions.
Terrific, Ben. Thank you very much. I think this is going to be great. I'm particularly interested in the new virtual meeting. I think that allows for people that are in very different places in the world to join and interact and build a small community. So I think that's going to be really terrific. I'm excited about the changes that are coming. All right, we are going to move on to no exaggeration, one of my favorite people in space. I have known Leonard David for 20 years. That's hard to imagine, but he is the third person I met in my space journey. So I've had a lot of admiration for him for a long time. Leonard is and I'm doing this by memory because I don't actually have notes on him. I just know him well enough. I'm just going to wing it. Leonard is a many, many times published author. He has been writing for space.com basically for 2 decades, but he's been doing writing in space for 4 decades. Recently, I think just last week, he got his Mars book that was part of the National Geographic series, got translated into, was it Chinese or, yeah, okay, so that's good for you. And then he's going to be talking a bit about his book, The Moon Rush. So take it away, Leonard. Thank you very much.
Okay, now we should be good.
Roger.
Okay. Well, thanks for having me. It's great to be with like-minded people. I live up here in Colorado, about 9,000 feet, and sometimes it's not like-minded, but we're closer to the moon than normal. I didn't prepare any slides. Barbara yelled at me to prepare PowerPoints, and I'm just going to, this is my book. It's a moving PowerPoint. I survived this book for National Geographic. You know, it was in the middle of all the books that were coming out on the 50th anniversary of the Apollo program. And my going in philosophy on this book was, I told National Geographic, I did not want to write about Apollo. I wanted to write about the future. where did Apollo leave us in the dust? Literally in 72 when Jack Schmitt and Gene Cernan left the moon, where do we go from here? And so I tried to do that. I went through 3 editors, so I'm still shaking. It was a it was a pretty monumental task trying to finish this thing. And at the end of the day, it's there. It's good. I think it does make some points that I was really pleased to see maintained in the book, because I'm going to go into the format of the book, which is, I think we're in a space race. This is something very similar to what I grew up with the Soviet Union and the United States vying for putting cosmonauts or astronauts on the moon. And it's a different situation. Maybe it's not a Sputnik event, but I do sense something on the ominous side. I mean, if you're a political whiz kid, I'm not probably one of them, but I think the idea of other countries now getting involved is really, one, it's exciting, it's diplomatic, it's also going to gnarl the US political system. So I think we've got some real comeuppance coming, particularly with China. I think this new relationship with Russia on establishing a lunar encampment at the South Pole is pretty interesting. And, Russia probably needs China more than China needs Russia. We'll see. But it's going to be interesting to see what the dynamics of that are going to be. Don't forget that Russia's going to come back with a vengeance in lunar exploration, maybe October or November of this year with Luna 25. This would be their first robotic lunar mission since 76, something in there, when they were returning samples from the moon. So we'll see how well the Russian system does on engineering wise. Lobachkin, we have some players that have traditionally been engaged in all the history of the Russian space program. We'll see how well they do. A lot of those people are dead. A lot of new younger people are coming into the vogue. And we'll see how well they pull this off. So that's always one wild card that's still to come. Beyond that, I think, I'm excited to think about, Bill Nelson and the new NASA, and we'll see how new it is. Got a new administrator, and he's fighting the political winds and trying to get a policy and finances to move forward on the US lunar program. I'm not quite sure how it's all going to play out, because I've been here too many times with too many presidents and too many social issues and too many administrators. You're never quite sure how it's all going to glue together. However, I would say that this Chinese, Russian, and other countries coming along in space exploration has got to play something on the hill, Capitol Hill. Got to have some import. Are we going to be left, talking about Apollo for the rest of our lives? Or are we going to try to move on? And I was listening to your last speaker, and one thing that, Michael, I don't know if you agree with this, but to me, the community of the lunar groups is huge. I mean, I'm going through a lot of emails and a lot of websites, and they go from, philosophical kind of, rhetoric to technical, how to beat the dust on the moon. I mean, it's a huge sweep of groups now that are very interested in this. The more I think your group can coalesce with some of those and try to appreciate their studies that they're doing, the better. Because, particularly one of them is Applied Physics Lab. They have a whole lunar group now that has just subdivided into all this minutia of detail. from power systems to lunar dust to, where the ice is to whatever it is. And that is pretty impressive. I mean, there's some really think-a-thon things going on now. And so everybody will benefit by coalescing these groups that are coming up with a lot of different kind of ideas. And I'm getting old. It's just like I reminiscing about 40, 50 years of space journalism and living through the Apollo program. I still have in my mind, I walked into the bar that I was working at, and I argued with the bartender, can you turn on the moon landing?
Right.
It was probably Apollo 14 or 15 or something. We're going to the moon again? Almost had a fist fight in there. It is going to be interesting to see, repetition of lunar landings and what's going to, how the public will assimilate all that. But that was one of my key memories is somebody tired of the moon already, and just didn't see the value of the whole thing. And one of the things I really did try to push in Moonrush, my book, that we don't know this place very well. There's definitely some surprises coming, and you can see it coming in the literature. I just read some Chinese paper this morning from China, Chang'e 5, some of their data in Chang'e 4, and there's definitely some very interesting scientific data coming from these craft. They're still being assessed and weighed. So my guess is we got really a lot of surprises. And how are we going to best characterize the ice? I'm a little tired of people already claiming billions of dollars on manufacturing ice and processing. And as far as I know, and I've talked to quite a few people and putting this book together, we're not quite sure what we're going to deal with in those craters that have no sun going in. Leslie Gertz, I live here in Colorado, so I go over to the School of Mines every time they have their lunar meeting and mining meeting. And, you can, the whole appreciation of what we're going to find in those sunshine craters, we don't know. How much money is that going to take?
We don't know.
Processing. What are we talking about? Is that real? We've got a bunch of small spacecraft that will help us sort that out. I always lean on the pessimistic side and am willing to always be wrong. But my guess is we're going to find a lot of odd things in these craters. And initially, I think there's some science data that's going to be accumulated in those craters that we probably want to assay first, science, and then think about mining that and using that resource up. So some of it's going to be life, signals about life, organic materials. I don't know what it's going to be. Who knows? And that's why we're going to go. So I don't know. Beyond that, I'm the thing about the moon now, and when you think about it, I wish I was 12 again.
We all do.
Yeah, because when I first started ripping out articles in a magazine called Aviation Week, they didn't even have space technology attached to it. And watching the whole NASA program build on this Mercury, Gemini, Apollo step-by-step realm, or things that we pulled off there as milestones. I feel like we're there again. I'm a kid on this internet. I'm having a blast. There's so much going on. We got Branson and Bezos taking off, you know, I mean, there's so many things that your email is just stuffed with excitement. And probably since we started talking, 10 new start space companies probably got going. So that's always a fun thing. And everybody's got a great idea, and not everybody's going to succeed. But we certainly are seeing something we've never seen before. Even back when I was 12 or 13, you know, looking at I grew up in San Diego, and I lived in San Diego in a little enclave there that had General Dynamics astronautics engineers. And I mean, watching these guys and talking to them in the neighborhood when you're a kid, things were blowing up, things were not going well. Kennedy was talking, we got to get to the moon, and you know, things were just going awry. And you know, they pulled off all these incredible achievements over the decades. And watching these younger entrepreneurial companies, and you know, even certainly Elon Musk and Jeff Bezos. I mean, these are and Branson, incredible entrepreneurs with money, deep pockets. So that's a great signal about what's coming. Now, when I flip to the pessimistic side, I do think we're going to see loss of life. I think we're going to have tragedies. The chances are high that we'll have some slip up here. And I don't know how the public takes it. I don't know how the companies will take it. Virgin Galactic, with their crash of their spaceship design, certainly got way behind schedule because of that accident that killed one of the pilots. So I do worry about all that. I mean, we're definitely taking risks here. I'm not, but you know, the people putting their money in there. You know, if we have some kind of mishap on Branson's or Bezos or both or whatever, that certainly will reflect on the space program in large. Orion, you know, there are people here probably that hate the Space Launch System, you know, but that's going to fly, and we'll see if that succeeds. But so you take all that in, and you're just like, oh, this is kind of cool. There's a lot going on here. You know, so again, I guess just to shut up a bit, the story to me is China. I really watch China a lot. I think this space station construction site activity is pretty fundamental for diplomacy as well as technical engineering for that country, and they're going to build on that. And the fact that they landed on Mars the first time out with I just posted some new photos from the rover this morning. That was pretty major achievement for them to pull that off first time out. So they're the wild card in politically how that reflects on the U.S. Congress and what we do about it. I'm just writing a new story for Scientific American on space cooperation, and what, you know, is it a good thing, bad thing? What, you know, are we going to be left behind at the launch pad, or what's going to happen? How do we work with other nations beyond the allies that we've utilized and been with for the many decades now? So let's say beyond that, I did have a thing I woke up thinking this is awful. I did have a thing, I put it down on paper, and it sort of reads okay. I don't want us to become the space flailing civilization. Space flailing, you know, and, you know, we have in the US, we have a good slogan going now with space, constancy of purpose. Okay, it can also be constipation of purpose. If we're not careful, And again, I've gone through a lot of presidents, a lot of space policy whiz kids, and this can go awry. And we'll see how the space program, as NASA puts it forward, as the government activity puts it forward, it can go awry. So we'll see. And I think the encouraging thing is all this private sector space activity, tremendous capability now, and NASA has taken advantage of that through a lot of public-private partnerships, to their credit. And so let's hope that we have a vibrant space agenda that leads us back to the moon. And again, the corny line is this time to stay and sustain. And let's see where we are. That's pretty much it, I think, Mike.
Okay, well, I'm not going to let you off the hook just yet. So, talk about the process of creating the book. What were the surprises that you had when it was about 3 years ago, right? Do I have my timing right?
Yeah, it's a couple of years or so. I worked so hard on this thing and it just almost killed me, but I think the surprises were how surprising I was that we didn't know as much about the moon as that you'd think we would after spending 25 billion to send 12 people that'll walk around and grab samples. And the other surprise and it's still there. Where did the moon come from? What is it? I went and talked to a bunch of people. I got more confused than I've ever been about trying to write that section about formation of the moon.
Okay.
It was accumulated, it came out of the earth, there's still this Robin Knapp at the Southwest Research Institute is one of the top gurus on this issue. And it's a head scratcher. And you'd think we would know the basics of formation of the moon and why it's there and what role it played, in early, even the early Earth. So that was surprising. The other thing that was surprising was I think I try to be honest and say, look, there are friends of the moon coming. You will have groups that you're taking our poetic license away. The moon is so part of our culture, and to trample on it and to have lunar mining sites everywhere, and we're going to be looking at craters with lights in there, and it'll be a different kind of moon that we'll see. So I did try to put those people in there to make sure that I didn't leave them out.
So I'm gonna steal a little bit of your time and tell you a story. I was out in Amsterdam about 10 years ago giving a lecture, and I'm all excited, right? I'm a lunatic. I'm trying to build an elevator on the moon, and this woman gets up and she stands up and she's like got her finger and she's pointing like this, and she's like, "How dare you talk about strip mining the moon? How dare you talk about strip mining my moon?" And she was very emotional about it. And she caught me off guard because I don't encounter people like that. I don't encounter people that are anti developing the moon very often. And so, I gave her my answer, and then afterward, she didn't like my answer, but I gave her my answer. And then afterwards, I specifically reached out to her and we had like a 45-minute conversation. And I'll tell you honestly, she changed my mind with just one or two sentences. She said, "The moon is the only thing that binds all of humanity," right? You don't have a romantic relationship with the sun. It will blind you. The only thing that all humans who have ever lived has in common is the moon. And that actually really kind of changed how I approached some of my conversations. So
Yeah.
it's definitely there. Definitely. You're
Yeah,
right.
no, they're there, and it is interesting. And you know, and then on the other hand, I try to balance that chapter out with. I kind of felt I'm not a great historian, but I do like to. I think we're in now history. You know, frankly, this is today.
Yeah.
But I did go back and look at Seward's Folly and buying Alaska, and I think there's some things that resonate with me when I read the history of buying Alaska. And it's a little kind of in the vogue of the moon is this wilderness site. We don't know what the value is going to be. We're not sure. I'm convinced it's going to surprise us right and left.
Yep.
There are resources there. There are scientific benefits of going. Unbelievable capability. Yeah, okay, we might be doing ISRU and making fuel and oxygen and water and rocket propellant, whatever. So I think we're going to learn a lot, but we got to get there and start working it.
Well, you've
I don't know how many papers I've accumulated on, you know, processing of lunar soil and all this stuff. My guess is we're not going to know much until we really put the hardware down and find out that crank does not crank. You know, it's cold.
You've heard Clive Neal, the professor at Notre Dame, talk about we have a sample size of 1, right? We have N of 1. We know where there's maybe some water in one place. And so everybody's betting these multi-billion-dollar fortunes on a sample size of 1. So I believe, I don't have evidence, but I believe there's more water there. I think we will find evidence if we start sending stuff, but we have to actually send the Dern rovers and get more than a sample size of 1. Yeah. So when you were doing your research, were there any organizations that that when you were writing, you're like, oh, these are groups to watch, or this is a person to watch, or this is an organization, or this is a capability? What should we be watching now from your kind of inside baseball perspective?
There were a lot of people I talked to. I mean, it was just a lot. I'd say Ian Crawford in England is one of my favorites. I think he's very thoughtful, good research. Clive Neal, definitely. The LEAG group, clearly, assembling quite a bit of information and data. Jim Head, Brown University, Carly Peters. I really did try to talk to a lot of people. And I'd say there wasn't anything that really was like and the Lunar Planetary Institute. They have a tremendous information base there, just great. But probably the one, because I asked him to do the kind of outward message was Jack Schmitt, Apollo 17 astronaut. I asked him to put together something for me, and Buzz wrote the forward, and I felt kind of good. I had the first, mission to the moon with Buzz represented, and I had the last one and the last part of the book with Jack Schmitt. So I thought I closed it up pretty good.
That's a good, yeah.
And Jack is much more politically savvy because he was senator. He's got a lot of interesting perspectives about America and independence and, some flag waving going on there. But I thought, well, okay, this is his opinion. Yeah, but he went to the moon. When you talk to people that went to the moon, it's different than people that are thinking about the moon. And Jack is continuing to write these great essays about his time on the moon. And I don't know if you guys have linked up to that one, but he has a diary of the last man on the moon, or whatever he called it. I can't remember the title of the whole thing, but it's really, he's trying to retrace his steps and things that he couldn't do, didn't have time to do, wish he could have done, what he really succeeded and was very pleased with. It's all there. And it's just, you know, he really puts you into his moon boots and you kind of walk around with him. It's a great
Wow, I've not
contribution.
read it. That
Yeah,
sounds
it's great.
that sounds interesting.
I'll send you the link and maybe you guys can tap into it. It's a little, well, the guy that's put, I'll send you the link, but it's really well done. And it's just a unbelievable account of his being a geologist. And I think one of the most fun things, I'm going to shut up. One of the most fun things I did in the last decade or so, I went with Jack Schmidt and a bunch of other lunar scientists, and we went to New Mexico, and we walked through the training area that he trained in.
Wow.
And I tell you, it was pretty neat. He explained, you know, trying to teach the other Apollo astronauts what to look for that weren't, you know, they weren't geologists, but, you know, he was trying to be their kind of a tutorial guy. And it was really great at the Rio Grande area there where where he and Cernan and everybody else walked through those areas trying to understand more about lunar geology. So that was really fascinating. Beyond that, I think good luck on all the things you're doing, and I hope. And I did put, you know, in my moon book, we got the lunar elevator in there.
Thanks. Glad.
Like I told National Geographic, I don't want to do Apollo over and over again. Let's go where we're going to go. So I'm hoping, and boy, there's more people looking at that elevator and you know, and seeing that as a viable concept for the lunar surface. And still got a ways to go for Earth.
Sure. I certainly appreciate the plug. This was not a paid endorsement, but
yeah.
Let me, before you go, I want to ask Professor Thangvalu asked a question. I just want to shout it out to you. Do you think activities in the fragile lunar surface environment, without messing it all up as we do here on Earth, in a pristine vacuum and low gravity environment, will make us a more refined species? Will we do better if we learn how to treat the moon well? Will we do better here on Earth? I think that's an interesting philosophical question.
Yeah, let me go get my white robe. I would hope, but I've been fooled before. You know, I used to tout something Margaret Mead talked about, anthropologist, about space and how it would help kind of galvanize thinking and philosophy. And I don't know. I'm cynical on that. I think it's fine. I hope we have an ethos that comes out of the lunar exploration that has some practicality for down here. I'm not counting on it. You know, I'm frankly, and maybe I'll stir up stuff for people to talk about later, but I'm a little concerned on these Artemis Accords.
Yeah.
I think this is a little bit strangeness, and it has all tied to the Outer Space Treaty somehow. And I get all these emails from people that hate the Outer Space Treaty. Let's rewrite it. No, it's fine the way it is. So there's something is in there that's worrisome for people. Artemis Accords, the fact that the guy championing that is now out of NASA, Michael Gold, he's no longer with NASA. It's bouncing around the State Department and all this, and so I don't think we've settled on what that is. And the other one that's weird, I'm really interested in what the military sees at cislunar space. This is a growth pattern, and we've talked about this.
Yeah.
You know, DARPA has something that they call Nomad or whatever it was. I'm not even sure if it's still going, but it's definitely using the lunar resources to build military infrastructure. And so, okay, you put that against the Artemis Accords, and you know, I see rubbing of hulls in the ocean. This is not quite what I envision as peaceful uses of outer space, you know, but you get all the military guys who I talk to quite a bit.
Mhm.
You know, other countries are going to be out there. We got to be ready. Okay, so we're seeing the beginning of the same rigmarole of air, land, sea, polar military conflict on Earth, and this gets back to Margaret Mead. You know, like we're going to somehow, it's all going to congeal into a peaceful, harmonious thing. So it looks to me like we're seeing vibrations of military superiority with whatever country you're talking about,
Yeah,
extending out into outer space. And so it's just that's going to be a continuum of paranoia. And
well, definitely come back.
peacemaking.
Definitely come back and join us tomorrow, because Major McLean is an active duty U.S. Space Force officer, and he's going to kind of walk through how we got here and maybe what's coming next. So definitely join us tomorrow. It'll be interesting.
I'll try to do that.
All right, Leonard, always terrific hanging out with you. I wish we could go grab a glass of wine right now. We've earned it. Let's move on to our next speaker, but thanks so much. It's really great having your experience and wisdom to kind of point us.
I probably should stay on here and make sure nobody really hates me. That's all.
They don't hate you. We all adore you. We do. Okay. All right. Thanks a lot, Leonard.
Bye-bye.
All right, Mr. Mealing, come on down. Michael is the president of the Moon Society and the co-founder of Starbridge, and he is going to talk to us kind of a little bit about the past, present, and a flirt with the future of the Moon Society. So take it away, Michael.
Sure. Thank you, Michael. So I'm going to preface my talk a little bit with a conversation that I just had with an investor looking at the space sector. And I had to spend at least a good half hour explaining to them what was going on in the sector and how a lot of the things that he thought were science fiction were actually not only real, but the companies behind them were not only unicorns, they were becoming unicorns 10 and 20 times over. Where, as many of you in the industry have noticed, with between SPACs and SpaceX and the amount of money they can raise, a good example is Relativity Space. In the span of 6 months, raised $1.2 billion from private investors. There are companies out there such as Axiom, Umbra, Orbital Sidekick, SpaceX, Rocket Lab, Relativity, that are doing things and have customers and have products on the roadmap that are talking about making the things that we're talking about very real. And so the challenge that I think is currently facing most of us in this industry and most of us on this conference is that the space industry that existed 2 years ago almost has very little in common with the space industry that exists today, and the rate of change is accelerating. A lot of this has to do with people finally, I've been talking about this since about the year 2000 when I first came into the space sector. And even when I joined the Moon Society back in, I think was 2004, It all gets muddier the older you get, as I'm sure most of the people on this call are probably familiar with. The fact that we now have real companies focusing on real customers in real markets. When you do that, the finance industry responds. You get, for example, in SpaceX's most recent round back in February, that was supposed to be an inside sale, was 8 times oversubscribed and had large venture funds wiring $500 million before they'd even signed contracts. And the demand for that stock is so overwhelming because investors do see the promise of SpaceX and Starlink. So whenever we're talking about in our industry about I need access to capital, or access to capital will do this and such. If you are focused on the business of business, and you have identified a large numbers of customers that are willing to pay you, the money flows. There is a desire across the entire financial sector to find risk-adjusted alpha being returns. And so that has created a tremendous amount of change in our industry. Even just in the past year, going into the pandemic, we thought that, oh my God, Rick Grimes is going to be, coming down the street on the horse surrounded by zombies. But what it's turned out is the space sector has had its greatest year ever in the entire history of the sector as a commercial sector. So the question that I'm posing when I look at the history of not just the Moon Society, but also our sector, is we spent easily 30 plus years imagining a future, and now we're on the cusp of actually being able to build it. And what does that mean to our institutions? The National Space Society has been doing some things lately with doing some reorganizations and changes to how it runs things and some of the programs. And I think the other institutions in our sector are probably in the process of doing the same thing. The Moon Society has been around almost as long as any of them. And we have wandered in the wilderness as well at times. And we got our start as a support organization and outreach organization that was tied to a commercial development. And commercial development of the moon and settlement has always been part of our organization. And now we are getting close to a time where the industry is ready for what we can do. And that means that it's probably time within our organization to do a bit of navel gazing. And so for everyone that's on the call, both our panelists and attendees, we're very interested in your input. What do you feel is, when it comes to lunar development and settlement, where are the gaps? What are the problems that need to be solved? Are they policy? Are they awareness? Are they capital formation? Are they formation of companies that can do certain things? And so that's where the society is looking for that kind of input to figure out what it is we want to do next. I do, through the Alliance for Space Development, along with all the other space advocacy organizations, do spend a fair amount of time talking with Congress. And I will testify to that. There are still large parts of Congress that believe that all the things that we're talking about, and this is a direct quote, are still at least 500 years in the future. And even when you show them things like Starship, they fundamentally believe, and then this is also a direct quote, that Elon Musk is a criminal because he is lying and defrauding the federal government, even though his rockets are flying these days on a bi-weekly basis. We still have a lot of work to do, but the industry is now backing up the work we have to do with accomplishments that are astounding people on almost a daily basis. And so that's where I think the future of, not just the Moon Society, every advocacy organization around the industry and around the world needs to prepare for a period of very rapid change. I'm going to get into a little of this tomorrow when I talk about a little bit about the Starship Singularity. In one of the things that I do spend my time on, in addition to the Moon Society, is the Integrated Space Plan, which I'm sure some of you have seen. The new version is out. If you Google for Integrated Space Plan, you should be able to find it. It's the 2021 version. It was originally the 2020 version, and things kept changing so fast that we had to keep making changes to it. There are parts of it that are already out of date, and it's only been printed in the past 3 weeks. The amount of things that are happening, we need to prepare for that change, because people are going to come to us and say, what the hell is going on? How do I get involved? What can I do? And that is something that we, because we are nonpartisan, we're not beholden to a single company, and we actually understand the kind of future that we're all building, we all have a unique role to fill. And that is something that, whether it's Planetary Society, Mars Society, and especially some of James's work within the Mars Society, and even in the NSS, we're all feeling that need by the world to understand that what it means for the world that we've been trying to build for 30 plus years, what happens when that appears. And conferences like this are kind of a key part of that, because the more we can educate each other about what's going on, and then use that to educate the rest of society about what's going on. And I think the other thing that we need to do is make sure that it's becoming far more international. One of the things that I do is run rooms on Clubhouse, which is a new social media platform that's audio only. If you can imagine an app that shows you all of the available conference calls running around the world, and you just get to hop into whatever conference call you want and listen in and participate. The Indian subcontinent has come onto Clubhouse, and now every room that's related to entrepreneurship or space, at least a third of the people in the conversation are from India, Europe, Africa, Southeast Asia, and they are all eager to participate. They want to know how they want to get involved. And so I think it's time that all of our organizations also become far more multinational. I ran into the person a few days ago who runs the National Space Society India chapter. So yes, the NSS that was formed as a US space advocacy organization now has chapters around the world. And that is a development that I think we all need to embrace, because they are eager to participate, they have a lot of energy, and they are ambitious. And so one of the things that I want to do is, that's kind of the end of some of my remarks. And I know I'm going to steal back my the 3 or 4 minutes at the beginning. I want questions. If anybody has any questions about, or comments about, what you think the society needs to be to fulfill the needs that you see in the industry, would love to hear comments or questions on the society itself and the larger industry. So I'm going to shut up and let you guys ask questions.
So there aren't any questions. I would like, if anybody has any comments, please post them. I want to echo something that Leonard David said just a few minutes ago, that there's a lot of stuff going on the moon. Everywhere he looks, everywhere he goes, it's the things we talked about early this morning: academic, civil, defense, and commercial. All of those communities are all pointing to the moon. I feel that the Moon Society has a role to play, a leadership role, an advocacy role, a science and development role, and a commercial role. So does anybody have any comments for Michael?
Michael, I do want to respond to something you just said that comes up on Clubhouse a lot. Yeah, every one of those, there's a lot of people that are looking to the moon and even beyond. We get the same conversations around Mars. I think one of the things that the society stands for is, and this is where we echo the statements in the Outer Space Treaty, is the moon is for everyone. Space is for everyone. It's not just for the United States.
Right.
It's not for NASA. It's not just for China or even Russia. The United Arab Emirates is the only country that has as a national goal the establishment of an Emirati city on Mars. There are other governments, there are non-government organizations that have aspirations for doing things in space and on the moon. This is not a US program. This is not a program for superpowers. This is a program, this is a mission for all of humanity. And if you want to go, we can figure out how to make that happen.
This isn't a plug for my book because it's a terrible book. Don't buy this book. But our title is Opening. So that's been the philosophy from from most space advocates that I know.
I got one question. Should the Moon Society take over the moon track at the ISDC? We've done that in the past. I think that's just a conversation between NSS and Moon Society. It's one of those things. During the pandemic, I think everybody was making everything up as they went along.
Yeah.
Sure, those are kind of some of the blocking and tackling things between the NSS, Moon Society. I do have to say that the Alliance for Space Development is a very unique organization, because that is where NSS leadership, Moon Society leadership, Planetary Society leadership, we all get together, and it's very collegial. It's like, okay, you do your thing, we'll do our thing. Where we have something in common, we will do it together, and we're happy to do it together. And we actually develop policy together. And it's something that as the pie grows, it's quickly becoming nearly impossible for any one organization to do anything, to do everything. It already is impossible for everyone to do that. So yeah, you're going to start seeing more and more partnerships between all of these organizations as the boundaries between what we all do get really, really muddy.
All right. Thank you very much, Michael. We'll hear more from you tomorrow. We're going to shift over to Josh Carlson. Great having you on board, Josh. Appreciate that. Let me pull up your, I have lost your bio. Where's your bio? There we go. Okay. Josh Carlson is the author of Space Power Ascendant. We'll be talking about that a lot. A book independently published through Kindle. It was the culmination of nearly 12 months of dedicated research and evaluation of both U.S. and China's views on the strategic conflict there. He serves both in Army and Air Force. He serves in both the Army and Air Force in different capacities. He is currently working on a new book with an as yet unpublished author that is targeted for next year. The new book will examine similarities in all dimensions, what missions need to be emphasized in various phases of space development, and examine the space domain to provide recommendations on U.S. Space Force development. Thank you, Josh. Please take it away. Looking forward to hearing what you've got to say. Thanks.
Well, thank you very much, Mike. So just to start all of my comments, obviously I want to say I'm speaking in a personal capacity. Nothing I say is endorsed by any governmental agency or the DoD. So starting off, so I think bouncing off of Michael Mealing's great comments about the importance of space development and the history that we've had up to this point and the incredible position that we're in at the moment. And I think that I really appreciate the opportunity to come and speak to the Moon Society, especially since the moon is such an important element in space, especially as it regards the Mars and other celestial bodies. There's never been an expansion in space. Obviously, we've never had permanent presence outside of the International Space Station is, I believe, the highest altitude system we've ever had. And so it's difficult to draw historical it's difficult to draw on a history that doesn't exist yet in space. But by reasoning, by analogy, I believe we can arrive at the framework and the process with which to develop space at a strategic and national level. And so to do that, that's the basis of the book I wrote, Space Power Ascendant, which puts forward space development theory in particular, which suggests that there is 4 phases that nations and the peoples inside those nations and organizations, etc., will go through as it develops a new domain. And the first 3 are linear. The 4th is conditional on outside interference. The first is exploration, which as space professionals, as space enthusiasts, that's very familiar to those who are steeped in the history of space. That's a large amount of what we've done, virtually all. And exploration has a variety of facets. It has a variety of purposes. During exploration, you're seeing what's in the domain. How do you move in the domain? What the key locations are, potential resources. How do you move most efficiently in the domain? And this maps across all expansions. So, or all explorations rather. Going back into the age of sail, you had Captain Cook's voyage across the Pacific would be an example of exploration, for instance. Columbus's voyage to the New World, another version of exploration. The Chinese treasure fleets about the same time going to Africa, also exploration. They are a chance to increase the knowledge of that society and lay some initial soft power claims based on the naming and the mapping of those locations. And it gives the society a greater fidelity of what's there, scientifically, physically, etc. That is, as I've already said, that's the majority of what's gone on in space. And in Earth's orbits, we've entered the second phase, which is expansion, which is the permanent expansion, the permanent extension of national architecture to both provide safety and speed and minimize risk of travel in the domain. So once again, so Captain Cook's voyage across the Pacific, he mapped, once they did that, they set up bases within about 20 years. And the maps that they brought back enabled vessels to navigate much more effectively. The bases enabled them to refuel. It increased the capacity to move in the domain. In Christopher Columbus across the Atlantic, you set up cities. You began setting up military outposts, resupply posts, and the ships going across the entire Atlantic didn't have to go all the way to the other side, hope to get supplies. Christopher Columbus convinced the natives to give him supplies because he knew there was going to be a lunar eclipse, and he suggested to them that he controlled the lunar eclipse, and they gave him supplies. But that's obviously not a very recommended method of securing supplies. And so you set up permanent bases, and then the ships could travel across the Atlantic, have a known resupply refueling point, and then journey back across. It decreased the risk. And likewise, in orbit, you've had permanent communication satellites, GPS, all sorts of things that benefit particularly life here on Earth. We have never had the outside of Earth's orbits, that expansion phase take place. And I think we are on the cusp of that. The Chinese and Russians just this, I believe 2 months ago, signed a lunar development, a lunar base treaty. And just last week or week before, China announced that they would begin construction of this base by 2026, which would be finding of the site, groundbreaking, et cetera. They, based on the timelines I've seen, 2036 is probably when that will be operational, unless they've managed to accelerate it due to the fact they've now pooled their resources with Russia, potentially. And likewise, the United States has the Artemis Accords and the Gateway project that was meant to put a orbiting space station around the moon. And that would also be a permanent extension. Once again, for the first time, humans will be able to exist for extended periods outside of Earth's gravity well entirely. In addition to those three nations, China, Russia, and the United States, Japan, as already mentioned, UAE, Brazil, the EU, India, have all expressed some form of interest in moon resources, moon settlement. The moon is becoming, in a lot of respects, at least in my impression, the gold rush of the space domain, the new area that everyone is very interested in. Based on the context strategically, that makes a lot of sense to me, because the moon, in a lot of ways, is an excellent refueling point, and an initial capacity check coming off of Earth. In a lot of ways, from Europe to America, it would look a lot like the Canary Islands. It's an excellent place to have ships refuel or be able to ideally mine propellant, getting slightly ahead of myself, mine propellant, send it back to orbit, and you can keep satellites on orbit, stations on orbit for an extended period of time, due to the fact that they can continually refuel at a fraction of the cost it would take to get that same propellant off of Earth. And all of that is expansion, the second phase. And it's still a net drain on resources. And in a lot of ways, the national architecture has to invest upfront for that. Once you get to the next phase, however, which is where, and we're kind of doing, SpaceX is already, I think, straining to get to this point of exploitation, which is the use now of these resources and these locations to generate a net positive. So in other words, the various nations or coalitions or independent entities have to invest whatever, $2 million annually to be able to maintain a moon base, for instance. And now they are generating $2.1 million in revenue through whatever means of this moon base. They have entered the phase of exploitation, in that it is now a net positive to maintain their presence in that location. And more than likely, they will continue to expand as it continues to be profitable. The trading posts that the British set up, obviously the cities in the Americas and in Mexico that were set up, Cuba, that eventually became net positives economically. And it would be the moon base, once it is able to use any of the number of resources, or just simply the location of it on the moon, to be able to generate a net positive. It has entered the phase of exploitation. And at that point, you are already in a net positive, and now more than likely the companies will continue to expand because they continue to make profit. And of course, the government should incentivize, both through the protection of it physically, as well as establishing legal frameworks to maximize this this exploitation of it, because it bolsters, from a national perspective, it bolsters national capability, what's termed soft power in international relation theory. And in the final phase, which, as I mentioned, and nations always, in my opinion, want to stay in exploitation. Every nation wants to always be making net economic positives from regions they control, especially those they've expanded to. Then there is the national, the conditional phase of exclusion, which is if there is a national, international, commercial competitor that is attempting to infringe on an area that is already controlled, or the nation sees a potential area they wish to control that is in the offing, they may enter an exclusion phase, which is once again an exertion phase of attempting to either control or deny control to a usually national actor. So the French and Indian War, or the that were fought in the Americas right before the Revolution War, right around 1750s, between the English that were expanding west off of the 13 colonies on the coast, and the French and their Indian allies that were already in the hinterlands. And the English were continuing to expand. The French didn't want them to expand due to the some of the lucrative trapping and other economic things they already had in place. They fought an indirect war, a guerrilla war, in an effort to stop the British. The British ended up winning, and they continued to expand further into the continent. This would be an example of exclusion. A much more modern example would be Iraq, for instance, taking Kuwait and attempting, and they saw an offering, they took it, they attempted to then retain that from the US-led coalition. They were not able to, they were not successful in that exclusion. Putting all of these together, thank you, Mike. Putting all of these together, a fairly obvious progression shows between those. And as Mike mentioned, I've spoken actually with NAMI extensively about the Chinese space program, which I think is very concerning in my opinion. And in particular, because the United States, there have been pockets of it, but in my impression, and I'm sure there'll be some interesting discussions later about the U.S. space program and how it's been related to possible expansions, economic expansions. There was O'Neill wrote a book about putting O'Neill cylinders, which are huge constructions able to turn to create their own false gravity, as far back as the 1970s. And he claimed at that point that industrially, engineering wise, we were able to do it, but obviously it hasn't happened yet. Why not? Based on my analysis from developing space development theory, the fact is there's been no economic driver for it, and there's been no international driver for it. And so the combination of those two, if there was, for instance, pure gold on the moon in vast quantities, more than likely, if the economic case made sense, there would already be nations mining that on the moon. There's not. Or an international competition. Obviously, the Cold War fueled the first moon race, but that was purely for national bragging rights, for lack of a better term, and exploration. It was I would argue it was couched in exploration. It was really just to be able to show that we could do it before the Soviets could. It was a test of civilizational capability, but that was not economic, and that was not true expansion. And there have been those who had the vision for this. One of the first Air Force projects was Project Horizon, which contemplated a potential Air Force base on the moon back as far as, if I remember correctly, like the 1950s, obviously before the Lunar Treaty, or the Outer Space Treaty, and all of the language there that prevented military installation. So it was completely possible at the time. But there's been visions of this, but no mass movement. And I think it's a pity Mike had to drop, but I was going to say that the two things that, in my opinion, that are changing is the economic case is starting to become on the border, if not already viable on the moon, based on several studies I've seen, particularly looking at lunar ice, being able to get lunar ice once you have the infrastructure on the moon, you have lunar ice mined, converted into propellant, send that back to Earth's orbit. You can actually fuel satellites, according to the study I read. You can fuel satellites in Earth's orbit more cheaply than you can bringing it from Earth's surface, due to the difference in the gravity well and the amount of thrust required, therefore propellant, therefore financial requirements to get it off of Earth. And that's not,
it's a delta V equation. You can do a round trip to the Lagrange point with a fuel station cheaper than you can go from Leo to Geo. It's crazy.
Yeah.
It doesn't even seem to make sense, but it works.
Yes. And so in the very short term, looking at developing this, like I said, there's tons of satellites in Earth orbit, and to have the capability to refuel those, and especially once the satellites are created with the capacity from the beginning to be able to refuel them. This is potentially a significant market, and one that would be fairly expansive, with some estimates I've seen as high as 40,000 satellites in Earth's orbit by the end of this decade. And that's not even counting the cost of human settlement on the moon. There's going to be, in my opinion, several moon bases on the moon by 2040, assuming that the nations who have already pledged they are going to do it don't default. If those are there, and even if there's incredibly efficient means of recycling water, etc., to have the capacity to add to that water or use propellant to get the rockets that are bringing the astronauts, taikonauts, whichever happen to be there at that point, to the moon and back to Earth, that also could be a significant market. And more importantly, even if the market's significantly smaller, the price differential, it is obviously far cheaper to mine ice on the moon once the infrastructure is there and convert it into propellant than it is even to bring it back to Earth's orbit. And so these are some examples. One other that that I have assessed as a potential one is also rare earth elements, and the fact that there is, in my estimation, a national competition at the moment that rare earth elements have been weaponized in the sense of supply or denying that supply. One example is Japan captured a Chinese trawler that they alleged was in Chinese waters, or in Japanese waters rather, and of course China alleged they were not. But the Japanese took them into custody, and the Chinese, I believe this was like 2015, 2016, cut off supply of the rare earth elements. China controls between 70 and 97% of the rare earth element distribution on Earth, which means that if they desire leverage potentially in the area of rare earth elements, which of course are intrinsic for the key high-tech items like computers, electric cars, solar panels. If they deny these to a nation and their industrial capacity, it obviously will hurt China, although to whatever extent is unclear. Of course, it will grind that nation's industry to a halt, which would be a significant amount of economic leverage to consider. One potential way to diversify this, they're digging other mines, they're delving deeper in current mines here on Earth, but also being able to mine this on the moon and potentially even generate an industrial capacity on the moon. There's also been some mention of helium-3. I would be very interested to see any other studies than the ones I've read, but most of the assessment I've seen is that there's not enough of it to generate a meaningful electric capacity here on Earth, and so it wouldn't be economically viable. In my book, I do point out, however, that Uranus, it has vast quantities of helium-3, and it's actually easily gatherable with our current technology. The major issue there is, once again, that initial price hurdle to get over the cost of getting there, and having power plants here that would actually be able to be configured to use it. But I'll leave that for another time. I think, Mike, I had until the top of the hour, and I'm going to try to make sure I can stay on time for our other guests. I'm sure they also have incredibly insightful things to say. I do want to finish with the thought that I do believe strongly, and I would recommend you check out the book. I think it argues its point very well. Shameless plug there. But within approximately 15 years, and I would assess perhaps sooner, there are going to be major changes to the space domain. Not necessarily, I expect them to be economic technological, etc. But strategically and internationally, by the end of the 2030s, so by 2040, the United States is expected to have a moon base. China and Russia will have a moon base. More than likely, they'll be basing other nations on those, as I said, Japan, UAE, Brazil, EU, India, all of that. All of those nations are most likely going to have some form of presence, probably, and probably others by that point, on the moon or in cislunar space. The Chinese have already declared they will have a nuclear space vessels capable of maneuvering in cislunar space. There was a recent article by Christopher Stone arguing that the United States also needs to embrace atomic-powered spacecraft to be able to also maneuver in space. And these are, obviously, there's military applications, but more importantly, there's also economic and other bleed over commercial applications to all of these technologies. Once you can move fairly freely and at fairly low cost in cislunar, that changes a lot of the economic calculations. Once you have infrastructure on the moon, that changes economic calculations. And I don't think it's going to be a linear progression based on space development theory, based on previous developments. It can be fairly meteoric, fairly quick gain, so to speak, on that, which means, final thought on space development theory is that space development theory recognizes that generally in indirect warfare is the most perfect form of warfare, summed up by Sun Tzu's maxim. To defeat the enemy strategy is true, not to succeed in 1,000 battles, but to defeat the enemy without fighting. To be able to position ourselves first, obviously as an American, I care about America, but I care also that the rest of the world, and especially our allies, are welcomed into this space economy that will form over the next 15 years. And being able to be positioned first allows us to assist in helping that system develop in both a way that is equitable and equal and beneficial to the world as a whole.
Sure. Thank you, Josh. That was really interesting. You covered a lot of stuff quickly. I'm gonna make a not very shameless plug. I'm gonna echo Colonel Reed's comment here. He's referencing your book. Quote, "It presents a logical, reasonable progression of concepts that takes into consideration of available historic analogs." Very thought-provoking. So I don't know, Josh, if you know Colonel Reed, but I'm happy to connect the two of y'all on LinkedIn if you like.
I would appreciate it. I'll be honest, I might know him. I'm horrible with names, but I'm great with faces. So okay. I would be more than happy to connect.
Right on. All right. We're going to move on. Thank you very much, Josh. Really appreciate it. It is an interesting idea, and it does show how once you get through some of the phases of space development and development terrestrially here on the ground, that stuff moves pretty fast. And I believe that we're in this kind of inflection curve heading to the moon pretty darn fast. All right. We are moving on. I'm going to bring on Dr. Roger Lanius. Give me a second. Let me pull up his bio. Roger, are you here? Fabio, can you move him from being an attendee to a panelist, please? Sir, we'll bring you on screen right away. Yep, perfect, thanks.
All right, I'm here.
All right, terrific. Dr. Lanius is principal of Lanius Historical Services in Auburn, Alabama. Between 1990 and 2002, he served as the chief historian of NASA, which honestly, that blows my mind. From there, he moved on to the Smithsonian Institute's National Air and Space Museum, where he served most recently as Associate Director for Collections and Curatorial Affairs. He is the author most recently of the Smithsonian History of Space Exploration from the Ancient World to the Extraterrestrial Future. Pretty interesting guy. He has been writing for years and years and years, and I think we're really honored to have him here. My hope with having him here was that, Roger, you didn't hear earlier, but Laura Forsyth was talking about millennials don't understand the Apollo program, right? I mean, they're 30 years old, 40 years old, and they've never encountered, arguably some of NASA's greatest hits. So I'm really glad to kind of have you here to give us some perspective. Thank you for joining us.
No, my pleasure. It's a pleasure to be here. But let me begin with a shameless plug. In 2019, I published a book. This is the book called Apollo's Legacy. It deals with sort of the meaning of Apollo after 50 years. And you can find it online. You can find it in at least some of the bigger bookstores. And I would invite anybody to take a look at that, which will encapsulate some of the things that I'm going to say today, and a lot more beyond that. What I wanted to do is to take you back in time more than 50 years ago and to talk about the issue of the Apollo program. And it began in a very specific way. Now, I've got a few slides, and if you don't mind me showing them, I will share my screen and do so. Not a lot of slides, but I think there's a couple of things that will be useful. The first point I would make is Apollo only makes sense if you think of it in the context of the Cold War setting. It is absolutely critical that that this is sort of the beginning point to this. Absent that rivalry, and it was a rivalry to the death. These were scorpions in a bottle, if you will. Somebody was going to win and somebody was going to lose this Cold War. And the Americans and the Russians were locked in this struggle for more than 40 years. And not until, the early 1990s did this change. And again, many millennials don't remember that part of it, even the end of the Cold War. So this is, in the truest sense of the term, history to them. Those of us who are a little older like me actually remember these things and how desperate it was. And in the context of the space world, it was the competition between the Americans and the Russians that really sparked the American investment to first create NASA and ultimately to go to the moon and put in place a system to engage in space activities that were viewed as not military. Now, there was plenty of military activity done under the auspices of the Department of Defense, but that's not what NASA was intent on. And two really defining moments in the late 50s and early 60s put us on track for these sorts of things. The first was the Bay of Pigs, was the Sputnik crisis of 1957-58, which led directly to the creation of NASA and the passage of an Education Act aimed at fostering what we now call STEM education, put tons of money into science and engineering, mathematics, and so forth, both at the K through 12 level, as well as the graduate level and the college level. And then in the early 60s, the Soviet success with the Yuri Gagarin flight in April of 1961 followed within a week by the American disaster at the Bay of Pigs, in which American-backed Cuban rebels tried to overthrow Castro in Cuba with a great failure. And the John Kennedy administration, brand new to the office, just coming aboard in January of 1961, said, we have to do something. And that's something that they came up with was to go to the moon by the end of the decade. And I would suggest to you that for about 6 weeks, between the middle of April and the end of May, that was the window in which they could make a decision like this to go to the moon and not be laughed off the stage. If you want to be flippant about it, during that 6-week period, the moon was in the 7th house. Jupiter was aligned with Mars, and we were able to make this commitment to go to the moon by the end of the decade. Absent the situation in the spring of 1961, the United States would never have made this commitment because it was an enormously expensive commitment. And less than a week after Kennedy gave his speech about going to the moon to a joint session of Congress on May 25th of 1961, his budget director, David Bell, comes into him and says, have you seen what it's going to cost to go to the moon? NASA is going to break the bank. We've got to get out of this. And the first week of June of 1961, Kennedy goes to meet Khrushchev, the Soviet premier, for his one and only face-to-face meeting with Khrushchev, and proposes not once but twice during a 2-day meeting that they turn the Apollo program, which is now starting to get moving forward, turn it into a joint effort between the Americans and the Russians. And initially, Kennedy just sort of on his own hook suggested maybe they should do that. At the end of the day, when they got Kennedy by himself, his associates, his advisors said, you can't do this. If you do that, you will open the door for the Soviets to understand our capabilities, because space capabilities are dual use. You can use them to explore space. You can also use them to kill people and break things. And the result of that was that, okay, well, maybe I need to walk that back a little bit. Is there something else that we can do? Khrushchev initially responded that maybe that was something they should probably talk about. When he got back that night, his advisors did exactly the same thing. You can't say that. If you do, you are going to show the Americans how weak we truly are when it comes to these issues. And they were. As a society, it was closed. The rank and file in the world had no idea what the Soviets could do. All they saw was successes, because that's all the Soviets talked about. They had plenty of failures too, but unless you had access to classified materials that had been collected in a clandestine manner, you weren't necessarily privy to what they were not able to do. What you saw was the successes. In that context, both sides recognized that space was an incredible demonstration of their capability, both militarily and in other ways. They understood in 1961, as we still understand today, that the society, the civilization that masters science and technology is the one that's going to lead into the future. There is no question about that, and they knew it. And the Americans believed they needed to demonstrate this to the world, not because it's about bragging rights, although they were happy to brag, but because it was critical to persuading other nations, especially non-aligned nations, that were not a part of the American bloc to oppose the Soviets, not a part of NATO, for instance. Whose side were they going to be on in a global struggle in which somebody is going to win and somebody is going to lose? And in 61, it looked like the Soviets may have the upper hand because of their military capabilities and their demonstration of this high technology with space activity. So, is a recently independent India going to be a part of an American coalition or a Soviet coalition? Is emerging nations in Africa or Asia going to be part of an American coalition or a Russian coalition? That was what was at stake. And it's important to remember that this is not just about, we want to feel good. It's prestige. Yes, it's prestige, but it's so much more. The Soviet Union was an existential threat to the United States. It is very hard for people to understand that today unless they experienced it themselves. We believed that it was absolutely a great possibility that we could be nuked out of existence at any moment, to the extent that when I was in grammar school in the 1960s, we had duck and cover exercises where we crawled under our desks that would protect us from a nuclear blast. That was, I thought it was stupid when I was 10. And it was. Now there are threats. There's no question about that. And having weathered all of that without being nuked out of existence is maybe one of the great successes of the last half century. But it was a very real, at that particular point in time, that was an existential crisis. And it remained in place until the end of the Cold War, in which the Soviet Union collapsed and was replaced by Russia and other nations around it. We have nothing like that today. We can talk about China as a major threat, and it is, but it is not an existential threat in the same way that we viewed the Soviet Union in those days. So this is a demonstration of American prowess from a scientific and technological perspective, and it was critical for us in terms of the Cold War. And I would suggest to you that having won that Cold War space race, it was a really significant part of the winning of the Cold War altogether. I mentioned to you that Kennedy was already by middle part of 1961 trying to get out of the commitment because of the cost. He wasn't that he opposed the idea of going to the moon. It was just the concern about the cost that was involved in this. And he revisited this throughout his presidency until his assassination. In 1962, there was sort of a hiatus during a more tense relationship between the US and the Soviet Union. Of course, in the context of the Cuban Missile Crisis, a major piece of that. But thereafter, Kennedy returned to the idea of a cooperation effort with the Soviet Union. And in September, he gave a public speech at the UN in which he proposed one more time that we turn the Apollo program to land on the moon into a joint effort with the Soviet Union. And Sergei Khrushchev, who is the son of the Soviet Premier Nikita Khrushchev, recently deceased. He was on the faculty at Brown University. At that point in time, in 1963, was a member of the Korolev Design Bureau in the Soviet Union, and Korolev was the central individual behind the Soviet space program. And so Sergei Khrushchev was involved in this effort. He said he got a call after that speech to the UN from his father, Nikita Khrushchev, to come to the Kremlin and to talk to him about this. And they met that next day and discussed it in great detail. Other people were in the room with them. And they all agreed that it might be a good thing to try to bring the programs, the American program and the Russian program together. For one thing, they could reduce the cost that they had to spend on these space activities, and they could lessen tensions at the same time. They were still concerned about technology transfer and betraying what their actual capabilities were. The Americans were as well. But both sides proceeded in the fall of 1963 with a possible agenda moving forward of turning this into a cooperative effort. Nothing came of it. Kennedy was assassinated in November of 1963, and Khrushchev was deposed not too long after that. And the result was it came to nothing, but it is a fascinating question to which we will never know the answer, what might have been able to happen. Had there been a cooperative venture established in the mid-1960s. And Kennedy was very concerned about this because of the cost and a fear that the Republicans would use this against him in the election when he ran for re-election in 1964. I've sort of walked through all of these particular basics. It was geopolitical. It was expensive. $25.4 billion cost in 1960s dollars. That's approaching 300 billion in today's dollars. Program life, more than a decade, multiple presidential administrations. Obviously, 6 successful landings. The first one in 1969, the last one in 72. 3 circumlunar flights. One was one of those circumlunar flights, Apollo 13, was an accident. They didn't intend to. They wanted to land, but obviously they could not do so. And I'm sure everybody on this webinar is well familiar with that particular story. But this is the chart I really wanted to show you. So this is a percentage of the federal budget allocated to NASA over time. And I used the percentage just so I wouldn't have to deal with inflation factors and all that sort of thing. So you see that big spike, that ramp up in the early 1960s. That is the investment that took us to the moon. And you can see that it peaks 64, 65, 66 time frame, and then it goes right back down. That was what we needed to go to the moon. And at its height, it's approaching 4% of the federal budget. Today, the NASA budget, you probably are aware, is less than 1/2 of 1%. And it's been declining more or less ever since the mid-1970s after Apollo. You have to ask the question, if there is to be a future activity on the size and scale of an Apollo, maybe there doesn't have to be, but if there is, you have to ask yourself the question, what is the driver that will make that budget increase? Maybe not to, 4% of the federal budget, but, maybe a doubling of the NASA budget or a tripling of the NASA budget, which is still not that great. And do you see a reason to expend those resources? The public has demonstrated over and over again that they like space flight, but they don't want to pay for it. And that makes them, that's actually true for almost all government services. We like the services, but we don't want to pay for them because we don't like the taxes. And so I did an analysis a number of years ago on public opinion polls. And, we can talk about the good parts and the bad parts of public opinion polls and how they can be manipulated in certain ways. But I just want to give you a sense of the kind of thing that we're talking about, using 3 graphs of 3 different sets of polls that ask a specifically different question. So if you ask the question, are we spending too much on space? You get the red line. And you can see that it goes up and down. The yes answer, by the way, yes, we're spending too much on space, is what is being tracked here. So, mid-1963, about 35% of the public say, yeah, we're spending too much. It goes down a little bit, 64 goes back up, 65. And then at the time that Apollo is successful in the latter part of the 1960s, it just takes off. Yeah, we're spending too much. The first meeting that Tom Paine, who was the NASA administrator who took over for James Webb in the fall of 1968, his first meeting with the new president, Richard Nixon. Nixon pulls out a bunch of these charts and he says, basically, the problem is you guys are viewed as military expending. And the public doesn't want to spend for Vietnam. They don't want to spend for space, and your budget is going down. There is no way around that. And it's a reflection of that particular mindset. We're spending too much. If you ask the question, is Apollo worth the cost? You get that blue line. And you can see it wavers up and down between about 35 and 45% who think, yeah, it's worth the cost. But that's a whole lot less than 50%. And the only time it gets over 50% is in 1969 at the time of the moon landings, and immediately starts down again. The public doesn't want to do it. They don't think it's worth the cost. But if you divorce your opinion polling from the issue of budget and money, and you say, do you approve of Apollo? And it's a yes/no answer. The yes is tracked in the green line. Yeah, we all like Apollo. It's terrific. It goes down a little bit in 67, 68 at the time of the accident, of the Apollo 1 accident, but then right back up. And at no point does it dip below 50%. We all like it. We don't want to pay for it. And that has been the story of federal expenditures for NASA ever since. The question I always ask people is, a lot of people say, how come we can't get more money for NASA? The question I ask is, how come we're getting so much? when there is clearly not an impetus to do very much. Now, all of this goes away when you're not talking about public funding. If it's about private sector activities, well, if you've got people who want to spend the money, that's fine. But they usually have to have a reason too. And that reason fundamentally is about economics. And the bottom line with Apollo is we didn't want to pay for it, but we also didn't find anything there that we wanted. Again, I'm a historian, so I tend to think about everything in terms of analogies. Terrestrial exploration on this continent, actually anywhere in the world, has been driven, and I specifically would hearken, I heard Josh talk a little bit about Columbus and so forth earlier. The idea behind this fundamentally is exploration. It really takes three basic ingredients to be sustained historically from a terrestrial perspective. One is that the quest for what I refer to them as the three G's: God, gold, and glory. You go somewhere and you find something that you want that's worth money. That's the gold part. Well, the Spanish explorers, the French explorers, to some extent the English, but a little bit later on in North America and South America, found a lot of wealth, most of which they took away from other people. But be that as it may, they found that wealth, and that sustained them pretty fundamentally for a long period of time. In fact, it's that wealth that was extracted from the Americas that made, hard to believe, Spain a world power in 1500. The gold, so that's the gold part. The God part is we're going to go to these new locations and we're going to convert the natives to whatever form of religion exists within the state that is sponsoring these particular expeditions. And then finally, the glory part is the bragging rights. And that's very real, no question about that, but it doesn't sustain very much. That's what the first person goes to, but the second person is not really sustained by that in the same way because it's not about bragging anymore. The problem with Apollo is we didn't find any of the gold thing, anything that we wanted. Doesn't mean it's not there. We didn't find it. Josh talked about helium-3 a little bit and other types of minerals that might exist there, and they may be there. Whether or not they're there in abundance, whether or not they can be mined in a manner that is that makes them cost-effective to extract, all of that's an open question, but nonetheless, those are issues moving forward. So fundamentally, that's why we stopped going in 72. And lots of people have looked back and said, why did we stop? That's the reason. We had achieved the objectives for which we had established that particular program. We had, and there's no question about this, brought into the American sphere of influence a large number of non-aligned nations that were attracted to the American side of this global Cold War struggle because of this and other activities that the US engaged in. We've sought to engage in returns to the moon, and this is one of the great problems, I believe, that we've got in the context of the space community. We learned one of the wrong lessons from the Apollo program, and that is that if we could get a president to make a brilliant speech and set forth a bold vision, all things would flow from it. And we've been successful in doing that several times. So the first President Bush in 1989 stood on the steps of my museum, the National Air and Space Museum in Washington, D.C., and announced that we're going to go back to the moon and on to Mars. And this became known as a Space Exploration Initiative. The budget for that was officially couched at NASA at approximately $400 billion. And oh, by the way, the response from members of Congress when this got briefed to them was, are you people insane? And end of discussion. It went away very quietly at the end of the Bush administration. The second Mr. Bush, after the Columbia accident in January 2004, went to the NASA headquarters and announced that we're going back to the moon and on to Mars. And we're also going to retire the shuttle and we're going to finish the space station and so on. these did not generate much in the way of a positive response. There was no significant increase in the NASA budget to make any of this happen. And it might not require the kind of percentages that I showed you earlier on, but there really wasn't much of anything in terms of a growth beyond that. And so consequently, they just went by the board. The same is true with the Trump administration. In 2019, announced that they were going to return to the moon with a date of 2024. And well, the clock has ticked. We're now in 2021. Does anybody have any possibility to think there'll be astronauts landing on the moon by 2024? No, maybe 2034. Could be a little earlier, but somebody's gonna have to make a decision and spend some and put some money behind it. Famous line from a movie of the mid 90s with Tom Cruise, "Show me the money and then we'll talk." That's the problem we've got. And I would suggest to you that that has been the wrong lesson. We have learned this, but it's inappropriate for us to think getting a president to say these things is going to solve the problem. But the larger question is this one, and it's the family circus cartoon that you can see on the left on this slide. See this little kid looking on television, sees a space thing there. Someday I might travel to another planet, but I'm not sure why. And the why is the core problem. So if there's anything the Moon Society can do to sell the American public on the why, I urge you to try to do it. And I think I will stop with that. There's just I had another slide that I could go through, but I will just leave it there. And if there are any questions or comments, I'm happy to engage.
Well, I love that that's your stopping point, because that is the driver, right? Why are we at the Moon Society event today? Why are we at the Lunar Development Conference today? What is the Moon Society going to do tomorrow and the next day and the next day? What are the members going to do? I mean, I think that is where we are exactly. I am new to the Moon Society, so I'm not speaking on their behalf. But I do feel like that this organization has a tremendous amount of untapped potential. And maybe that is one of the things that we do, is figure out the why, because I think there's a lot of good reasons. So pretty excited about your talk.
Thanks. And by the way, I think the why comes down to economics.
Yeah.
Can,
no argument here. Yeah.
Yeah.
It's the goal.
Is that business case to be made where you can make money going to the moon, people will figure out a way to go to the moon and do things. Yeah. We have done that in Earth orbit. Earth orbit has become a normal realm of human activity really since 2000. And we don't think twice about that anymore. It's a very viable economic activity, but we're not there yet in terms of cislunar and translunar space.
No.
And that's what's got to be found.
I'm particularly interested to hear in about an hour, General Warden is going to come on board, and my claim is that the new moon rush is directly attributable to the missions that he helped foster with Clementine and L-Cross, because when we found water, suddenly we had a why. Suddenly there was gold, that you referred to gold, glory, and God. And
right. Yeah, we haven't found any extraterrestrials to convert yet. But
not yet. Not yet. Well, the report that came out of the Pentagon a couple of weeks ago could have changed that a little bit, but no. All right, sir. Thank you very much. Really appreciate it. I don't know if you saw it in the chat, but I posted a lot of your books, and I'm going to just do a shout out to this paper that you wrote about historic analogs. I posted that also. I think it's particularly interesting and relevant to developing out the moon. So, sir, thank you very much, Dr. Lanius. We're going to move on, and we appreciate your time. Thanks a lot.
Thank you.
All right. Dr. Goswami, thanks for being here today. I have lost your bio, which is really kind of a shame. So I feel bad that I've given absolutely everybody else a an intro, but I cannot find your bio. But here's what I know about you. You're pretty amazing. You're really smart, and you're very, very good at identifying national priorities in space. I'm going to post your book here in a second. I'll find it in a moment. But I apologize. Can you just introduce yourself a little bit more than that? Because you're more than what I just said.
Sure, Michael, and thank you for having me here. Can you hear me all right?
Thank you.
Okay, great. So I am basically an independent scholar working on space policy. I look at the space programs of the US, China, India, Russia to an extent, and as well as middle powers like Luxembourg. Recently, I co-authored a book called Scramble for the Skies, the Great Power Competition to Control the Resources of Outer Space with Peter Garretson. And as part of my research, I also have conducted fieldwork in both China and India. And in 2019, I testified before the US-China Economic and Security Review Commission on China's space program. It's a real pleasure and an honor to be invited to the Lunar Development Conference hosted by the Moon Society. It comes at a very relevant time because, as you would see from my presentation, the moon is becoming a critical focus of not just the US, but for like countries like China, India, Russia, Japan, as well as UAE, and recently Turkey. Turkey's announced a program to go to the moon by 2023. Let me share my slides. So.
I just found your bio like 1 minute afterwards, so I just couldn't find it. I have so many screens open, I couldn't get to it quickly, but I did find it and I have it. So thank you. All right, please continue.
It's a pleasure. Can you see my screen? All right, great. So in the half an hour that I have, what I'm going to do is talk a bit about the cislunar pivot, as well as some of the future missions that are in store for the next 10 to 15 years. And so what is interesting, especially from the perspective of why are we going to space in the 21st century? Roger mentioned this as to why should the US population or the electorate support more funding for space? So one of the articulation that actually has a lot of traction in another country, China, is that the Earth-Moon system, especially the mapping that you have here, including their relay satellite that is at L2, Bao Weiming, who is one of the chief architects and the spokesperson for the China National Space Administration and the Academy of Sciences, basically points out that the return of investment on the lunar surface, including resources and in situ resource utilization, is going to be about $10 trillion by 2050 annually. So for China, the reason why they are actually investing in a lunar exploration and utilization program is not just for the sake of science or exploration, but also because they have identified the very real economic benefits that come from it. And so there's a very clear reason why the state, especially under President Xi Jinping, is investing in a lunar capacity. So if you look at why the moon has suddenly become so critical, especially in the last 5-10 years, we've always known that there is solar energy that can be used. For example, in the peaks of eternal light, there is eternal light. There is oxygen in the moon that can be used not just for life sustainability, but also for rocket fuel. Water, which was discovered for the first time on the Chandrayaan-1, which was India's first mission to the moon through a NASA mineralogy mapper. There is also the possibility of helium-3. And in fact, the reason why some of the scientists from India and China are talking about a lunar exploration program is the possibility of finding helium-3, because in their estimation, that is critical for nuclear fusion. Then there are rare earth elements. For example, there could be iron, there could be platinum, especially titanium, that is possible on the moon as well. But there are also some non-tangible benefits of why the moon is becoming so critical in the space policy focus of countries like China, Russia, Japan, and India. And that is, first of all, it's very proximate. So it's not far away. In fact, if you listen to the recent rationalization of the China-Russia Memorandum of Understanding, their argument is that if you do not sustain yourself on the moon, it is not going to be possible to become a spacefaring civilization. That's the planetary body that's nearest to us. And so their argument is that once you sustain yourself there, only then can you think of further probes into deeper space. The moon has very less gravity. And for example, the next chart will tell you why they are interested in looking at the moon, especially in terms of a lunar base, is because it's not just about, again, exploration. It's also because the gravity well of the moon is much lower than the gravity well of Earth. The struggle that our rockets go through to actually escape Earth's gravity requires 22 times more energy than if you actually construct in situ rockets on the moon and then send probes deeper into space without using much fuel. So there is a very clear articulation of why the moon has become critical in the estimation and thinking of countries besides the US. Now, some of the lead players in terms of the moon is, of course, the US, especially with the recent announcement of the Artemis Accords, where we have about 9 countries that have signed in, including Brazil very recently. So there is that. The second country, of course, is China Lunar Exploration Program, which was established in 2002. So we are actually about 20 years into that particular program. So the one thing I always remind my audience is that it seems like China is achieving a lot very quickly. But actually, if you look at China's lunar space program, especially their exploration program, it's been in the making for the last 20 years. So all the deadlines that you are seeing being achieved, including their lunar far-side landing, the Chang'e 4, for example, their lunar sample return, these missions were actually conceived about 2002 and then was executed by 2007 once they got the funding. But what is uniquely different in China's articulation is, of course, from the very beginning, China's space scientists recognize the why. So they explain the why, that is in terms of lunar resources and economic returns, actually in our interviews that were given in 2002 itself. Now you have Russia, which also has a lunar program, and as many of our speakers have mentioned, have recently signed an MOU. I'll talk a bit about that in the next slides as well. India also has a very experienced lunar program. In fact, India tried to land on the very close to the lunar South Pole in 2019, but failed in the last few seconds. And then, of course, you have Japan with a lunar exploration program and also with very clear-cut ambitions and missions that have been set for the next 2 years. Now, China's focus on the moon, very quickly, it establishes the moon as an Earth-Moon economic zone by 2050. China became the second nation in the world to plant a flag on the moon, a fabric flag. In fact, the Global Times, which is one of the propaganda outlets for the Communist Party of China, very jingoistically stated that the 21st century is the age of Chang'e. The 20th century was the age of Apollo. And so the first flag of the 21st century has been planted by China on the moon. So very nationalistic discourse in terms of why China is going to the moon. Now, this is what they are planning to do in the next, in the next 20 years. The missions that you see in blue are the missions that have already been executed. So in 2020, as we all know, they autonomously brought back lunar samples back to Earth. And then by 2024, they're aiming at bringing samples from the South Pole. 2030, a survey of the South Pole for evaluation, especially its composition. And then by 2035, test key technologies like 3D printing to lay groundwork for the construction of their base. And of course, the first research base on the moon in collaboration with Russia by 2036. So another interesting aspect of China's conversation around the moon is that they equate it to the concept of territoriality. So Ye Peijing, who is the head of China's lunar mission, stated that the moon is very similar to some of the islands in the South China Sea and the East China Sea. And so if we do not lay some kind of claim by way of presence, we will be actually questioned by our descendants. And this kind of logic was supported by Ouyang Jiang, who is their chief designer. And he pointed out that China's long-term aim and task is to set up a base on the moon. And this was in 2002. So they have been actually planning in establishing this base for a very long time. And then again, you can see the development and utilization of the lunar potential mineral and energy resources stated by Luang Angji, who is the former director of the China National Space Administration. Now, some of the treaties that I thought I should mention before I document a bit the other countries and their missions to the moon. As we know, the Outer Space Treaty, of course, limits the placement of any kinds of weapons of mass destruction. The one condition that the Outer Space Treaty lays is, of course, that you cannot have national appropriation of any real estate on any planetary body. But what it also says is that you can have utilization and use. So the conversation coming out of China, Russia, India is that can that utilization be done without actually claiming territory? And the argument seems to be that it can be done. But there are conflict triggers because first of all, the moon is a very small body. And also there are only certain areas on the moon that have resources, for example, the South Pole. And that could lead to some kind of conflict in the future once bases are established. And if China and Russia establishes a zone of non-interference, which Chinese strategic culture thinks about. The Moon Agreement, of course, again, is another agreement that determines the geopolitics of the moon. It has not been signed by the major spacefaring nations, but about 18 nations have signed it. One of the biggest concern on the Moon Agreement was because of the argument that once developed nations function and develop capacity for extraction, this has to be shared with developing countries, even those countries that have not actually invested any resources. And that was one of the main reasons why the Moon Agreement was not signed by the US, China. India is a signatory, but has not ratified it. Now today, of course, the biggest lunar politics is between China, Russia, and the Artemis Accord. So when the Artemis Accords were actually put out by the former NASA administrator under the former Trump administration, the biggest opposition to the Artemis Accord came from Russia. Russia argued that this is about US trying to take leadership and actually establishing a kind of colony. China was much more silent in terms of their opposition, but China was active actually much more than Russia in doing something tangible as an alternate alignment system by actually proposing a memorandum of understanding with Russia. But because, as was mentioned in the panel, China today has the resources to actually invest in a long-term lunar development capacity, and Russia actually has joined in as a junior partner. So just quickly, before I get into a bit more detail about the different nations investing in lunar development, we of course have the Google Lunar X Prize, which I believe is a catalyst for almost all the development that we see today. We have Hakuta, the parent company iSpace, which has announced a launch to the moon by 2022. You have Team Indus, which was an Indian company that was supposed to also launch, was one of the finalists, but of course, the ability to fund for their launch fell out with the Antrix Corporation, which is the Indian Space Research Organization's commercial fund. They had to pay about 20 million, but could not get the funds for it. Today, Team Indus, of course, was part of Orbit Beyond, but then fell out of a contract with NASA. SpaceIL has announced that they would try again in terms of another moonshot by 2024 with the Bereshit 2 moon mission. I was looking at the website of Synergy Moon. They seem to want to have collaboration in terms of international efforts to go to the moon by 2022, this time to stay. And then you have Moon Express, which actually is now competing to become a part of the Commercial Lunar Payload Services Program. So what is interesting is that almost all the 5 finalists are actually continuing their presence in one way or other. The most viable, of course, seems to be iSpace, with a very clear-cut program of going to the moon. So now let's get to the actual, what are we looking forward in terms of the future? So if you look at the timelines that I have put here, so between 2017 and 2024, we of course have the Artemis program, which is a US government funded program and based on international partnerships to go back to the moon with the landing of the first woman and the next man. You have China's lunar exploration program that aims to establish a lunar base by 2036. You have the Japanese Lunar Exploration Program, which is a program based on robotic and human missions between 2007 and 2030. And then you have Lunar Globe, which is a Russian moon exploration program that is timed between 2021 and 2040. Now, by 2022, these are the missions that we can hope to see in terms of their ability to actually meet their deadlines. We have the Chandrayaan-3 from India Space Research Organization, which will be a repeat of the Chandrayaan-2, but will also include a lander and a rover similar to the Chandrayaan-2, but it will not have an orbiter. As we know, an orbiter is already around the moon because of the Chandrayaan-2 mission. You have some private companies that are wanting to go to the moon by 2022. You have Nova C2, which is a lunar lander designed by Intuitive Machines, and which wants to deliver a small commercial payload. I do know that Maston is developing the XL1 small cargo lunar lander, but their deadline has shifted from 2022 as I speak to 2023. So they have shifted it a year back. You have this is the mission to watch. You have the Hakuta R mission 1 by iSpace, which will include a lunar lander and will try to soft land on the moon. So they might actually become the first private company, if they succeed, to land on the lunar on the lunar near side. Now in 2023, there are some major programs that are going to happen. We have Fleet Space Technologies Lunar Exploration Mission. You have NASA's Viper exploration rover. Then you have Hakuta R mission 2 by iSpace and Draper Lab, which will include a lunar lander and a rover. You also have Blue Ghost, which is a lunar lander designed by Firefly, which is aiming to go to the moon by 2023. And then you have the Dear Moon Project, which is a lunar tourism mission. And we all know about that, which has made the news very, very much with Japanese billionaire Maezawa. By 2024, one of the missions that is going to have geopolitical significance is, of course, China's Chang'e 6, which is going to be a robotic Chinese lunar exploration mission to actually perform the first reconnaissance mission for their International Lunar Research Station with the aim to bring samples from the lunar South Pole. You have Rashid, the UAE's first lunar rover, which will include high-resolution cameras, and it's going to be launched on iSpace's space platform. So you can see collaboration between UAE and Japan. You also have Blue Moon by Blue Origin, which is a robotic space cargo carrier, which had aimed to be able to go to the moon by 2024. And then you have Roscosmos, Luna 26, which is a lunar polar orbiter, which plans to function as a telecom relay between the Earth and Russian landed assets. So between 2025 and 2027, again, you have several major Russian lunar probes. You have the Luna 27 with collaboration. And this is interesting because the Luna 27, which I don't think gets reflected in our conversation, is actually a collaboration with the European Space Agency to go to the moon between Russia and Europe. So they're planning to go to the South Pole Aitken Basin by 2025. You have Luna 28 again in 2027, which is again another mission that plans to go to the South Pole with the objectives of a sample return to support the Chinese mission a year earlier. Now, between 2028 and 2030, you again have several missions, but again, the mission to watch, I would say, are the joint Russian-Chinese missions. So China's Chang'e 7 will be an orbiter, rover, lander, and hopper to make detailed surveys of the South Pole region, covering the terrain, geological composition, and location of polar water ice. So I think that's one of the missions that is going to be utilized for the establishment of the Lunar Research Station. Now, in the last few minutes that I have, I'll say that one of the interesting insights that I got last month in June was when the China National Space Administration released their detailed roadmap of how they are going to actually create this international collaboration with countries, especially along the Belt and Road Initiative. So you can see these are the maps that they have put out in their detailed analysis of how they're going to go about. So they're actually starting the construction by 2031. So you can see that this planning has been happening for several years now. So by 2030, they'll finish the survey of the moon's South Pole. And then by 2031, they'll actually start the construction of the International Lunar Research Station. And they hope to complete it by 2035. And these are some of their concept designs of how the International Lunar Research Station would look like. And if you see their launch platforms, by 2035, they will have their heavy lift rocket, which is the Long March 9, which is capable of taking 140 metric tons to low Earth orbit. And the aim is to have 10 heavy lift rockets in 1 year. So they are actually having several missions planned by 2035. And so before I end, I would say that there are several reasons why all these countries are looking at the moon. Basically, some of the missions are about investigating the origin and history of what the moon is. For example, Leonard Davis made an interesting point that we don't have that particular data as yet. So you have the Japanese Space Agency that is actually investing in looking at that kind of understanding of the moon. You have NASA's Lunar Crater Radio Telescope, which will of course be there in terms of astronomy, and the European Space Agency that is taking steps to understand how to extract resources like oxygen and water on the moon. Now, the Earth-Moon future, as I see it from my analysis of China, Russia, Japan, India, is that the basic priority is to actually establish permanent presence on the moon and to be able to sustain human presence. So some of the developments we can see by 2035 is that there will be helium-3 that will be extracted from the lunar regolith. We could have lunar mining, but what I see from the mapping of China especially, which is the most serious space lunar program, is that this will be based on autonomous capacity. And they are basically investing in that capacity and becoming leaders in artificial intelligence and robotics. And we would see moon ports in terms of their articulation. And so one of the connected technology, which I thought I should bring to the conversation, is that if you listen to China's articulation of their lunar exploration program, they're also developing a simultaneous technology that they think will benefit their lunar base, which is space-based solar power. So one of the designs which the China National Space Administration has developed is, of course, the design on the left. And this is what they plan to do. So they are hoping to actually be able to process a megawatt level space solar power station by 2050. We also have very small experiments in the US. The Air Force Research Laboratory has an experiment going on as we speak, and the US Naval Research Laboratory has an experiment in space trying to understand power beaming. So these are very interesting times in terms of looking at space, not just from a prestige reputation perspective, but actually from the perspective of the economic returns. Now, this is the present that you're looking at. This is not the Cold War. This is not just two space powers having space programs that are actually dominating the world. I thought I would create this map so that you get a sense of what has happened since then. It's unbelievable if you look at this map, how many space agencies have been established. And the recent, of course, as I mentioned, is the Turkish Space Agency that has announced a program for the moon. And you can see that Africa is starting to become very, very serious in terms of collaborating with China, in terms of the Belt and Road Initiative to go to the moon, if possible. And I think it will be, because the China-Russia International Lunar Research Station is calling out for partners in terms of creating that alignment structure. I'll finally end with this. So one of the important points in terms of looking at the lunar development is that we sometimes forget that the technology development is not the end goal. So if you look at China's articulation of why they are investing in the moon and why they are actually talking about cislunar space, it is located within the ideological perspective of President Xi, who wants to establish China as a lead actor in space. And one of the books which I found very insightful was The China Dream by Lu Mingfu, a retired colonel from the People's Liberation Army, who pointed out that the ability to persuade or coerce countries to behave in a manner that is beneficial to the country, yielding space power, is important. And that is why China should actually invest in an independent launch capacity, project and maintain military space power, and enable access to key zones in space, to include the moon and the Lagrange points. And this particular book actually influenced some of the People's Liberation Army Strategic Support Force leaders, like President Yang Zhuling, who pointed out in 2016 that China's focus is the Earth-Moon zone. And as Joss was mentioning, It's very critical that China's understanding of space warfare or war in general is that you actually win without fighting. So you develop your economic prospects and you establish yourself as a lead player without actually breaking down into war. And finally, I'll end by saying that this is what President Xi pointed out in terms of China's space dream. So he said, experience tells us that great undertakings begin with dreams, and dreams are the source of vitality. China is a nation that pursues dreams bravely. The Communist Party of China's Central Committee's decision to implement the Lunar Exploration Project is to pursue the nation's unyielding dream of flying into the sky and reaching for the moon in the journey of building a great modern socialist country and realizing the great rejuvenation of the Chinese nation. And what is insightful is that space is now included in terms of the China dream and is part of the civil military fusion strategy. Michael, I think I'll end there and look forward to any questions.
Terrific, fascinating. So many things I want to talk about right now. First of all, I wanted to say thanks. Those are amazing slides. Like the effort you put into putting those slides together is very nice. So, I actually was when you started this presentation, I was watching to count how many missions, but then I got caught up in the details as you were describing them. So I didn't actually count how many missions, but it feels like it's a lot of missions to the moon. Did you count them? Do you know what the number is?
Well, from the top of my head, if you look at China's missions, there are about 12 missions.
12.
Till about 2036. But then they are now collaborating with Russia, which also has about 10, 12 missions. So that itself makes it about 22 missions. And then you have the missions from Japan every year from iSpace. So that is about 4 missions. And so I would say that if you count India's missions and UAE's rover, I think it's about 30 missions from the top of my head. And that's yeah. And that's just in the next 5-6 years. So we are not even talking about the distant future.
No, right.
Right? Yeah. So it's quite a lot.
I mean, you know, to go from Dr. Lanius to Dr. Goswami, right, where we had two nations, 2 budgets, and 1 goal, right, the moon, versus I don't know how many space agencies you showed on that one screen, but you know, half a dozen or a dozen lunar missions. I don't know how many budgets that means. I don't know how many companies or organizations involved, but it is really quite astounding to see that evolution. So thank you for showing us that kind of depth and width. It's a new world right now. Like we're in a new space.
Yeah, and I think, Michael, I would like to reiterate that it's not just, so there is a misunderstanding that just because we are talking about space, it's all about wonderful cooperation. That is what we aspire for and we hope for. But if you look at the programs, for example, China and Russia space program, Turkey, for example, India to an extent as well, these are very nationalistic space programs. Yeah. And so China, what it has very cleverly done is that it has actually established a Belt and Road Space Information Corridor in the last few years. And this is President Xi's thinking in terms of institutionalizing the Communist Party of China. So Xi learned a lesson from Hu Jintao and Deng Xiaoping that if you want to have the Communist Party of China as a central body in terms of decision making, you must have it institutionalized, including in foreign policy. So the Belt and Road Initiative, including space and the Lunar Development Program, has got credibility today because China has demonstrated capability. It's not like they're just saying things, they're actually executing those goals and meeting those goals, including their first landing on Mars this year, right? Which was a big achievement for them. Yeah. What that does is that it attracts partners. So for example, Turkey, Saudi Arabia is now talking about collaborating with China. France recently said that they are actually thinking about collaborating with China and Russia in terms of their lunar program. The first conversations I hear. So you have an alignment structure here that's vying for partnership with regard to the moon.
You know, Roger was talking about glory, God, and gold, it definitely feels like there's a lot of glory to be had. I think that's why India attempted their mission, Israel attempted their mission. It's time. It's time for other nations to start developing their own lunar systems for their own glory. It's amazing. It's an amazing time right now. Thank you, Dr. Goswami. We're going to move on. Really appreciate your time here and your insight. Dr. Warden, really excited to join for you to join us. Thank you very much. Let me jump over and get your bio here. Okay. Pete Warden, retired Brigadier General from the United States Air Force. Dr. Warden is the chairman of the Breakthrough Prize Foundation and the executive director of the foundation's Breakthrough Initiatives. He holds a Bachelor of Science degree in physics and astronomy from the University of Michigan and a PhD in astronomy from the University of Arizona. Prior to joining the Breakthrough Prize Foundation, Dr. Warden was the director of NASA Ames Research Center at Moffett Field in California until his retirement in 2015. He has held several positions in the United States Air Force and was research professor of astronomy at the University of Arizona. He is a recognized expert on space and science issues, both civil and military, and he has been a leader in building partnerships between governments and private sector internationally. What is not posted there is that, in my opinion, I'm going to give the guy credit, that between Clementine and L-Cross, those two missions are one of the reasons why we think there's so much water on the moon. And I think it's the reason there is a moon rush. So I'm just going to personally give you credit for starting what I think will be a stampede. So really glad that you're here, sir. Please continue.
Thank you, Michael. Can everybody hear me all right? What I'm going to do is talk a little bit today about my own personal past. I'm almost 72. It's appropriate. I'm speaking to you from Trier, Germany, which was the oldest city in Germany. It was founded by Julius Caesar in the 1st century BC. So probably an appropriate place to speak from. But I've got a little presentation here. Let me see if I can share the screen. You know, as I noted, this is kind of a personal story, but you know, I should probably give you a little background from my sponsor. I'm the chairman of the Breakthrough Prize Foundation, which was founded about a decade ago by a number of Silicon Valley moguls. And the first thing that we do is the Breakthrough Prize, which is the largest prizes in science. There are about 7 $3 million prizes. It's about, I might mention, it's about 3 times the size of a certain Swedish prize I'm not supposed to mention. But there are fundamental prizes in physics, mathematics, and life sciences. We also have early career prizes, and I'll talk about another prize. But how I got involved in this, as was noted, I was the director of NASA's Ames Research Center. And about 10 years ago, the Vanity Fair came to see me, and my chief of staff said I would never guess who was in my office, and I said, no, I probably wouldn't. And she said, it's Vanity Fair. And I said, well, are they here to see me because I'm the best dressed center director? And she says, no, you're kind of near the bottom. But it turns out that Vanity Fair puts on the post-Oscar party, which I've never been invited to, I keep hinting. But it's supposed to be the coolest party in Hollywood. So the idea that we're going to set up the coolest party in Silicon Valley. And it's sort of now called the Oscars of Science. And it really is quite a ceremony. And since I was the landlord, you always invite the landlord for having a rowdy party. But this is really quite an interesting affair. It's the only big black tie affair in Silicon Valley. Hopefully we can have it in person here in the next few months in the fall. But I want to mention one particular recipient a couple of years ago. This is uh, uh, you know, the basically the inventor of the discoverer of the pulsar, and she was a graduate student, Jocelyn Bell Burnell, at Cambridge University in the 1960s, and she discovered this sort of strange signal that her advisors told her was rubbish. And in fact, she initially called it little green men. It was a radio signal, LGM1. And she persisted, and it turned out eventually to be the first radio pulsar, first pulsar. It eventually got published, and the Nobel Prize was awarded, interestingly enough, to her advisors, but not to her. And we thought that was a great injustice. And Jocelyn is quite an impressive scientist in her own right now. And so we awarded her the Breakthrough Prize in Fundamental Physics. To her great credit, she spent the $3 million on founding graduate and postdoctoral fellowships for underserved groups, particularly women. So, hopefully we remedied the injustice a little bit. We also have another program which is for young people. I put this up because I'm kind of excited about it. I'm the chairman of the selection committee, but we give a Breakthrough Junior Challenge Prize to a person between the ages of 13 and 18. They're asked to do a 3-minute video on some principle of physics, mathematics, or fundamental biology. It's sort of interesting. We've now given 6 prizes. We're about to award the 7th. But the winner gets a $250,000 scholarship wherever they want to go. The school where they attend gets a $150,000 laboratory. But to me, what's one of the neatest things is the teacher that the student identifies that inspired him or her gets a $50,000 check. And it was interesting. The first young man that won this was from Cleveland, Ohio, and he didn't tell his teacher he'd nominated him. So when we called the teacher and asked where we send his $50,000 check, his first question was, "Is this a call from Nigeria?" And we finally convinced him, no, it's we're really serious. You're really the winner. The second part of what we do, and I'm not going to really talk about this other than say this is what I spend most of my time on, are a series of initiatives that were started in 2015, funded by one of the Breakthrough Prize founders. At the Royal Society in London. As you can see, the very famous scientist there, Stephen Hawking, was our scientific advisor until he passed away a couple of years ago. But the initiatives include 3 fundamental questions: is all about life? Is there life elsewhere? Is there intelligent life elsewhere? And can we travel between the stars? Well, let me now turn to the moon. I'm an old guy. As I said, I'm almost 72. My first involvement with lunar program was the Apollo 13 mission. Maybe it's appropriate that it didn't work so well, but when I was a college student, I was part of the Air Force Reserve Officer Training Corps, and they took us down to see the Apollo 13 spacecraft. It was about 3 or 4 weeks before it was launched. It was being stacked in the vehicle assembly building, so it was kind of an exciting experience for a young guy who was already convinced that I wanted to dedicate my life to science and space exploration. The role I actually played in Apollo 13 was minor but interesting. I was an undergrad at the University of Michigan, and there was this observatory that the university had that had been founded in the 1930s. And this is kind of a recurring theme, at a wealthy individual's estate not far from where I lived in Lake Angeles, Michigan, called the McMath-Hulbert Observatory. It still kind of exists, but in ruins. But one of the things that we were under contract for when I was there was called flare patrol observing. So during the Apollo programs, there was a lot of worry that if there had been a major solar flare, the astronauts would have been in grave danger. So there was a network of observers around the world that looked at the sun every few minutes to see if they could detect a solar flare. Or you could. It was there was a filter on the telescope that filtered it all with the red light of hydrogen alpha. And so actually during the Apollo 13 mission, I was actually started working there in April of 1970. I was one of the flare patrol observers, and now it turns out there was a ultraviolet leak in the filter, which was discovered later. So if I look very carefully, I've got a hole burned in my retina. It doesn't do much other than I can see it on occasion. So this is my wound from Apollo, and so I feel proud that at least I took one for the team. My next experience with the moon was somewhat later, but let's see if a lot of you may remember now that on the 20th anniversary of Apollo, President Bush, George H.W. Bush, committed us to go back to the moon and on to Mars, and a lot of us said, look, all we needed to do was have a president like John F. Kennedy did to say we're going to go do this again. So this was it was a hot, nasty summer day in Washington. I had started working at the White House a few months before this, and I was actually the staff officer for the Space Exploration Initiative. So we were all quite excited. You can see here that President Bush signing it with the vice president who was running the Space Council and the Apollo 11 astronauts, along with the NASA administrator, Richard Truly. So we said, okay, we're on our way. Not too much time later than that, we were bemoaning the fact that NASA had done what's called a 90-day study, which said, well, we needed to triple their budget and make the space station even bigger, buy another half dozen or dozen shuttles. And we were quite upset with that because it was clearly that wasn't going to happen. But it turns out another staff member and I, Stuart Nozette, who later got in quite a little bit of trouble, that's another story. He just got out of jail a couple of years ago, and I went over to a bar nearby. This plays a big role actually in a lot of things that gets done to get the moon move forward. And it turned out we were meeting a congressional staffer who was late. So we started, Stu started scribbling on a napkin, which I've actually got the copy of the napkin here. And said, well, why can't we do much cheaper missions than, $500 billion in 1989 money. And we've been working a lot with the Defense Department on the missile defense program. And so this napkin actually suggests modifying one of the space-based interceptors called a Brilliant Pebble at the time, that could we go to the moon? And what's kind of neat is, this is actually a real case of making the design on a napkin. So the mission was started, and a couple of years later, I went over and ran the technology program. And we did the Clementine mission, and it turned out, interestingly enough, I was actually fired just before the mission was launched, largely because I was doing Clementine. It was actually a kind of a sneaky space weapon test that got around the anti-ballistic missile treaty. It turns out that the treaty said that you couldn't test missile defense sensor or systems in Earth orbit. So we sort of figured out, well, that doesn't say anything about the moon. So the lawyers agreed, and so the Strategic Defense Initiative Organization went ahead with the Clementine mission, which you can see the logo here. And we basically picked Clementine as from the Oh My Darling Clementine. We said we had enough sort of, goofy Greek gods and other things that NASA named missions after. So why don't we pick something that's generally American? It was a very successful mission. It went to the moon. It mapped the entire moon. It discovered the first evidence of ice in the lunar polar regions, which I think is a really key discovery. We were then going to go on and visit asteroids. Unfortunately, we had a software glitch and we never got to the asteroid. But a very fun mission. As I said, I did get fired over doing this because when the new Clinton or the new Clinton administration came in, they decided they didn't really want to do space weapons, and they finally figured out this was a nasty space weapon. So it was the program. They thought it was going to fail, so they let us launch it anyhow. But this was my first real lunar mission. It's a very, very exciting mission. You know, a decade later, another president decided we were going to go back to the moon and Mars. This was the vision for space exploration that NASA had worked very hard. You know, the previous effort was a complete failure, but shortly after this started, it turned out I was in the running to be the NASA administrator, but didn't get selected. It's probably a good thing. I got fired probably within a year or two. But I was given the job in 2006 to run the NASA Ames Research Center, which I think is sort of the renegade center in NASA. And it was a really cool job. And it turned out I was promised that NASA, that we could lead the new lunar exploration program, the robotic exploration program, not the human exploration program that President Bush had just started. It turned out that didn't last very long, and I'm probably known a lot for writing a paper, 20 years before that referred to NASA as a self-licking ice cream cone. And the reason that we called NASA a self-licking ice cream cone is that it had become basically a jobs program, and within about 2 months of me taking over at NASA Ames, the lunar robotic exploration program was sort of ripped away from us because that one of the bigger centers decided they wanted it, and they got it largely due to, and I won't go into details of who the person is in the lower right, but you probably all know him. And Alabama got the lead for robotic lunar exploration programs. The point is that national programs, particularly in the United States, are traditionally have been based mostly on regional politics, and I think that's a huge problem. And the reason I wrote that paper about 15 years before that date was to sort of decry that. But it turns out that Ames had already been given one mission, which they allowed us to continue, which was the Lunar Crater Observing and Sensing Satellite. Very, very cool mission. Was launched in 2009 in the midsummer. It was basically a secondary mission when the lunar orbiter, lunar reconnaissance orbiter that NASA Goddard was running was launched. And what we basically did is we attached a small satellite. It was basically an adapter that for CubeSats and small sats to the upper stage of the booster. It was an Atlas booster. And it turned out this was kind of a really cool mission because this was NASA Ames' first really big mission that we ran. And I have to tell a little story here that it was if you've ever been to a NASA launch at Kennedy Space Center, there's a formal event called the Final Readiness Review. And there's this huge conference room. It was 200 or 300 people in it, and there's a big wooden table in the center, and that's where the primary players for the mission sit, and they go through all these briefings, and then they do a readiness poll. And this was the first time that I was allowed to sit at what I call the adult table, and so they got around to me, and I couldn't resist being kind of a bit of a smart aleck. And so they'd gone through, said, launch vehicle is go, the range is go, weather go, so on and so forth. NASA Goddard was the primary mission, go. And of course, we were the secondary mission. I said, NASA Ames is go for the first precision bombing run on the moon. And there was a sort of a nervous laughter around the room. And so I decided this was really cool and put it on Twitter. And I got in a lot of trouble because the Clementine mission was kind of considered to be a bit of a secret defense mission. And various people said, I was a retired general. And they said, well, this must indicate that there was that NASA had detected an alien base on the moon and was working with the CIA and to bomb this alien base. And the scientists that were running the program, my program after it, I said, what did you say that for? I said, oh, nobody will pay any attention to that. It turned out it got a lot of attention. I got all sorts of emails from people that said, oh, I'm a mother, I've got 3 kids, they want to grow up, please don't start an interplanetary war, and so on and so forth. And I was counseled by the NASA administrator. It was at that time it was Charlie Bolden, and he said, what did you say that for? And I said, it was just a joke, everybody knew that. And he said, well, actually, I've got some congressmen here coming to my office that want to understand why we're working with the CIA to bomb aliens on the moon. But anyhow, it was a very successful mission. The aliens are gone, by the way, and it confirmed that there was substantial amounts of water in the lunar poles, permanently shadowed craters, something like 5% by volume and weight, and I think a very important result. So I'm quite excited about this, despite the fact I almost got fired over it. We finally got a real mission, and we had to be a little secret about it. So we had it in an old paint shop that the Navy had at NASA Ames. My staff called it Area 51. And we were trying to develop a lunar lander, a low-cost lunar lander that would cost tens of millions, not hundreds of millions or billions. And so we had what's called a hover test facility where we demonstrated that this thing might work. Again, I almost got fired about it when it got public. But in the end, we did get this mission called LADEE, which we were forced to work with NASA Goddard, which just meant the cost was 3 times higher. And but they're very good, so it actually worked. This was the lunar atmosphere environment observer in it to explore, and it was designed to study the residual lunar atmosphere. Again, a very, very successful mission. We actually launched it on a refurbished Peacekeeper. It's called a Minotaur 5 from the Wallops launch complex in Virginia. And this is a pretty cool mission. It was launched at about midnight, but it turns out it rained a lot just before it got launched, and there were pools of water nearby. And when the booster, which is a solid fuel booster, launched, apparently there was a nice frog that was sitting quietly in one of the ponds, and it all got blasted into the air. So this frog is immortalized here on this image when LADEE was launched. And my wife is quite a sort of animal person, and she asked me, "Well, is the frog all right?" And I said, "Dear, I'm sure the frog is wonderful." I didn't have the heart to tell her it was probably immediately roasted to death. But again, so in addition to going to the moon, we also launched a frog. I just want to point out that there's a lot of discussion, and this is kind of what I want to talk about the next few minutes. That all we needed to do was have the President of the United States, push us to go back to the moon. And again, we had 2 presidents that said we're going to go to the moon, both Bushes, and that didn't go anywhere. When I was at NASA, we got President Obama to say we're going to go to an asteroid. And you probably remember the asteroid redirect mission. There was human missions going to asteroids, and of course that didn't go anywhere either. So I think one of the big concerns that how do we address this issue of we've gotten now a number of presidents to say that we're going to go to the moon. I mean, most recently was President Trump said we're going back to the moon, and so forth. So I don't think this is really the way it's going to happen. So one of the things that I've done is to try to find other countries that may have a better effort. And one of the reasons I'm in Europe is I'm a advisor to the Grand Duchy of Luxembourg. In 2016, they announced the Space Resources Initiative, which is an effort to go to the moon and Mars or moon and asteroids to get resources that would benefit people on Earth. And this is a picture of the announcement. The formal press conference, you see me on one end, and the other end is Jean-Jacques Dordain, the former Director General of ESA, and the Prime Minister and Deputy Prime Minister of Luxembourg. So Luxembourg has put hundreds of millions of euros into this topic, and is very much focused on not traditional space exploration, but on commercial development of space, and particularly of lunar and asteroid resources. There's about 30 or 40 startups now in Luxembourg. There's a number of programs. Luxembourg was one of the first 6 countries that signed the Artemis Accords with NASA to focus on space exploration, particularly the commercial development. Luxembourg is kind of interesting. It's a small country, only 600,000 people. It's also the richest per capita country on Earth. So they've done a really good job of getting marshaling support for commercial use of space resources. A lot of countries won't sign an agreement with the United States because we're a big bad superpower, but small Luxembourg is able to do a lot, and they've moved this forward quite impressively in terms of beginning to get a consensus. I mean, there's still arguments about use of lunar and asteroid resources. I want to close with a discussion of the private sector of the moon. In 2014, when I was still the director at NASA Ames, I had a number of young people that I brought to Ames that were quite excited about space and the moon. There was one group of them that were kind of led by a young British guy, Will Marshall, and that in 2014 they had managed to get a couple, really big billionaires in Silicon Valley interested in the moon, including Sergey Brin and from Google, and a number of others. So we had a little workshop, and the workshop, was very well attended by a variety of people, former Apollo astronauts and other experts on the moon. And the conclusion was that we could probably establish a lunar settlement within a decade, for something of the order of, a few billion to 10 billion. And so they established, I think it was in 2017, Open Lunar Foundation, which is focused on basically lunar settlement, private lunar settlement. I want to note that these people founded Planet Labs that just a few days ago, had their IPO at a $2.8 billion initial offering or valuation. So these folks personally now are, I don't know if they're billionaires yet. I mean, of course, this is a valuation. They actually got it. But at least they've got a lot of money to go ahead and start. So I think that we're beginning to see, a really significant interest in this, and they've got a lot of other, high net worth backers. So I suspect we're going to see private lunar settlements, hopefully by the end of the decade, and if not soon after. So, whereas I'm concerned, as Namrata was, that of Chinese and other efforts, but I think that in the end that these private efforts, coupled with efforts of smaller countries like Luxembourg that are going to that are really emphasizing private space development and development for economic purposes, that in the end, I'm pretty confident that you know, the winning combination is going to be in these private sector efforts. And of course, you know, there's many others. You know, obviously Jeff Bezos is interested in using the moon. Elon Musk is certainly as well, and a lot of it again is based on space resources. I think initially for fuel. And I have to really close that I'm sort of, I suppose, sort of interested in, and I'm sure there are other discussions in this conference about where we're going to settle. And I think lunar lava tubes is kind of an interesting location. And this is my own personal suggestion, is where these private sector groups might end up. There's probably some of these lava tubes have a lot of water resources and other things. And I think that's where we're going to go. Well, let me close there, and I think we got a few minutes here for some questions that I'd be happy to address.
There's so much here in your talk. Thank you very much. I'm gonna pass the first question off to Professor Thangvalu. I think you know him at USC. But his first question is, will we see private crews landing before Artemis? That's like throwing down the gauntlet on that one. So that's.
I don't know. I think so and hope so. You know, of course, I love the government. I mean, I spent most of my career working for the U.S. government, and you know, I now still work for governments. I work for the Luxembourg government part-time, and but I think in the end, my bet is on the private sector.
Yeah.
And it's you know, I suspect that, you know, I mean, okay, already the Artemis schedule is sort of thrown the 2024 date out of the window, and you know, I mean, this is the government after all, so you know, at the end of the decade maybe. But I think these private groups are pretty serious, and I think they're gonna do it. And you know, I don't know which one will be first, but you know, it's sort of interesting when I met Jeff Bezos about 20 years ago, and it was in a kind of a breakfast cafe in Seattle, and you know, when Jeff comes in, you know, when you meet him, you know, he just strikes you as a standard sort of computer geek, and with kind of a very unique laugh. And so you know, after we had a few you know, some breakfast, you know, I asked him what his objective was. He says, "Look, I'm just selling books so I can build rockets." And of course, he sold a lot of books, so you know, I think that he's pretty serious. I mean, I know Elon Musk, and you know, he's very serious and is done what he said he did. I mean, not as quick as he said he was going to do it, but there's a lot of others that and I sort of, you know, focused on one group. You know, these young people that I brought to Ames with me, you know, here, you know, 15 years ago, they've all said they want to do lunar settlement, and they've both mobilized high net worth people, and now they themselves are high net worth people. And so I think they're pretty serious. They're gonna get to the moon, and there are probably others. You know, one of the other groups that I've been working with is Rocket Lab.
Yep.
You know, Peter Beck is the founder of that. When I was at NASA Ames, he showed up there as this sort of kind of wide-eyed, you know, young New Zealander that was going to build a rocket, and he had an idea of what he called a toothpaste rocket, that you had a solid fuel that if you put it under compression, it would turn to liquid. We worked with him, and of course that didn't work, but he's now interested in sending private probes to Venus. And in fact, my foundation is working with him on some possibilities to look for life. And so I think these folks are pretty serious, and they're probably going to succeed.
Amazing. It's so much fun to watch this stuff unfold right now. I feel like every day there's a new breakthrough, a new opportunity. James Burke, the vice president of the Moon Society, asked a question. When you were working on Clementine, did you expect to find water, or was that somewhat of an accident?
Well, it's an interesting question, and you know, I have to give credit where credit's due. Stu knows that, who you can probably look online as an interesting history. He and I were at many bars, and you know, after the mission launched, you know, he showed up and said, "Look, you know, there may actually be water on the moon." And he looked at, there were other data that said there could be, and he sort of waxed rather, you know, kind of almost religiously. And he said, "Look, I don't believe in God, but if God intended exist and intended us to go to space, there would be water on the moon as a to encourage us to move on out." And so he and some graduate students devised this idea of using the Clementine radar as a and this was after it was launched, is a bistatic way to get into these craters. I mean, the geometry was just right that you could bounce the signal off the floor of these permanently shadowed craters and actually get data. And they figured out that it would be circularly polarized in a certain way if there were crystalline structure that was most likely ice. And you know, we did the experiments, and sure enough, it was positive. And I mean, it wasn't proof that there was ice. And of course, then another unique mission, NASA Ames had, well, I think it's Lunar Prospector mission, that was again a kind of a private sector thing with Lockheed Martin, and who were trying to build a new booster. And you know, it began to look, you know, discover neutrons and things that suggested there was water there. And then the L-Cross mission proved it. It was sort of interesting. Stu, just before he ended up being a guest of the U.S. government for about a decade, you know, after we discovered that the ice, he said, "Remember, you guys didn't discover it, I did." And I said, "Well, that was my program too." But yes, it was you know, it was a bit of a serendipitous discovery. We were just trying to do space weapon tests.
So let's talk about the future, right? So you're in the spot, you're in a very influential and inspirational position with Luxembourg. I know that you've worked with other nations as well. I won't out anybody that you don't want me to say, but what are they trying to do, right? Nobody thought that Luxembourg was going to be a space power. Like, that caught me off guard. So in a nutshell, what are they trying to do? What's your role there? And what are their expectations? What are their hopes?
Well, Luxembourg is an interesting country. You know, in the mid 19th century, it was kind of one of the most impoverished places in Europe. It had been fought over, and you know, it was kind of divided between Belgium and France wanted it back, and the Germans wanted it. And so a compromise the British negotiated in the mid 19th century was, you know, the half of it spoke this bizarre Germanic language called Luxembourgish, was granted independence, you know, but it was subject to the Dutch crown, and that didn't work out very well. But Luxembourg, you know, had really no resources. It was a small agricultural country. Over half the population immigrated, many of them to the New World, you know, Canada, the United States, and actually Brazil. And but then they discovered iron ore and coal, and they built a steel industry that was very successful in the late 19th century. And in the 20th century, the very successful steel refining and industry attracted the attention of its big neighbor to the east, who twice decided to incorporate Luxembourg into the Greater Reich. You know, and that wasn't very well received, but fortunately they again gained independence. There are stories there of what the Grand Duchess had to do with the President of the United States to get that agreement, but anyhow, we'll leave that for a drink. And but they realized in the steel industry wasn't going to last forever. So in the kind of late 60s and early 70s, they started to get other industry in. And one of them was communications. They'd long been the only country in Europe that actually allowed commercial radio broadcasting, and banking. But they understood all these could all leave in an instant. And so in the 80s, they decided that they were going to finance their first commercial, ComSat outside of the United States, and they formed SES.
SES Global, yeah.
Which is now, essentially the biggest ComSat, geosynchronous ComSat. And it turned out the deputy prime minister told me there were a lot of debates in the parliament where, what do we need this for? We already have, 2 channels of TV that are from 5 to 10. Why do you need all these other things? And they're worried the satellites are going to fall down and Luxembourg would be liable. It turned out they actually had the first satellite failed. They self-insured it. It was about 5% of their gross national product would have, so I think it's pretty gutsy for a country to say, I can't imagine the United States betting 5% of our, GDP on some space thing. But it turned out to be very successful. And as they said, Luxembourg's a lot bigger in space than it is on the ground. It's 1,000 square miles on the ground, and it's got, between Intelsat and SES, it's got, over 100 satellite slots. But they decided to expand on that. And in the, this last decade, and it turned out that, my first interest in Luxembourg was we had hired a postdoctoral fellow who was one of the first people the government had actually sent to get his PhD in astronomy at Ames. And, he told me, like most Luxembourgers, he likes to drink wine, and so do I, that I should go visit Luxembourg. And so I said, really? I said, I thought that was a little country you went through to get cheap booze and gas. And he said, no, he told me about SES. And so I ended up showing up, and I ended up meeting with the Minister of the Economy, who was soon to become the Deputy Prime Minister. His name's Etienne Schneider. And his family had made a lot of money in the mining concerns. And, he was, one of the coalition leads, and actually his party is the Socialist Workers' Party. So, but it's sort of interesting. I asked him once, I said, there can't possibly be any socialist workers left in Luxembourg. And he said, well, that's our problem. We're losing votes. And I said, so your only socialist workers are like junior bank vice presidents, I assume. And, but anyway, they were very successful. And, they really put Luxembourg on the map. They believe by the end of this decade that 10% of their GDP will be space.
10%.
And it's, they're already a couple percent. And, so it's been very successful. It's really put them on the global map and global attention. They've got a very robust, diplomatic effort around the world, and that's been very successful in beginning to build consensus on commercial space resources. They sponsored there was I guess called the Hague working group that was looking at, how do we, rather than just throwing old treaties out the window, we just, what's the protocols to allow this? So, I'm sort of impressed what small countries can do. If you want to see the prime minister, his office is off the central market. You just go in and knock on his door, and it's it's very hard to do that in the United States. To just, a century and a half ago, you could go see the president, but you can't do that anymore. So it's and there are other countries. You mentioned I'm working now with the Kingdom of Bhutan and Rwanda. That I think some of these smaller countries, they understand that space inspires their people. Space has been very valuable for Luxembourg to inspire the next generation of people to go into these high-tech things. So I just like the United States and China for that matter.
Terrific. One last question as we wrap up the day. Josh Carlson talked earlier about some of the development process is as we, you know, as Americans moved across the West, and then using some historical analogies, kind of trying to figure out how we move out to the moon. And then also tomorrow, Major Sean McLean, active officer for Space Force, is going to be talking about some of his research and development of the cislunar environment. But and then also, I think Pete Gerritsen is going to be talking about a paper that he just recently wrote. So can you give us the Warden line idea? Can you talk to us about the Warden?
Yeah, just briefly. This was one of my students at Ames is Matt Daniels, who works for the Office of Net Assessment in the Pentagon, and also is the at Georgetown University. And he and I had a lot of discussions, again, like most good discussions, over many beers.
Yep.
Yeah, and we began to talk about that there's what really matters in the future is things that are in cislunar space and beyond. And so, we began to discuss where does that begin, and where do you begin to have the domination by the Earth-Moon gravitational system, rather than just the Earth. And it turns out it's roughly 100,000 kilometers up. And so he had some briefings he gave at the Pentagon and the White House and other places that, in honor of me and the many beers I'd given him, it was called the Warden Line. And, but I think that's an important place that I believe the future competition, whether it's commercial or national or international, is really based on beyond that line. And I'm very honored by that Dr. Daniels decided to name it after me, and it really should be called the Daniels Warden Line, I think. Just like the argument of the where's the line at space, the von Neumann line. I think that that's roughly 100 kilometers, so 100,000 kilometers is a good place to begin to, and that's clearly, and I think many of the discussants here, that's where our strategic competition is, for economic competition. That's where our future is. So, I'm happy to have my name attached to it, but in truth, the mathematical definition of that is really Matt Daniels' responsibility and invention.
Terrific. Thank you very much, sir. Always fascinating to talk to you. I learned so much whenever you're around. We are going to close out the day. We're going to close out the event. Dr. Warden, if you're available, Major McLean has some pretty interesting stuff tomorrow. If you want to join, the link that you have now will get you back.
Sure, I'll try to get into that. And again, thanks, Farrell. I mean, this community is really moving the United States and the world forward in our unlimited future.
It really is. He'll be speaking at 3:15 approximately tomorrow, East Coast time.
Right.
Terrific.
Thanks.
Thank you, sir. All right, that kind of wraps up our first day. I want to thank all of our tremendous guests. Oh, hey, in case anybody's curious, Dr. Warden's icon there, he's actually been knighted. I know that that's not the entirely correct term, but he's been knighted by the Principality of Luxembourg. So that's his get up for his knighting, which I thought was kind of fascinating. All right, so tomorrow we are looking at a great day. We're going to talk a lot about the moon-based competition. Sorry, I'm looking this screen because that's where my notes are. We're going to talk a lot about the moon-based competition. We've got 6 of the competitors. I think there were 14 originally, so we've got the winners and the second place folks, but then also some other really terrific designs by other competitors. I think it's fascinating. I mean, it really describes just how complicated this stuff of going to the moon is. It's really, really hard. So hats off to all the competitors. After that, we're going to talk about hardware in a lot of different ways. Hardware about building settlements, hardware talking about environmental controls and life support systems. Frankly, y'all, keeping things alive on the moon is really, really shockingly hard. And we're going to be honored to have an expert on that. Professor Thengvalu, who's been with us all day, thank you for being with us today. He is going to give his presentation tomorrow, also on more habitats. Dr. Jewell is going to come in and talk about analog sites and how useful, how important they are. Sam Jimenez also has a background in analog sites, but he's going to specifically be talking about dust mitigation and building spaceports. I just mentioned a moment ago, Sean McLean. There's a question mark whether or not he's going to be in uniform. I believe he is not going to be in uniform. They did not get that cleared by the Public Affairs Office. But still, Major McLean, active officer for Space Force. He's one of the first 2,000 officers that joined Space Force. So he's in a very unique place in history. And then I'll talk for a little while about lunar elevators, and Michael Mealy is going to talk about, you've heard the phrase a couple times now, Starship singularity. You know, what does that mean? What does that really mean? Are things going to change? I think they are, but what and how? And so he's going to be talking about, from his perspective as an investor, that's one of the first questions he asks. And then we'll wrap up the day with a call in from Australia. Joshua Lecter is going to talk about his program over there. And Michelle Hanlon's going to talk about her moon registry, her moon artifacts registry. Finally, Manny is going to talk about another settlement, and Pete Garrettson is going to finalize, take us home for the day, talking about the last conversation we had with Dr. Warden about the cislunar environment and just how challenging it is to operate there. So thanks everybody for being here. We're going to stick around for a little while. We'd love to have, I've got a correction here. Manny's going to be talking about a VR program, his virtual moon program, which I interpreted as habitats, but it's not. So, we're going to, if anybody would like to stick around, if anybody would like to chat a little bit, we'd love to get any feedback. There's a little bit of time for social conversations. I know that Ben and James and Michael Mealing would like to kind of get some interaction with the community that joined us today. So we're going to keep this line open. We are going to close the recording. So Fabio, if you could turn that off, that would be great. Thanks, everybody. I'm going to stick around for a little while and just chat with folks. Anybody, the mics are open. If people want to start chatting, feel free to start doing that. All right. Thanks.
Hello, Mike.